Good morning, Columbus. It's great to see so many folks here early in the morning. I know it's, I don't know, that maybe a little bit too early, but we do have coffee outside. So that'll be up until 10 o'clock, so feel free to partake there. We want to appreciate you all coming out, and also the folks that are watching us on the YouTube stream as well. Just a reminder for those folks, and actually you here as well, when you signed up for your ticket, you did get a link to invite you to our Slack, and you can go on there and chat with folks. And if you want to have questions for the speaker, and you're not here, or you're too shy to speak up, you can ask them in the main stage channel, and those will be relayed to the speakers. What else do we have? This is our 20th annual event. It's hard to believe, but this is going to be our second hybrid event, and we're looking forward to having a great combination of folks here in person and also joining us online. Without any further ceremony, I want to introduce our first speaker, Jonathan Bowman. We have a long history of folks involved with Python here in Ohio and involved with OLF. So it's really fitting that our first talk for this year is going to focus on Python. So Jonathan, please come on, take it away.
Thank you, Vance. I was trying to figure out what it means that I'm the first presentation. I'm choosing to believe that I am your warm cup of coffee this morning. I'm Jonathan Bowman. I am a hobbyist developer first and foremost. That I've been a teacher, a preacher, an IT director, web developer, consultant, and now I am a software engineer, moving data, writing SQL all day long, and Python when I need to. But my computer history started in 1982 when my family got a Commodore 64 for Christmas. Yeah, oh man, so glad there's some fans. My parents only bought us 2 games, and they were educational games. So we kids, not having a budget, were left with this blinking light blue cursor and the basic version 2.0 programming language from Commodore, which was perfect. The computer became a place to experiment, to build things, tear them down again, sometimes destroy things, and then build again. It was an entire world to explore. Sorry, one moment there. There we go. So I find the Python REPL to be somewhat similar. That's the read, evaluate, print loop, or if you're just like me, you call it the Python prompt. It's approachable, it's powerful, it is available. It is a place to experiment, to tear down, to build again after you accidentally or intentionally destroy things. I didn't go straight from the Commodore to Python. There was a large span in there, and the path to get there was through Linux and open source. No production file systems were harmed in the making of this presentation. So from the Commodore in the 1980s, fast forward to 1999, I was finishing my bachelor's degree so I could become an English teacher, and I heard about Linux. Discovering Linux and open source was like cresting a hill and seeing this vast landscape open before me with certain key features highlighted along the way. Information that was freely available was so inviting, and the tools that were attainable and free were also very inviting. This is the view from Old Rag, a mountain in Central Virginia. If you are into hiking and you're ever in the area, I highly recommend it. The wildlife may or may not look like that. So I became a middle and high school teacher, and bringing with me that rekindled interest that I just rediscovered technology, building digital things. And ever since then, I have continued to develop and build on my own, building and tearing down my own machines, home lab projects. But I also quickly found that this vast landscape of open source it provided natural resources for helping others. And that was something I was enthusiastic about. I evolved into being an IT technician in the school where I was teaching. I thrived on responding to others' needs and trying to engage their questions, being able to point them to freely available tools or to use freely available tools, open source tools, to help them, configuring servers or desktops, web pages to support the adventures that my coworkers and my students were on. I suspect I am not the only one in the room who is motivated by the desire to help others. I'm probably also not the only person in the room who has found that when you're helping others, you're often hindered by tasks that are taking too much time, or are hard to remember, or are prone to human error. So then there's a desire for automation, and that's where it stems from, to improve efficiency, to improve repeatability, to improve reliability. All of these are quite desirable with Linux system administration, or configuring Linux systems, whether that system is your Ubuntu laptop or an OpenWRT router or a data center that you're managing with hundreds of RHEL instances, or your Arch Linux-based home lab. I'm sure I left someone's favorite distro out of that list. Grant me some grace. And automation is even helpful with other platforms, Mac, the BSDs, even Windows, and it's very pleasurable to, if you have to manage those things, to do so from the flexibility of a Linux environment. So when considering system automation in the open source world, I immediately think of two classes of tools. And I think they're represented well by Bash on the one hand and Ansible on the other. Again, trying not to leave people out. There's in those classes, any shell that is programmable. You can think of Bash as a placeholder for that whenever I use Bash in this presentation. And then, of course, Ansible has its friends Salt, Chef, and Puppet. I presume there's other ones, but those are the big four configuration management suites. Both Bash and Ansible can automate tedious tasks. Ansible, I think, is more readable and more shareable. A Bash script has less guardrails, more flexibility, and is useful for more than just configuration management. Any sort of one-off tools can easily be made with Bash. I think Python, just itself, the language, I know Ansible and Salt are written in Python, but I'm talking about Python just using it by itself. Python occupies a middle place between these two. It can be used to do anything Ansible does. Ansible is just Python under the hood. And it can pretty much do anything Bash does, but unlike either of these, it's a general purpose programming language with a multifaceted ecosystem. And I know old timers in the room are like, you're saying Perl with a strange pronunciation. Now, none of these are the right tool for every job, right? There are always going to be things like a simple one-off script where I'm just trying to remember all the flags for FFmpeg or whatever command that has umpteen switches. Yeah, just make a bash script. At the same time, and I am guilty of this, it's sort of hideous, it's hideously cruel to leave a pile of Python scripts for your successor to manage a whole data center or something like that. Ansible or something like it is going to be a lot more readable due to its self-commenting and its readability. So not everything is going to fit. Python isn't necessarily going to fit every role, or maybe something else entirely. But when would you use Python? I turn to Python when my bash scripts are getting too large or complicated. Turn to Python when I need to process complex string or array or other kinds of complex data. Sometimes the target machine lacks the required commands, or I can't trust that the grep, the cut, the whatever command that Bash is really a glue language, right? It's gluing those tools together. I can't trust that I know what version of those commands are going to be on the target machine. Or sometimes my Ansible scripts are just, I get too impatient waiting for them to complete. And I can think of some ways to streamline that with Python. Sometimes I'm writing something that I actually want to be used not just on Linux. Python is a good choice for that. And honestly, I'll use Python because it's something I'm already familiar with or want to get more familiar with, and so it becomes this, again, Swiss Army knife, multi-tool, whatever you want to call it, to serve a variety of needs. You can find my GitHub repo, and the slides here are available at olf22.bowmanjd.com. You can go there and follow along and click on any of these links. This is going to move really fast, so honestly, if it's worth anything, it's probably the links that I'm containing in there, so feel free to get distracted while I'm presenting. And also, keep in mind, Python works great with Bash and great with Ansible, so this isn't an either-or choice. So why Python as opposed to other languages? It's, I don't know, use whatever languages you want. Use them all. Many scripting languages exist that fill this space. Perl, of course, is the old standby. I will admit that my Perl scripts, when I look at them a year later, I don't know what I was doing. But when I read my Python scripts, I can tell. So that's me. Maybe it's a personal fallacy there. But Ruby, JavaScript even could be used. Lua is probably worth learning. So I mean, there's any scripting language that could fill this space. If you find something that works as well as Python, excellent. But if you're weighing the options, here's a couple things to consider. I was reading the GitHub README project where it sort of bios of various developers, and I found Lorena Misa's bio kind of compelling. She's an engineer at GitHub. She was former chair of the Python Software Foundation. One of the things she just says is the Python space, it's beautiful, it's great, and it's big. I'll go into some of those a little bit here. And she quotes Brett Cannon, who is a well-regarded Python dev. He says, "I came for the language, I stay for the community." That's true in a lot of open source communities. So it's a great language, but really what makes it are the people, the tools, the ecosystem around it. Also famously, Python is known as batteries included. The standard library of Python has so much stuff in it that they're actively trying to weed out some of it. You know, some of the stuff that no one ever uses anymore, they're actually trying to prune a little bit. It's huge. It contains most of what you need. And then, of course, there is an ecosystem around it if you do want third-party packages. I will admit, in this presentation, I'm trying to err on the side of just using a standard library, although hopefully I'm giving you some tips on third-party tools that you might want to explore. All right, so if you're getting started with Python or just wanting to brush up, there's some great tools, and the ones I'm listing here, I believe, are all free. The book, Automate the Boring Stuff with Python, you can get a paper version, but it's also available in HTML online for free. Again, if you have the presentation, you can just click on these and it'll take you right there. It's again, the idea here is I turn to Python when I need to automate something. This gives several examples of things you could automate. Django Girls is a phenomenal organization. If you know a girl and you have a Django Girls near you, I've not experienced it, but from what I read, it's a phenomenal thing. But they also have a tutorial online that is one of the best written introductions to Python and to Django. But even if you're not into web development, Django is a web development framework. The tutorial is a phenomenal one. The Python docs themselves are excellent, a great reference. There's an awesome Python list I love to look at just to see all of these external libraries that could be used for this, that, and the other thing. And then from the Python REPL itself, you can just type help, and it, of all things, will give you some help. I'm going to do a quick run through of some introductory Python things here. To install Python, it can be confusing. And this XKCD comic is true, but it doesn't have to be confusing. So let's talk about just trying to make it as simple as possible. If you aren't if you aren't sure, just go to python.org/downloads, and you can find the Python for your system and go from there. If you're on Linux and you're used to using a package manager, you know, the Debian Ubuntu crowd do the apt install Python 3. Notice they are usually called Python 3, even though most modern distros don't have Python 2 anymore. It's a historical thing. I gave Fedora, Debian, Ubuntu here, but you can probably figure out your package manager. If you are familiar with Docker, just want to run it in a container using Docker or Podman. I like the Alpine one because it's a nice lightweight container with the latest Python in it. You can even do it on your phone. Mac, if you're on a Mac and you have Brew, you could just use that, but using the downloads is also a great one. Windows, there's so many options. I find Scoop. Scoop is the gateway drug I try to get people into open source if you're using Windows. Like, get started with Scoop. Oh, you can just install grep real easily. You can install sed really easily, and you can install Python really easily. But honestly, if someone was like, I want to install Python on Windows, I would direct them to the downloads page first. Unless I'm wanting to just introduce them to open source as a whole, then I might go the Scoop route or Chocolatey or something like that. On Linux, the Python executable is usually called Python 3, not Python. It depends on your distro. But on sort of some of these distros, it's an easy, there's several different ways. If you're tired of typing Python 3, because that is a whole extra character to type, you can, I mean, on Debian, I'm sure you could do your update alternatives, but you can also just install Python as Python 3. On Fedora, it's called Python on version command, or of course, you can alias in your shell and just make Python equal Python 3. Surely this need will go away the further we get from Python 2, where Python will just be. If you don't want to do it on your terminal, and I would encourage you, if you have a laptop in front of you or phone or whatever, to follow along here. We're going to be dabbling a little bit of code. You can also find the REPL on the web. There's a variety. Python Anywhere is run by Anaconda. Python.org has its own shell, but under the hood, it's Anaconda's Python Anywhere. Of course, GitHub Codespaces with its own VS Code Online. I love Replit, or however, Replit. Great way to start programming or teaching programming. Pysa.cloud or Amazon's Cloud9. These are just some examples of how you can execute Python online. The space is actually getting interesting now that people have compiled the Python interpreter to run in WebAssembly, but that's a whole nother topic that we won't go on here. Python does have its own packaging ecosystem around it, and typically that is installed with the command pip. If you don't have pip, there's a chance you might have Python space -m space pip, and that'll work the same. Or some distros, I have no idea why they do this, but you have to install Python pip separately. It might be, the package might be called Python 3-pip or something like that, depending on your distro. But you can install one package. Here I'm giving an example of Request, which is a wildly popular HTTP client. But you can also install a whole bunch at one time. So that's the gist of pip install. There are things that the XKCD comic was referring to called virtual environments. Highly encouraged, although you can end up with a lot of virtual environments. You need to practice some organization there. But you simply create a directory within your project directory, and then it installs and symlinks a Python there. The nice thing is you can install all you want and then realize you've just really created a messy system, and then just delete the directory and start over again. So it creates a wonderful sandbox for playing around. You create a directory and activate it. Of course, Docker and containers could be used for the same purpose if you're more familiar with that way of going about it. For editors, the editor you're already using probably is fluent in Python or could be with the right extension. If you're not sure what editor to use, probably VS Code's a good place to start. I'm a Vim user myself, and Python works great on Vim, as well as a lot of the other common ones, even something new like Helix or something that doesn't exist yet like Zed. If you are ever working with especially younger people and want to introduce Python, the IDEs Thani and Mu are really interesting in that space, or not even young people, but just they're IDEs for Python beginners. So if in doubt, use what you're already familiar with, or use VS Code. I do have a companion GitHub repo that has some code snippets in it in the examples directory if you're interested in that kind of thing. So feel free to browse there if you like and check it out. And the pretty simple snippets, and we're going to run through them very fast right now. So this is just a whirlwind introduction to Python. Might be review for some of you, might be new. Feel free to queue up your questions for Q&A at the end. Def defines a function. This function here is named greet and takes one argument that is assigned to the variable greeting. And then return is the keyword used to specify the return value of the function. So similar to a lot of other languages. White space in Python matters. The indents aren't just for pretty. So make sure you do indent when you have a code block like that. Also note one way here to do string concatenation using the plus operator to concatenate a variable with a string, something that's fairly common. Default arguments can also be specified. Here, if no one specifies greeting, it will default to hello, so I can actually call the function without giving it a parameter, giving a value, and this one would result in saying hello. You can also name your arguments. So if you notice, I can call this function using positional arguments, where it'll say salutations galaxy. But I could also skip the first argument and just name the second, as I do in this second example, saying audience equals galaxy. So arguments can be named if, we can use names. They don't just have to be positional. Also note the cooler way to use variables in strings, somewhat new since Python 3.7, or maybe it was 3.6. The F string allows you to prefix a string with F, and then in braces, you can interpolate your variables. It's just syntactic convenience. Python, like other languages, does have types. You don't have to declare them in advance. It will infer them. So we have integers, got floats, and you would really just assign them in this way. Strings. Python has a concept called a range that is useful for counting, for iteration. So a range 10 is actually the numbers 0 through 9, excuse me. Python strings are Unicode by default, UTF-8 by default, usually, probably on your system. But there's also bytes, which does surprisingly come up when you're shell scripting with Python. Say, for instance, if you were trying to automate something around OpenSSL or GPG or something like that, that you actually care about the output being bytes. Python has lists. That is not JSON. I know it looks like it. And they can be mixed. They don't all have to be the same type. And then you can call a member of the list just with the brackets there. So here, given this list, we are calling the fifth item, since it's zero-based numbering, and that would, of course, refer to 1, which is the loneliest number. There's also Boolean, and note the Booleans, true or false, are capitalized, the first letter. The dict is perhaps one of the most important types used in Python. Call it what you want, a hash type, a mapping. Depending on what language you're coming from, you might think of it as an associative array. It's named values. So in this case, have a dict where I have several things, and then I'm pulling one out, calling it by name, in this case pi, to assign it to the variable Archimedes constant. There's a variety of ways to compare, and in this function here, I'm kind of demonstrating numerical comparison, but it also works with not just numbers. Excuse me. There's equality. You can use the not keyword to negate. You don't need to use a bang. That's other languages. You can just use the not. It's a little more Englishy. But you could also do does not equal, as you see an example there, greater than, less than, or equal to. You'll also see in some future code here in this presentation the use of the word in to tell if text is in another string, if it's inclusive. Loops, and here's some examples. So here, loops in Python are always looping through some sort of iterable or collection. So it's not just for I equals 1 to 10. It's you first supply the collection, which might be the range. But in this case, I used the OS module that's built in, took the environment, the keys to that environment are all the currently set environmental variables in your system. And so in this case, that first loop just iterates through every environmental variable you currently have set that your Python instance has access to. The next one is similar. We're just iterating through using a for loop for the variable I'm assigning it to in the collection. In this case, I took the environmental variable path, split it by colons so you can get each chunk of the path, and I'm just iterating through that. If you just want to count, that's where a range can come in. If you just want to count, if you just want to do something a certain number of times, and you don't, okay, one way that's often done in Python is we'll just use the underscore variable. It's still a variable, it's just everyone knows it's a throwaway variable that no one cares about. I'm not actually using the variable. So shell scripting in the standard library, just a quick run through. We've got the subprocess module, which I'll describe in a little more detail. That's the heart and soul of it. We got a pathlib module, which is a little more of part of what I'm doing here is if you Google on how to use Python, there's lots of search results such as W3 Schools that understand SEO more than they understand technical competence and modernity. And so what you'll find might be out of date. Pathlib is an excellent example of that. That's a more modern way in Python of managing file system manipulation, reading and writing files that I highly recommend. shutil for copying, it's doing some additional file, more shell-like file manipulation. Shlex for parsing shell arguments in a fairly safe way. Re, I'm not actually talking about re much here, but regular expressions. For me, one of the draws of using Python is, as I mentioned earlier, I know exactly what regular expression engine is going to be in use because Python is always using the same regular expression engine. I don't have to guess what version of grep or sed or whatever is being used. fnmatch can do shell globbing, that kind of thing. argparse we'll talk about a little bit for using for parsing command line arguments, and os and sys are just these huge modules that have a whole lot of things that are useful in them. There's also data. I mean, Python's great with data. In the standard library itself, you can manipulate CSVs, handle JSON. You can use XML, although there is a third-party XML library. I would recommend that if you're bringing in any kind of user input because it defuses XML bombs. SQLite is built into Python, and so you can do a lot of data manipulation that way. There's also a built-in HTTP client. The heart of shell scripting in Python, heart and soul, is subprocess. And in subprocess, there is one command that can do it all, and that is subprocess run. And here's an example of calling the IP command just to get the IP address and some network adapter information. I'm telling subprocess run that I want to capture the output, which allows me to assign it to the variable result. And I'm telling it that instead of giving me that result in bytes, give it to me as text, as Unicode text. That's what I'm saying, text is true. Checks for the return code, and then passes back the standard out from that command. So here you've captured standard out. You can do all kinds of things with it. Note the way we do commands in this, the recommended way is that you pass in a list, pass in the list where the first item in the list is the command you want to run and subsequent items are the arguments towards that command. There is another way called shell mode, and this would be useful, say, if you could actually use Python to execute a shell script, where and that will expand environmental variables and do tilde expansion for your home directory, but it's not safe. If for any reason you're collecting, say if you're making a web app that collects allows the user to input a shell command, I don't know why you would do that, but let's just say you were, don't use this format, because if they happily put --rm-rf/ on the end, this will happily execute that, while the other way cleans it up first. There's shortcuts though. I said subprocess run is sort of the do everything, but I often like to type less, so check output will just assume you want to capture the output, so I don't need to tell it to do so, and then I don't need to call standard out, pull out standard out particularly. And then if I don't need the output, check call is even simpler. So if all I wanted to do was see the result of a command, it's this simple. Subprocess.checkCall. Summary of everything subprocess. Subprocess run for anything and everything. Subprocess check output for a convenient way to capture the output of that command. Subprocess check call if the execution is all that is needed. Use shell equals true if you want to do shell, but it's more advisable to do the list of command and parameters, but the command would be the first one. Of course, if you're using Python to manage, you probably are also thinking about managing perhaps remote systems. There is an external library for Python. It's not in the standard library, called Paramiko, that works great for SSHing. Here's an example of using it. It's a little involved, but not too bad. It doesn't, in my experience, read my SSH config as conveniently as I would like it to. Just admitting that. It's possible, but especially if your SSH configs get complex, it might not know how to handle them, but you have to do extra work to get it to read that. So in this case, I actually do have a server in my SSH config named server, so this would work. I'm that creative. But there's other ways of doing SSH. So there is a third party. If you are serious about using Python with shell scripting, there's a library I'm starting to fall in love with called Plumbum, which makes shell scripting almost as easy as you can tell, Python's fairly verbose. This makes it almost as terse as bash. In this case, you can see from Plumbum command import IP, but in whatever, you can put anything you want there that's in your path. So you could do import ls, you could do import whatever, and then you just call it with the parameters, and there you go. So it's much more succinct, and Plumbum itself just does a lot of different things. It also can SSH, so you can just import SSH machine, and then in this one, it's using the actual OpenSSH client under the hood, so it'll respect everything you have in SSH config, all your hosts, all that kind of thing. So Plumbum's worth exploring. Other SSH options, if you're familiar with concurrent programming with an async await kind of syntax, maybe you come from JavaScript, TypeScript, or other languages like that, or you know how to do async, you're comfortable with async await in Python, consider async SSH. It's a pretty sweet library. Another library that's useful is called Fabric. It's built on Paramiko, and so it has that functionality. I feel like it parses SSH config a lot more conveniently and automatically. It's also like Fabric is, if you ever find yourself, you like Ansible scripts or name your similar, but why do I have to learn a domain-specific language? Why can't I just write it all in Python? Fabric's your friend there. But also, if Python's already on your server, you don't necessarily need to think about doing SSH in Python itself. You could just do what I'm doing in the third line here, where I am piping a Python script into my SSH and calling the Python executable from there, if that makes sense. I'm taking a script I have locally and just passing it straight to the server, trusting that the Python there will be able to run this. So that's another way of SSHing. File reading and manipulation, I like to use pathlib. Here at the top, you'll notice I'm not just importing pathlib, I'm cheating again to be lazy. I'm importing a part of pathlib called path into the global namespace, so I don't have to type pathlib.path every time, I can just type path. So here, I'm naming the file, it's etc os release. Then it's this simple, I'm just reading all the text, one fell swoop. And then I'm just checking what's in this. I'm using this in operator. I'm like, if it's, I'm gonna check if it has Fedora in it, then respond appropriately. If it has Alpine in it, then respond appropriately. Same with Arch Linux, and name your favorite distro there. Also showing in the last line, my favorite way of line length is important. I like readability, and so strings that are 200 characters long are anathema to me, so this is my favorite way of breaking a single string into multiple lines, but the interpreter will still see it all as one piece. Just put it in parentheses and then use as many chunks of strings as you want. You can also read line by line, which is important if you're dealing with a huge file. Rather than loading it all into memory, let's just parse through line by line. So this one's doing the same thing with the same file. This is using a with operator to create a context. What a context handler is in Python is a lazy, you can see the theme here is lazy, is a lazy way of opening something and trusting that it'll close when it needs to without me actually closing it. So I'm saying with opening this file, now I'm going to go through line by line for line in the file handle. Hey, if it starts with pretty name, print it out. So if you run that on Linux, you will get a line that says what your distro is. This is far more involved, but I just want to example. Schlex is a built-in way of safely parsing shell-like syntax, so that would actually work on the OS release file, since all it is just variables being assigned. And so in that case, this would be a way, if I'm wanting to say look at a server and tell what the distro is, this would be a way to do that. You can also write text to a file. It's pretty much just as easy as reading it. And here I'm just writing to the message of the day. So processing command line arguments, you may find that you want to write a one-off script that takes arguments. The inflexible but very, very simple way is to import sys, import argv, where you end up with a list of all the arguments that were passed on the command line. So here's an example where I've written a very useful script to simply take text and write it to the message of the day. Notice I do have to use sudo because it's etsy message of the day. And you can just execute it with calling Python, calling my script, and then calling the argument. You'll see at the end there where I basically take sys.argv, the oneth, that's not the first because this is zero-based list, the oneth, which is the second argument. The first argument is the command name itself. The second one is the one you care about. And whatever that argument is, it just writes it to etsy message of the day. So Python, when you write a Python script, by default, it just wants to be a library. It just wants to be imported, and then you can use all the functions in it. If you also want to execute it as a script, you do need to put this little funny nomenclature at the end called if name. In other words, if the name of this module is main, in other words, you're just executing this as a script, then do something. That's why you're going to see anything that I'm using as a script to be executed from the command line is going to have that if name equals main nomenclature. It's necessary. It's Python. Yeah, I don't know whether to apologize for it or not, but that always is going to have to be there if you want to just execute something as a script, and then you can put in there what function you want to call with what parameters. Typing Python 3 before a command is, of course, way too much typing, so put that shebang line at the beginning, make your script schmod it, add the executable bit to the script, and then you don't have to type Python 3. You can just call the script directly, and it works the same way. A more flexible way to parse arguments, though, with built-in help and all that, is the built-in module called argparse. Here, again, very similar thing we're doing, but I'm parsing the argument. I'm assigning, I'm naming the argument. I'm saying this is going to be called message. This one will be a required argument, so it'll complain if I don't pass in the argument. It offers a help message, so that if I type the Python script with a -h or a --help, it's going to give me the help as you'd expect from any command line tool. That, of course, is not good enough for most Pythonistas, and so there are all sorts of external libraries that can be used. By far and away, I think the most popular one is called Click. Just makes writing command line Python command line tools easy. Typer is the new hotness. Fire is from Google, and it's probably like the easiest way. You just write normal Python, and then at the end you call one command, and it turns your functions into commands. And then Plumbum, which I introduced earlier, is also able to handle CLI libraries. So if you're exploring that library, maybe just use that for your command line parsing. If you are writing command line tools in Python and you just want them to be gloriously beautiful, colorized, laid out, Rich is the de facto external library to do that, so you can pip install Rich. The same people are making something called Textual that basically is, I don't know how else to describe it. I mean, they have things like CSS for the terminal, so you can just totally style your terminal in some phenomenal ways. Temporary files are something we often have to deal with when we're manipulating a shell, manipulating a system. In this case, I'm just showing the paradigm of, here I'm doing the same thing. I'm modifying etsy message of the day, but this time, instead of modifying it directly, I'm modifying a temporary file to get it just the way I want, and then doing a quick swap, and then cleaning up my temporary files at the end. That way, I'm also having the sudo built into the script, and so I can just execute the script, and it'll prompt me for my sudo password when I want You don't have to do it that way, but that's the demonstration here using check call, passing sudo in first, and then a copy. There's a broad and deep Python ecosystem around data manipulation. Here are some helpers that are built in. You can write JSON. You can take that line 3 there, looks like JSON, but that's actually a Python dict, and it's trivial with the JSON module to dump it to a string. Dumps is dump string. The indent there is totally optional. I just wanted it to look pretty. And then you can print that out as JSON. You can also read, you can deserialize JSON. Here's an example of where my Docker service config, which is a JSON file, I'm able to read that, and then I can do all sorts of processing with it because built-in Python can read JSON. CSV, here is a sample CSV. This is also the requisite reference to the Monty Python comedy troupe that's always necessary when explaining Python, for which it is named. Other way around. Python is named for the Monty Python comedy troupe. I wish it was the other way around. But you can import the CSV module, and then, again, similar to, you open the file, but instead of iterating it over line by line, you actually pass it to the CSV reader, and then you can pull out your data and do with it what you want. People don't often know, but I find it super helpful. If someone ever gives you a CSV file and that you need to parse, they think the next time they give it to you, they're giving you the same file, but they've changed the columns and they've rearranged them. It happens all the time. And if you use the dict reader, you can you can turn each row into named value pairs to make it easy to call and a little more resilient to well-meaning clients. Writing CSV is very similar to reading it. Again, you open the file using tactics we've already showed, and then you can write a list of values as a row, and it'll take care of doing all the formatting, escaping, quoting where necessary, all that kind of thing. Web requests are a fun thing, an off thing. If you're managing a system, sometimes you need data from outside. I mentioned, well, and I will mention again, there's some external libraries that are good for that, but built into Python is an excellent library for doing web requests. So here's an example. If you desire to see the weather in your terminal, this is one way to do it. We're just going to use urllib request. Conveniently but horribly, urllib request, the URL open function, is made to handle not just HTTP and HTTPS URLs, but even file URLs. So if in your infinite wisdom, you are designing, say, a web application where you're taking arbitrary user input of URLs, you probably want to check to make sure they didn't put file : / etc password or something like that so that they can find what users you have on your system or something like that. So do sanitize the inputs to this, but it is really as simple as giving it a URL, getting a response. That response is binary, so we decode it so it becomes UTF-8. You can also post some JSON using similar, again, that data variable there looks like JSON already, but it's actually a Python dict. And then we encode that to JSON. We make sure that in our headers we're telling it, hey, we're expecting JSON back. And then we're posting the request, making sure that we say what the method is, putting the data as post data, and then that will work. And sorry, I ran off the last line there, perhaps. JSON placeholder simulates a post. It's not, you're not actually wrecking someone's server, but it is a great way. JSON placeholder.typecode.com is a great way to test out some web APIs without actually affecting any data. There are other third-party libraries for the web. There's requests, very popular. My favorite one is HTTPX. It also supports async await syntax, but has a very similar syntax to requests. Beautiful Soup is used for parsing HTML, and it's a very liberal parser. So if you're doing web scraping where you're trying to get values from an HTML page because there's no API, Beautiful Soup can be your friend. Scrapey is a tool that I think is built on Beautiful Soup that is also useful for web scraping. There's other data avenues to explore. I already mentioned SQLite. I already mentioned XML. SQL Alchemy is a third-party library that is very mature and can interface with any SQL database out there, and just has some phenomenal things. Pandas and NumPy are familiar to Datanauts. Pandas, I think of it as like, if you want to programmatically treat your data like a spreadsheet and do so much more, you might want to explore Pandas. I'm just going to throw a whole bunch of links at you to finish out the presentation in case you're one of the people that might be interested in these. If you're a network engineer, these are the Python libraries to explore. NetMiko can manage network switches, Napalm for doing all kinds of network automation. All of those are included in this big giant thing called Nornir, which, like Fabric, is another way to have something like Ansible, but you're actually using Python, full power Python, not just a domain-specific language. And the people who make this also have a free Python network automation course that you can explore. If you manage hypervisors, they're, for the most part, your cloud provider or hypervisor probably has a Python SDK. Here's a list of some of them. If you have to manage Hyper-V, the API for Hyper-V is PowerShell, and Python can interface with PowerShell pretty well as well. If you do container management, there's a Docker module, there's a Podman module, although you actually have to be using the Podman socket for that to work. There's a Kubernetes module that you can explore. Thank you. Questions? Are we good, Vance?
Yeah, thank you so
Okay.
much.
Yeah.
Yeah, if anybody here has questions, I'll run around and bring the mic to you. I don't see any on Slack at the moment, but for folks who are watching on YouTube, or if you're here, you can join the main stage channel and ask questions there as well. So, do we have anybody who has a question?
Hi.
Well, first of all, thank you for the presentation. That was like a speed reading.
It's
something.
speedy, yeah, just it's a fire hose, my apologies.
So my question is, when you are running commands
Mm-hmm.
and you are capturing the output of the command, is there any limit like to which you can capture and after that it would be discarded? Like if the command gives
Yeah, that's a
2
good,
megabytes of data.
that's a good question. I might want to research that further. In my experience, the limit is imposed by the memory constraints of your system. And if that's not respected, you can do some embarrassing things. Yeah, as with any, whether it's not just, that's not Python specific, but yeah, I have yet to encounter such limits, but that might be worth some research. Good question.
All right, anybody else here? There you go. And I'll just real quickly ask, while I'm walking over here, if our next speaker would start getting up here. Thanks.
Good presentation. I just wanted to wonder what your thoughts are on PyScript.
Yeah, I mean, that's what I was referring to. That PyScript is compiling the Python interpreter to WebAssembly using Emscripten, I believe. And so where it's most interesting to me right now, even though I'm not a VS Code user, is the online version of VS Code has an experimental extension where it is actually executing Python using a Python interpreter that has been compiled to WebAssembly. So that's fascinating. It feels, I don't know, I'm not using it yet, but I certainly think it's cool. Yeah. Okay. Yeah. Yeah. I mean, if you want to write Python instead of JavaScript, go for it.
All right, any other, oh, there we go.
So I'm coming from Bash scripting, and I've been doing a lot of like string manipulation or text manipulation with sed and awk.
Yeah.
Is there? I'm assuming there's similar functions that it can do that in Python.
Yeah, I mean, okay, I'll confess, probably the reason I turned to Python is because I haven't yet mastered awk, which is like the de facto, string manipulation. Because Python does string manipulation so well. I mean, you can split things by a certain token, you can join things with a certain token, you can use regex, a consistent regex engine to parse it, split it, whatever you want. Goodness, that's the main things I use. If you're thinking of something else, feel free to ask. But yeah, Python's great at string manipulation. That's probably why there are so many Python web frameworks, because all web frameworks is just ways of gluing together letters. That's all they do. So yeah, Python's excellent at that. Yeah, good question.
Oh. Sorry.
Question about virtual environments.
Yeah.
ENVs. however you would pronounce that. Can you speak to how that affects your path?
Yeah.
My understanding of it is that you're able to call anything from the Python environment.
That's right.
How is that getting in and out of the environments?
Yeah, sorry about the microphone there. Jordan's just asked, how does having a Python virtual environment affect your path? So all the Python virtual environment basically creates a bin directory that has either a full Python interpreter or a link to the system Python interpreter, depending on how you configured it, as well as any installed Python command line tools all in that bin. And then when you activate the virtual environment, really what it's doing is adding that bin to the front of your path. And so now when I do a pip install YouTube DL, if that's legal for me to suggest that package, which is a Python package, now YouTube DL is available in my path in that virtual environment. As soon as I deactivate the virtual environment, it's not even there anymore. So again, it's just inserting in the front. In fact, sometimes I'll use a virtual environment instead of calling the activate script, I'll just change my path to point to that bin directory that's inside the, what I usually use the .vnv folder, .vnv/bin, and now that works. Yeah, great question. Shows that you're thinking about how virtual environments work. I think that's my time. Thank you all very much. It was
Thanks,
an honor.
everyone. Thank you. We'll get set up here for a few minutes, and we'll start at 10 o'clock with the next next talk.
Looking at what?
How to connect the machine. I have another session after the next one, so I just want to see what kind of connectors you have.
It's just an HTML. Do you need something different?
No.
Okay. We've got plenty of adapters if we need it. Yes, sir.
Upside down every time.
Did you have any audio?
Nope, just
Okay.
me.
Should be good.
Into the mic. I hope I'm a nice constant level.
You can use this, or if you want to have a clip-on mic, we got those too.
This is. I'll be good standing here. I think this is good. If you think I'll have better audio with a clip-on lav mic, I'll go for that. But like this year, I'll make sure not to touch it for some handling noise.
If you want to move around.
I think this will be good. This will be good.
Okay, that's fine. Cool.
I'll make sure to stand still in one spot.
Yeah, yeah, seems to be working. So, fantastic.
Good stuff. And I will make this bigger and then maybe even while we're waiting for everyone else, to remind them why I'm here. There we go. Cool. And then I will be ready on this window. Yeah, what I did this time differently, and I was just thinking about it as we watched the slides, I was like, I had a bunch of slides 5 years ago, and then like I walk out of the room and they're stuck on my computer forever. And so I just went, all right, this time I'm putting it on GitHub so that, even for someone in the audience, when I've been in the audience, it's kind of nice to be like, okay, on my laptop, can I follow along real time and, actually click that link and all that. So I hope this goes good.
And then we'll post a list with the links to the YouTube video and the slides. So if you want us to, we can post the slide more.
Right. Yeah, this is pretty much, I think like,
Or we can just link to the GitHub as well. That's fine too.
I'll print out the markdown as a PDF and call it good. I think it's probably the answer, just to give it like that, a snapshot in time. You know, because the other advantage of GitHub is, you know, if someone out here is like, you have a typo, they can fix it for you.
Yeah, sure.
All right, cool. Well, I'm excited. I hope I get through it. I hope people get something from it. There we go. Good. I think it is switching. All right. Well, these people have a beautiful face. Back in March, I had to fly to Indiana for a family thing. And a few photos short, but as we walked into church, my mom was like, "You don't have to wear your mask. We're in Indiana." I'm like, "But I was just in Los Angeles." It's already in Los Angeles. I minimize I'm the risk everybody. And Sam, welcome. What can I do to make your life easier today? Stand in one spot? It's just going to be, yeah, no PD. I'm just going to be scrolling through a web page and call it good. My problem with PD, you know, with slides is they get lost on my computer and then no one else has access.
So is the audience going to need to see that, or are you going to?
Yeah, totally. Yeah. Consider this my PowerPoint. Yeah. I'll be scrolling through, skipping through my notes. All right, yeah. Make sure that I'm not going to accidentally start walking left and right. I run a once in a while, Jake's poetry, but like problems I have they're out walking through the crowd. Like, the camera operator's got to stand right there. I know I got good illumination, but it's not like spotlights on here. I don't want to actually see. All right, cool. I don't know what time it is.
Good morning, everyone. Thank you all for coming out. This is probably about your last chance to grab coffee if you haven't up until this point. But I am very interested to have our next speaker. Many of you who work on web servers, and Patrick is going to talk to us about how can we configure Apache to work better. So take it away, Patrick.
All right, cool. All right, hey, thanks everybody. I'm glad you took some time out of your Friday to show up and listen to me. Apache's been a big web server on the internet for a long time, and I have spent the last couple of years really spending, a lot of focus on it. So I have prepared for you guys a repeat of my presentation from 5 years ago, where I was out here and talking about some of my experiences with Apache. So what I have as a presentation, you can go ahead and follow along. Maybe we got it up here. You can see the URL. I've got github.com/ptutor/better-httpd. And this is pretty much my presentation with my notes plus my actual configurations that you might be interested in. And so, for a lot of us today, the internet is a web browser. Your phone, the applications on your phone are doing calls over port 443 to a web server. We're not really, we don't focus on weird things like who is an FTP much anymore. So, there's a lot of alternatives out there besides Apache. You might use Nginx, you might use IIS, you might use HA proxy, you might use Varnish. There's stacks. Use what's best for you. And be mindful whenever you see someone saying some particular web server is faster or better than anything else. They're all really fast, right? We have a lot of, it's very easy to make your own applications slow, right? You can tune a web server to be slow. I hope my screensaver doesn't keep kicking on. This one down here is flashing on me. So my general index of things that I'll be talking about, just some shortcuts that you could do. I really suggest you all read the documentation. There's great stuff in there. Talk a little bit about web browsers so we know what we're all saying, and then Apache's core modules. Some of the stuff I really like in Apache, like macros, translated error messages, how you can have some common files shared across your websites. Maybe you've got a fleet of various subdomains. You want to have some common files shared across them. What are some of the new things that we're always doing with web servers that you weren't doing 10 or 15 years ago? You know, strict transport security headers, cross-origin requests, those types of things. What are some really important things you can do on your websites? You know, mod caching, and then the way that I tend to use Apache most often with proxy passes, balancers, kind of as a load balancer. And so my shortcut to a fast website, if you're going to be using Apache, turn on your cache control header on every object. Make it long, you know, let that web browser hold on to the image in its disk cache or whatever you have. Cache it on the server as well, and then limit your methods. Specifically, things like post can be a cache busting operation. You're always going to go back to the origin, and if you just have your web server say, you know, you're not supposed to be posting index HTML, you can save yourself some operations. If I, you know, go in the other direction, how can I make a slow website? Turn off the cache. Turn off the cache control. You know, every single request from the web browser is going to have to go back to the server. Every single request from the server is going to have to be generated dynamically. It's tough on your CPUs. And be mindful in your cache control header. Sometimes folks will, you know, match private and public, for example. And the most restrictive should get used. But the cache is a good thing for you, right? You're going to be saving yourselves time, you know, in wall clock time when people download a font from your server. You're going to be saving yourself bandwidth costs, etc. So check out the documentation, you know, and that's kind of a boring thing, but if you read the documentation, you're way above someone that didn't. And the nice thing about the Apache documentation, there's a lot of strong examples that they offer to us, and it's updated over and over and over. You'll see the name in there, Rich Bowen. I think he's a Red Hat guy. He's been doing a lot of great stuff there. Specifically at the Apache documentation, there's a reverse proxy guide. If you've got Apache in front of a backend dynamic application or even other web servers, check out the reverse proxy guide. It's going to, and something that, you know, if you are already using this, you may not be using mod remote IP, which is their a built-in way to get your X-forwarded 4 headers out of an upstream connection. Another thing, I dislike rewrite rules in Apache. They confuse me, they look complex, they're hard to read and understand what the guy who wrote them was trying to accomplish. And in Apache 2.4, there's a lot of improvements. And so basically what you want to probably check out is the expressions page in Apache. It's how you can do comparisons. You know, if this variable is true, set this config. And you'll see an example of that right down here. You know, well, I won't skip past this one. This is pretty cool, right? This whole right-hand side of this config option, you might have had a custom log before where, you know, whatever, but here you can actually kind of filter it in the Apache config. If I only want failed requests to show up in this particular access log, that's how. You could use an if, right? You know, if I don't have a particular variable present, or if it is present, take an action. And this would set a header so that in my browser I can see what the server thought was happening. Fallback resource, just an extra note there. Some folks don't know it exists. But when I was talking about rewrite rules, here's a good example for me of an old style rewrite rule that you might turn on and you say, hey, I want to take this path of podcasts and anything, and I want to send it to a different host name where we just append the result of this. And before, a rewrite rule is the way you would go about that. Right now, I would pick a redirect match. It's a lot, you know, it's more clear in the intent to me, right? We're trying to do a redirect. It's not left to, you know, what's this R over here mean? It's pretty much, it looks the same otherwise, but there's an actual command dedicated to this purpose. Another big hint I have for your Apaches is turn off htaccess. And the reason for that is Apache's got to do a stat on a non-existent file in every directory until it gets to the destination. That's inefficient, right? So try turning off HT access. If you are reading somebody's document where they says, you know, put these 3 lines in an HT access file, put that in your Apache config that it reads at startup time. You know, don't add that little config on every single hit. Another detail on new Apache stuff is double check your authentication. Between 2.2 and 2.4, this was I delayed this on my own web server for a little while. I did it at work before I did it for myself. But the way that compatibility, the way that authorization, authentication, those types of things happen changed. And the new syntax says require something. The old style is order. And when I see order, I immediately go, this config needs attention. No one's looked at it in 10 years. Web browsers, you know, if you're doing web stuff, you gotta know what's out there, right? You can't just use Chrome for 100% of the time and then be surprised when somebody says, I get a weird error in Firefox. You know, check your website across different browsers, make sure they work. I've seen weird stuff before. You know, I had a production version of Firefox that gave me a specific error on a specific site. The development version didn't, and I just kind of went, all right, as long as no one else sees this, we're going to wait 2 months and hope it's okay. But being able to compare browsers across different browsers is useful. The big thing for me that I think all you should know about when you're using your desktop client is Command-Option-I. You can open up the inspector. I spend all my time in like the network tab, and if we reload this real quick, you know, we can just kind of see what's happening here. We're fetching a README. We can look at the headers that we got from the FAR server. We can look at, basically we can inspect our conversation. And this is an important part in troubleshooting, close my inspector, in troubleshooting websites. Shouldn't have reloaded. But anyway, so check out the web inspector. If you're dealing with particular types of content like JSON files, some web browsers work better. I like Firefox's way that it renders JSON. Chrome has a copy as curl command, you know, really useful for that type of stuff. If you're doing dynamic websites, you may be interested in a server timing header. It's a way for your application to push values out to the client, and then they just kind of show up in there. I also spend a lot of time when I'm working on websites dealing with what they look like in the command line, right? You know, I showed in the web inspector, we can see our request headers and our response headers, that conversation between your computer and the web server. But sometimes you just kind of want to attack your own website. And here's a simple, you know, a method to go about that, right? Just go fetch a page. You can see here when you're doing command line stuff, if you want to change your method, you can go about that. If you want to inject some values like a cookie, you can do that. If you want to request a compressed response, you know, here's some options on how do you go about that from the command line. wget and curl, you know, another one of, you know, do you want to use Chrome or Firefox? They both work the same, they just have slightly different syntaxes. This is a fun command though. I do a lot of like while true, wget, and sleeps. Just, you know, do I get the same results across multiple replicas across time? I also, you know, gonna remind you all, you know, this thing is a dangerous command, right? If someone was running this against one of my websites, I'd kind of notice and be annoyed. And I mentioned here, there's a very recent federal complaint from 2020. Somebody in my neighborhood, he worked in my neighborhood, right? Totally unrelated otherwise, but he basically just did a simple, you know, for me, it wouldn't even show up in my logs, right? It was such a small counter, but there's a really interesting look at how the FBI, what they consider an attack. And if you're running this against your own websites, you're good to go. As soon as you run that against someone else, don't, right? If they're not paying you to do it, don't do it. So in that conversation I mentioned between like the web server and your client, what are some of the common headers that we get? Like Wikipedia, pretty basic, but they'll give us a cache control, good stuff. Of course, it's private and must revalidate. I was logged in at the time. They're compressed with gzip. They have a strict transport security header. These are all pretty good headers. They have a vary, and that's telling us that, you know, because I was logged in, the content a downstream cache should know that the content may vary based on some other dependent headers. IANA looks a little similar to us. This age header tells us that it's coming from a cache, but we have a cache control header. We've got content encoding. We got a CSP. These are some of the pretty typical headers that you'll see. Sometimes you get an error. In our first line here, we intentionally served a 503. We can tell people, hey, this language, like if you've been using Chrome and it says this web page looks like it's in Chinese, would you like to translate to English? You can influence that a little bit. You know, if you're writing content in French because you're based in Quebec City, or you're writing in Spanish because you're in Mexico City, you can tell people this, you know, the content is in this language. You can nudge the web browser to go in the correct direction. I have this one here because Chrome would always offer to translate this page that's in all the UN languages into Russian or something. So, but Google's, you know, aside, Google's webmaster documentation is incredible. You know, if you have the time to sit there and read through all of it, they'll tell you how to make your website fast because they, you know, they have a strong interest in websites being fast so people see more ads. So Apache Core, there's a lot of configuration items. I'm going to check the time real quick. Good. A lot of configuration items that I'll just leave it there. A lot of configuration items, but the big one that you want to check for in your own configs is making sure you're using the event npm. Historically, it wasn't, right? The default was going to be the slow worker model. This is going to give you threads and speed. You just want to do that. At this point, if you do a Fedora, I think it should be the default. There's some new stuff, right? If you're on bare metal, when I was preparing this, I came across listen cores buckets ratio. I'm not bare metal, but check it out and let me know how it works. Something that matters to me if you're dealing with production websites is how do you deal with restarts of the server? And Apache, if you've done anything old before, you may have, instead of restarting Apache, you may have done a graceful restart. Where's that come from? Well, here's an interesting, you know, what would happen without that, right? If someone's mid-transaction, if they're downloading a PDF over a modem link and you restart your web server, the connection goes away. And their web browser puts up a scary message that says, look, the remote server went away. I don't know, the world is ending. And so to prevent that, just let Apache finish the transaction. And in this case, I tell, you know, instead of an infinite wait, I set it to 10 minutes. If you haven't downloaded in 10 minutes, you know, that's okay, right? Other places, I may have waited 8 hours. We wanted every customer to have a successful response. And how you do that, make sure you send the winch signal. If you happen to have a deployment in Kubernetes, that's how you want to do it. But again, winch signal. And I think, do I have a note here about Nginx? Nginx has a very similar, but it's not winch. So the core stuff, yeah. The defines are a way for me to have feature flags, right? And so when you launch Apache, you might have something like -d foreground, and it's a way to, you know, you might say, all right, I want to define this one as test 1 or test 2, or my example here, primary or secondary. And if that defined value has been set, if that constant basically has been set, change the document root to something else. And this way we can have one Apache config, but multiple instances with different results. Defines are kind of, you know, they're cool if you want to say, you know, if you're adding a new, again, like a feature flag, if you're adding a new feature and you want it to be ready and you can turn it on and off at the process execution time, check that. Some basic stuff I want to go over just in Apache is you've probably come across directories, files, locations, and aliases, and these reference paths in the URL. Some of them, and there is a big difference though, I rarely use directory because it refers to file system locations. And if you're running a real simple static website with, you know, you're serving 3 HTML files, you'll be dealing with directory and file. But if you've got a more complex situation where Apache is there as a load balancer, location is where I tend to spend my time because that's referring to what you see in the URL, right? It's not actually inside of air.html. It could be a synthetic destination on some remote web server. Be mindful of well, regexes, right? I showed an example earlier where my rewrite rules became redirect matches. Generally, everything in 2.4, there's going to be a match statement. So, one moment. merging becomes important here, right? Is it going to be first match or last match? And location is a last match, right? Proxy pass is going to be first match, alias is first match, but location is last match. So I always end up with a structured tree, right? You know, we'll start at the root. What do we want to do? Let's allow all requests. Let's remove some header from a downstream application. But let's say we have a /private URL. Let's just make sure that people are only coming from certain IP addresses. Or maybe we have a forbidden path where we have some files there that we just didn't get around to deleting or whatever. Let's require all denied. A similar way when we're talking about, you know, first match or last match, if you have an a little annoyance for me if you have authentication on the root and then someone fails authentication, you get an error page about you couldn't serve an error page because you couldn't authenticate to the error page. Here's a way to go about that. If you need a valid user on the root, let your error page let anybody get an error. Another, you know, again, just repeating the same stuff. You know, if you want to have an allow methods get on the root, but downstream you have a form somewhere, allow post on that particular path using a location to decrease your baseline security level there. Alias is cool for, you know, just know it's there, right? You have a fake on the left side, a real on the right side. So maybe you have a robots.txt and you want to actually refer it to a different path on your disk. Limits, if you ever run into this, know that it's there. I know it's there because before the current version of Apache, limit request body was unlimited. They've decided 1 gigabyte's a better value, but I decided a much lower value was more appropriate when I had a problem with it. Protocols is a pretty cool thing in Apache in the last 5 years or so. And the main thing here is that when we're going to be strict, a real weird thing about the RFCs on HTTP is that it has a carriage return line feed new ending, which is more Windows style rather than Unix, I guess. So if you're just doing like a telnet into a web server and you hit return, you're not RFC compliant. So this is a real easy way to discard simple scripts that people, you know, somebody did a netcat shell script to attack your site. Well, if they're not sending you carriage return line feed, just throw their connection away. Server tokens, server signature. These are some real basic things for me that you just kind of leak some information if you don't have those in there. If you are running, let's say for some reason you can't launch as root. Apache is really good about launching as root, binding to port 80, then dropping privileges to a lower privileged user. But let's say you're running an OpenShift and your SEC is giving you a random user ID when you launch the process. Maybe you want to be somewhere above 1024 without modifying your capabilities. Change your listen ports. You know, it's a pretty simple change there. And in my OpenShift example, you might want to drop your default, change your default user that you're running under to just assume, you know, whoever launched me, if I launched as user ID 999, that's my user ID until the end of time. So that really covers Apache core. One of my favorite things that's kind of new for me is macros, and, you know, it's a macro, right? The way that I go about using these is I have a website, batrick.shabakta. And here's, I don't know, fake example, but let's say I wanted to listen on both port 80 and port 443. I could create a macro with my common configs, my document root and aliases, proxy pass, whatever, and then apply that configuration to both my clear text port and my TLS port by then appending some extra config. Macros. I kind of, I like them for that flexibility of let me take one basic website that's listening on a common port, but then maybe play around with the options on a different port. Here's another way that I benefit from macros, and that is you might have a proxy pass rule that's really specific on certain paths. Let's say you set up a Django app and you've got 3 routes, view, edit, delete or something. You might list those 3 lines individually, or with a macro, you can just call that macro repeatedly, and our result of calling that macro would look like that. So if you are nesting the macros, be sure you undefine it. You'll get an obvious error if you don't. But don't get too complex, right? Don't have macros nested inside of macros and confuse yourself later. When a web browser is talking to your computer, to your server, we get all kinds of cool things. And so the first one that you kind of know about is the user agent, right? When someone's talking to your computer, they're going to tell you, I'm running Chrome 105 or whatever current version, or they'll tell you, I'm running curl or some other. I'm a big fan of if you have, say, a custom script where you're spidering someone's remote website, put a custom agent in there that identifies your GitHub repo or your email address or a phone number or some way to tell the person that's looking at the logs that you're legitimate, right? You're not just somebody's bot network gone awry. And some of the really cool stuff that you might do here is look for people that don't send you a user agent. That's weird, right? Any human using a normal web browser is going to send you a user agent. And if it's null, you could do something like just punt them away from your web server. They don't need to hit your dynamic website that takes 2 seconds to generate a JSON file if they're not going to read it. And so, for example, contrived examples, right? But if we wanted to do a match on one of the user agents that we found, we could take some actions to either put that inside of an if, or same way we're just kind of doing it over here, a conditional. If that variable is set, take this action. But the other part of user agents is don't trust that it's accurate, right? If somebody says, oh, we're getting attacked by somebody who set their user agent to Ohio, I can't do much with that because as soon as they change their user agent from Ohio to Pennsylvania or Indiana, my block is gone, right? So don't depend on it too much, right? If somebody's coming at you and their user agent says Ohio, block the user agent in Ohio, but they can notice that and fix the problem. You've got to kind of go a step, further. But we also, I mentioned earlier, mod remote IP, very useful if you've got upstream load balancers of any kind that are doing the TCP handshake on that connection before actually returning content. Know that that's there. If you always see, hey, my IP address always shows up as something localhost-ish, watch that. So as I mentioned here, when we're dealing with Apache, we get 3 IP addresses. We've got the peer who is talking to us, which could be an upstream load balancer from a vendor, or we also have like the local address, which is where you kind of bound to something. If you were listening on localhost or if you were listening on a container network or something like that. And we can then use that information to make ACLs in Apache. And this can, so I've got some simple examples here. Maybe we just need a 1918 address space. It's really wide. I've got a documentation example here. But these two are more kind of realish for me. Maybe we want to say, oh, this one IP is being really annoying, and I don't want to just do like a network ACL where they just get dropped. I don't want to do anything like that. I still want to be able to log the connection and give them a response. So here's some methods for going about that, right? Like if someone was in this ACL deny with a 503, I can just go ahead and say, you got a redirect on the route, and I issued you this real brief error message. I don't even want to give you HTML because I already know your trouble. But we also could be a little more polite. If somebody is attacking us and we don't like it, we can give them HTML that says, hey, you are having a problem. You need to call us on the phone, send us an email, whatever. We want you to have access to our public websites, but you're impacting other people. So you can give people custom error messages just for them. Here's maybe some other examples. And the important thing here to note is that when you're using the require syntax, it's first match. So you can do a more specific require all or require any clauses to chain these together and help another administrator understand your intent, but know that it's first match. If I list 2 of these, it's not saying that both have to match. As long as one matches, you can see this path. So another example, this is kind of, I don't need to spend much time on this, but the general idea here is that if we have a path where someone is pushing a cookie to us, we can then put it all together, you know? We can say if we saw a cookie, we can inject a header so that in my web browser, I know, okay, the server saw the cookie and it told me it saw the cookie. This is a way to, you know, just combine those bits together, doing comparisons with Apache expressions. What's some other cool stuff? The browser also sends us an accept language header, right? If someone is based in Mexico City or Quebec City, their operating system, their web browsers, they don't prefer English, right? So a real world example for me, I have a domain, traveltutor.com. I put pictures on there a long time ago, and somebody hit me up and said, hey, I have a travel agency. My name is Tutor. I live in Hungary. I created a company called Travel Tutor. And I was like, well, I'm not going to sell you my domain, but what I can do for you, because I assume all your customers are not speaking English, right? They're going to be speaking the local language of commerce and education in your country. Let me give you a redirect to your own website based on the language. So you can do fun things. Let me see here. Now we're kind of getting into my, my fun part. I mentioned earlier our 503s and those types of things for user agent blocks. In Apache, if you just set it up out of the box, you get these black and white error messages. And if someone really messed it up, you're going to get, this, my favorite, an error was not, we had a problem serving you the error message. You can create your own, right? So let's say, for example, someone was building a container and they put their Docker file in the root. I can, at Apache, go ahead and try to prevent that from leaking, right? Or some other bad examples, let's say someone accidentally put .git in var www.html. We can go ahead and just make that a 404 or 403 to help us, protect the website, right? Or this is one of my favorite examples, right? If you're running, say, a PHP website and every file extension you have is .php, and someone comes in to, just a scanner on the internet, right? They got a list of common URLs. If they're asking for an ASP page and you're not serving anything with a file extension of .asp, you can have Apache do a redirect match on the file extension to just issue the synthetic error so that it never gets back to your back-end application server and spends 10 times the CPU to generate the same result. I'm just demonstrating a little bit of flexibility here. You could do it on like a location match rather than directly. If you're not running WordPress, you'd be amazed at how many requests you get trying to fingerprint that you got a WordPress server. It's not just WordPress, right? Everybody's trying to fingerprint everything. Struts was a big one a couple of years ago. This is, I want to just put flashing lights around this. Watch your trailing slashes on redirects. It is real simple for people to copy and paste up to the trailing slash and accidentally drop this. But if you do that, the equation doesn't match, right? So just put the trailing slash there. If you don't have it, what happens, as I mentioned down here, is you end up kind of creating new TLDs, right? Because you're not bringing along the slash that you should have had. Translated error messages. These are my absolute favorite, and I hope you guys all go home and do this for me. And like a foundational thing, here we are. We're all in a country where most folks are expected to, read and understand English, but that's not the case throughout the world, right? People grew up speaking other languages, writing other scripts, and the internet should be available to all of us. And one of the things that, when I'm going to a foreign website and I get a 404 message, I just, want to throw my hands up and I don't know what this is. Why is the computer yelling at me, right? And so if we at least have internationalized error messages rather than Varnish is one of my favorites. Grew mediation failed. like that just means nothing to anyone. When they see that on their screen, it just says, you know, computers are hard and we shouldn't use them. Let's go walk outside instead. And so having here some, well, basically, I'll leave this to go check this out, guys. It's in the default, you know, it's in the source code. You just got to turn it on. And the Russian translation is because I asked the guy, hey, can you do this for me? So I think it's really cool that Alex has his name probably on your computers already. With Firefox, that's how I test these out. You can just, you know, go into your Firefox preferences. That's the easiest way to change your language priority. You know, put Spanish first, hit reload, and you'll see your error messages translated. You can also make your error pages kind of pretty, and that's by, if you come back, you know, afterwards and follow this, you just got to put some CSS in the correct places, and you can change your black and white Apache defaults into being styled for what you want to see. Like I think I have this over here. I'll give you guys a quick, see if I get one. This should be better than like an Apache 404, or if I just don't have internet access, you know. Live demos, let's not. Here's another one you might want to, if you actually turn this on. I kind of think this should be in the upstream source code, but they use the referrer header to echo it back to your client. And security scanners complain that, oh, I gave you a bad URL, and you then reflected that back to me, therefore bad things could happen. You kind of do the same thing. If you have, if you're using Apache for auto-indexing, you know, you've got a static web server with a bunch of files in a directory. You can kind of, in your web browser, just have a, you know, little clicky thingy here. Let me see if I can show you guys this one. Okay, I'm not going to worry about why my internet access doesn't work, because at least I got my document loaded. But if you guys went to like internic.net/domain, you would see there's an auto index from Apache, but it's styled. You know, we've got CSS there to make it look pretty. Another good example, data.iana.org. Down at the bottom, there's a little IANA logo, and it's all from customizing the CSS. You also, something if you're customizing your CSSs, there's a lot in here. I'm going to skip past it all, but if it interests you, come back to it. I think web fonts are something you should serve yourself, because if you just use an upstream third party to download all the web fonts for your site, their access logs are the exact same as yours. You know, they know the number of people that connected to your website, from what, you know, from what countries, from what IP addresses, from what browsers. If you host your own fonts, that's a quick, easy way to keep that in-house. And here's my bonus. If you're using Nginx, you can also make prettier error images, or error pages in Nginx too, just like that. Shared files, let me have a sip of water here. I think shared files are good for kind of things like branding and stuff like that, right? This guy, Ed, he a couple years ago thought about, let's make a file called security.txt, and it's pretty cool. Here's a way that you can, you know, if you have a common Apache config that's going across multiple web servers, you can kind of share that config, or, you know, rather than having it being served directly by your downstream application server, you can just put it in your common HTML files and refer to it with an alias. Like these, right? Maybe for branding, you want your fave icon to be consistent across every single website. These are good for branding. And then while we're checking that out, don't forget, you know, cache control, right? When somebody's downloaded your fave icon, let them keep it forever. And then here's an extra note for you if you guys are using a downstream load balancer. I haven't mentioned yet proxy passes, but this has a bang at the end to exclude it. That's pretty cool. But these are, you know, for branding, these are some of the real simple ones. Some of the newer stuff that we're dealing with on the web in the last, you know, I don't know, decade maybe. Basically, there was an EFF project, HTTPS Everywhere. It used to be a browser plugin trying to get people to upgrade from clear text to TLS. And we kind of just shifted everything so that now everybody assumes 443. And one of the really easy ways to go about that, in modern times, set your strict transport security header. This is a great way to make sure that somebody's web browser is always talking to your web server. Like think of how the NSA or companies like WebSense, how their products work, right? They try to basically man in the middle of your connection. And I think I mentioned down here that, you know, like what's the worst case that could happen is somebody on port 80, you issue a redirect to 443, the man in the middle strips out the redirect and just continues serving you an HTTP page and listening to your transaction along the way. Strict transport security, this header lets us on the server side encourage people to always use TLS. Once your browser, it's a trust on first use, but once your browser has it, it's gonna stay on TLS. And how can we encourage that? Because I have some old websites, they're still available over port 80. They're gonna be available on port 80 forever. Some of them are RFC'd on port 80, like CRLs. But how can I encourage a modern web browser that first does its first hit on port 80 to switch over to TLS? You know, a CSS link is a good way to go about that, right? Don't stay on the same schema, switch the CSS over to TLS, and that will let them get the trust on first use STS header. Another option, and this is, you know, kind of old, it's less seen now, is upgrade in secure requests. And Chrome or whatever browser would say, oh, I saw an HTTP link, let me try it over HTTPS. And then when it does, then it's able to trust the STS header and everything works good. So this was a way to just push it forward. If you are using ModMD later for Acme or Let's Encrypt, you can just have it inject that header for you. I also have a little example here. All of my headers do a set or set if empty. Because if you do an add instead, you might mess up your headers and, you know, no one's going to notice, but when you are wgetting, it'll look weird. So add is appending, set changing. And I mentioned earlier, you know, you might have a man in the middle that's changing the content of your HTML without you knowing, and here's a way that you can kind of do that directly with Apache. You can use a substitute module, and on just, you know, local HTML you're serving from your disk, there's a Galmon project. The source code has a hard-coded link, and I wanted to change it to my own website, so you can do that, substitute. Or maybe someone says, hey, for GDPR, we got to put a cookie policy on the tail end of every single page, but we don't want to go edit everything. You can just kind of, you know, well, let me find the closing body tag and go ahead and inject some HTML in there. It could be a good HTML, or it could be your, you know, compromised ad server network, whatever. But this is a way to go about changing the HTML directly in kind of real time. You know, if you want to change from a downstream proxy, don't forget to reinflate your compressed response. CSPs are one of my more recent focuses. And if you look at a site like Twitter, their CSP is, you know, longer than the web page. But just, you know, be mindful that content security policies exist now. It's part of the modern web. And it's a way to say, you know, it's safe for your web browser to load an object from this destination. You know, going back to my bad ad server example, if somebody was able to change my HTML and put in a little bug that goes back and hits their website and downloads some malicious file, the content security policy should help us prevent that. You know, the browser is going to say, there's an object in this HTML that I'm forbidden from loading. And this is going to be the magic for that. You know, check out your content security policies. Try to make sure that that those work for you. I mentioned here nonces, but it's kind of, you know, those are old style. If you're using them, cool. If you can use them, cool. But don't worry too much. And this ties also, you know, I mentioned web fonts, CSPs, cores goes right into that. And as soon as you see your browser error in the console in your inspector that says, hey, I can't load this font, and you go to Stack Exchange, you go find some great example. Most of them are just going to put a star in there. I've seen a star over and over and over, and that's cool for intentionally public files. You know, some JSON that you want the whole world to consume. But I think a more cool example is to just reflect back the host name that they gave you. It's not really different, but I think it looks neater. Then, how would we test that? Just try to do a wget, and if you set your origin, that's the magic value for the CSPs. Not CSPs, but for cores. Caching. I think this is the most important thing if you want a website to stay up. Probably got about 5 or 10 minutes. Good. There's multiple ways of going about caching, and one of them, there's the expires module. If you're serving static files from disk and you want to make sure that your images or whatever, maybe you're serving videos and you don't want to have to pay for the bandwidth over and over and over, set a long expire time on them so that the client can cache your content and not send you the bill for the bandwidth. What else? If you're dealing with expires by type, you might deal with add types as well. I do add types, like on my own web server, if I've got a little shell script I want to share to somebody, it's easier to view the shell script in the browser than have the browser automatically download it, and then you got to go open it and cat it or whatever. So, maybe you want to do that. If you've got some files with a checksum, just let the browser, display them as text. The cache control header, this is important to me. If your cache control header says never cache the objects, your page is going to be slow. So you can change these on a particular path. Earlier we had a files match example that did the same thing, but if you're not serving locally, if you got proxy downstreams, here's a way to go about forcing these files to be cacheable. This is a really cool one where maybe we say we're only going to impose a cache control header if we got a good response, right? If I got a 500 back, I don't want to unconditionally be saying, go ahead and cache this for 3 days. Only cache it for 3 days if you got a 200 or a redirect or, something positive. Mod cache, the basic values that I've had to change are the floor and the ceiling. Min file size 0 lets you cache redirects. Max file size, 1 megabyte can be small on the modern internet. So you might have to bump your max size. The cache quick handler has the real big caveat in the documentation that if you have this enabled, you may be so fast in responding that you bypass some important checks that you wanted to have happen. Test it, If cache quick handler on, works for you, good. If it accidentally bypasses all your require envs, turn it off. The cache itself, you can turn on a cache header, cache detail header. It's just going to tell you, I was able to cache this object because of X, or I was unable to cache the object because of Y. You'll get that log information, but having it directly in your browser can save you a step. There is a cache ignore query string. I think it's a little dangerous, and a better idea for you is cache ignore URL session identifiers. But these are both just kind of trying to fix problems that could be better handled downstream. You might like to how can I say? One of my default perspectives, as I mentioned earlier, post is a cache busting operation, right? If I don't need support for, put, patch, delete on the root document, let me turn it off so that Apache can filter these from the downstream application, right? But there's places, I had earlier an example of a form where we need to enable post. Maybe you got to do that. Here's, allow the methods, turn off the cache. You can do it. You may, another little Kubernetes example here, you may want to store your cache on a RAM disk, Makes it a little faster, goes away when you restart, but no big deal. Be mindful there's an HT cache clean script so that if you did, you'll fill your disk if you don't eventually run this. If you're using a temporary disk that you restart on a regular basis, no big deal, but if it's long running, you've got to have HT cache clean, get rid of the old objects. And fill your disk. I wish it had a daemon mode. If any of you guys want to write a daemon mode for HT cache clean, that would be cool, but I just put it in a loop. Well true, run HT cache clean, sleep 3600. This guy, Daniel Rugari, his presentation is so good. It's from about 5 years ago. If you're doing anything with proxies in Apache, I go back and watch it every year. I tell everybody that has to work with proxies on me, go watch this. It's great. There's a lot of really impressive things in Apache 2.4 that turn it into a full-featured load balancer, and check that out. But what I will tell you is that make sure you don't have a star here, right? Forward proxies versus reverse proxies, you don't want a star here. You want a slash. And so here's a kind of a typical example. I showed this one earlier when we were talking about macros. You might proxy pass a certain destination like /static somewhere. You might give it a little extra timeout because maybe you have some report page that always takes 16 seconds to generate and people think it's normal. So, okay, account for that. If you are running a proxy on the root, which I don't suggest, because running a proxy on the root, all the things for like, if you want to filter WP login.php, it's easier to just have a 404 on / any random file and then only allow only have an allow list of good paths that get proxied and have Apache do your 404s for anything else. But if you're in the opposite situation, right, where you've got a proxy on the root, but you need to exclude some files that you want to serve locally, like your Google Webmaster authentication, your Bing authentication, or that security text, or this UUID path, that's how you would go about it. Just put that bang in there. Load balancers, or I should say balancers, are a newer thing in Apache that I really like, mainly because you can have a status of hot spare. So we can say for my, instead of having a one-line proxy pass that always goes to the same one destination, whether it's available or busted in the moment, with the balancer object, you can have multiple balancer members, 5, 10, whatever. I tend to have 2. There's my backend Kubernetes service, and then maybe a secondary, a SARI server of some kind, so that we do respond with HTML. Proxy pass reverse is basically a sed on any downstream response. You can get away without a proxy pass reverse a lot of the time until that one time you need it. There are status pages from Apache that will tell us all about the cool things that, that it does. And a lot of third-party monitors are going to be looking straight for the server status page, and you might have to change that URL if you follow what I've been doing throughout the entire thing, is I use a lot of UUIDs. And you can see right here, like I have a proxy pass, so that this UUID path can get served locally. And that lets me make available pages like the server info handler, the server status handler. There's a balancer manager. We also have Apache, not Apache, but Acme related stuff like certificate statuses. And these are all going to be kind of under a UUID or whatever special path you want. But they're not under the default because people will be out there scanning for /server info and it just dumps your server config. Let's encrypt, another part of the modern web, strict transport security and all that. If you need a let's encrypt example, there's one. It's pretty cool. I suggest, trying it out. But if you're, look at my example if you need some hints. If you, exploring the web server, you can do some gross stuff with old style CGIs. Should you do this? No, but if you needed to, here's an example. A shell script that just dumps every environment variable that the web server that knows about. And this is kind of cool if you're dealing with mod SSL and client certs or TLSA or whatever. You can do export some extra variables out, and you can literally export the raw certificate that you got inbound and run some OpenSSL commands on it. Or here's another one, if you want to set your remote username and your logs to match the DN on the client cert. Maybe you want to use AJP instead of HTTP in your proxy pass rules because you get all that metadata for free. And I will real quick talk about logs, and pretty much logs are going to help you out immensely. An example that I have in here is you can send it out to standard logs if you're doing something with containers and, purists want their logs going that way. Or if you're doing something that's kind of JSON formatted. The big thing that I'll suggest you do in Apache is go read the log documentation and check out the insane amount of values that you can get. Like every header that comes inbound, I can log in addition to mod cache statuses down here, or even some of these environment variables that I've chosen to set. Like if someone matched the 1918 health check that I created, I can log a 1 or a 0 here. The unique ID is the most important part of my logs because I can take an error log that has a unique ID and map it up to the original hit that has a complementary unique ID. Also, there's forensic logs if you need to get really advanced, and buffered logs if you need to queue your logging. Once you've got all those logs, instead of using old tools to just, count it in word count dash lines or whatever, make a dashboard in your log environment. If you're using OpenSearch or the Elk Stack or Splunk or whatever you have, make some dashboards that show you things like your most popular hits but also the least popular, right? That's where all the gems are in the really rare hits that you get. And also make sure, I guess, we'll wrap it up here, but make sure that your server name matches, right? Your host header that the client presents to you should map up to your server name. And let me go find my macro example. This is going to be my quick summary of how I, basically with host headers, you want to put the correct key in the lock. And what I do here is the server name must match this, right? You can have server aliases, but if that server name does not match, your default virtual host will issue a redirect to the most correct site. And you want to do that because of things like Google. If you have Patrick.com, Patrick.net, Patrick.org, Google will index those documents as 3 independent things. You want to pick your most correct host name and issue redirects to your most correct host name. Consider the situation where someone goes and registers Patrick.horse independently and then points it to my name server. If I'm not double checking the host headers, they are now serving content under their domain from my web server, and at any point they can pull it back to their own web server and kind of take the reputation that they've gained by indexing my documents under their domain. So this is very important to me. Make sure your server name and your host header matches. If someone's coming at you with an IP address, don't return content to them. Make sure, if they're coming at you with their own domain or local host, don't return content. Send them to the correct place. Sorry I don't have questions. Time for questions, you guys. I think I get off the stage in about 30 seconds. But if you, I might be in a bright red hoodie. If you run into me over lunch, if you got any questions or comments, let me know. This is a public GitHub repo. I hope you guys are able to check this out later and that I've exposed to you something that you may have never heard of before, right? That there's one little bit that you can take home and make your web servers better. All right. Thank you, everybody. I really appreciate you hanging out.
Thank you. This is Rafiq Rahman, and we are going to have some discussion about security program maturity, risk scoring, risk register, and different things. This is going to be a relatively smaller discussion, so I don't plan to take the whole hour for this discussion. But depending upon the questions that you may have, and we will see where we go from here. I just want to give a little bit introduction of myself. I am in information security field for quite some time. I came from Linux background. I am a Linux enthusiast. Very much supporter of open source software, open source movement in general. And I actually am volunteer for OLF Conference for a number of years, 6, 7 years going now. All of the training programs that we run here, I manage those training programs. Professionally, I started my career in software development and initially Linux system administration. I went into networking, and in early 2000s, I stumbled into information security. So that's what I have been doing for a very, very long time. But at the same time, I continue working on software development projects as well as contributing to open source software and open source technologies. Currently, I am working with Verizon, and I have been solution architect for quite some time. For the last 6 months, I am working mostly with the software development, product management teams, helping them build information security related issues into the software development lifecycle and so on. Out of work, I contribute to, as I mentioned, open source software, but also information security industry in general. One of the things that I do on an annual basis is what we call CISO mind map. So if you may have seen some spider chart on the internet, that's I do on an annual basis. I have also written some of the books. This is a sample. My latest book is what you see on the left-hand side, Cybersecurity Arm Wrestling, that came up last year. And it is mostly about building security operation centers and how to manage it, how to make it more efficient and more reliable and so on. So I am going to, as I mentioned earlier, I am going to mention a little bit about how to mature the security program. And there is actually a specific part of the security program that I'm going to talk about, that is risk register, risk management, and so on. And I have some thoughts that I'm going to share with you. But before I go there, let me ask if any one of you is working in any information security capacity, whether it is secure software development, software management, security program. Okay, some of you are. Okay, very good. Anybody who is dedicating their time mostly towards risk management? That is okay, some of you are in the risk management area. So as you can imagine, there is a lot that happens in information security on a day-to-day basis. People are running their security operations. That is most of the time they're doing incident response and day-to-day work and firefighting and whatnot. But there are many other things that happen on a routine basis which need more planning, which need program development, and so on. So as I mentioned, one of those things is the risk management part, which I'm going to talk about. By the way, the CISO mind map that I mentioned, this is what you see. This is the CISO mind map for 2022. The next one would be coming up, I think, in 2023, somewhere March, April timeframe. But it kind of comprehensively identifies everything that happened in information security professionals' life. So let's start talking about the security program maturity. So there is one way of running a security program, which is primarily working on day-to-day basis, looking at vulnerability scans, looking at log files, chasing down alerts, and figuring out if there is any incident, how to respond to that incident, what caused it, and so on. So that is a what I would call a non-automated, not a very mature process when you are dealing everything on a day-to-day basis. So first thing that I have learned over the time, and I have seen in many cases that helps building security program to next level of maturity, is automate. So anything that you can automate, you should automate. I'm not saying that you can automate everything, but the first thing that should come to your mind when you are dealing with a security incident, a security issue, or some advisory service, first thing that you should be thinking about is, can I automate? If yes, how do I automate so that there is no manual interaction and it happens on a continuous basis? It is a repeatable process. So automation is number one thing that I would suggest anybody who is running the security program to do. Many times you may not be able to do automation by yourself. You may have to go to somebody, for scripting, somebody for building something inside application hosting. You may have to go to DevOps people and so on. But get help from around the people around you and automate as much as you can. Second thing that many times people know but they forget is that the reason most of the security programs are there to enable business, and that is many times people don't realize that if any security program is not enabling business, it is not a mature security program. The third thing that is actually a bigger and bigger problem, and many of you may realize, but industry is realizing it over the years. We have built so many security tools, and now many times it feels like the purpose of security teams is not managing security, but managing those tools. On the average, there are some studies, every organization is using some 40 to 50 different security tools. I work with a lot of DevOps people these days, and I know even in DevOps side, there are probably 10 to 15 security tools that everybody is using just for software development, managing CI/CD pipelines, and so on. So there are a lot of tools that people have out there. So the biggest thing that everybody is realizing that this is not sustainable. There are more than 1,000 security software companies who are selling you tools. So one of the biggest recommendation is that if you see more tools, think about how we can reduce those tools, because having more tools is not always equal to having more security. Many times it is actually quite the opposite, because you spend more time in managing tools than actually thinking about how to manage your business. Last thing is about managing risk, and this is actually the bulk of talk that I am going to have after this initial kind of giving you a high-level idea. Okay, so one of the things that I talk about is making incremental changes. We do want to do big projects. We do want to do something that is big and significant and that everybody knows about. Many times, what I have realized in information security programs, that when you do big things, those things are usually not successful. When they have a lot of touch points, they have to work with a lot of people, different teams. So my suggestion over the time has been make incremental changes. Many times people think that incremental changes are not very useful, and they should be thinking always about big things. But if you make some incremental changes over time, they do build up, they do accumulate, and they have a much bigger impact than you would be thinking about the larger project. So this is not like really how life works, but this is just to give you an idea that if you are making 1% change every day, and there are 200 working days in a year, then you can achieve actually significant improvement over the year. Again, this is just for sake of having fun. Life doesn't work like 1% improvement every day, but I guess you get the idea. Okay, let's talk about risk now. So I just want to start with some of the basic definition of risk, understanding that many of you are not coming from the background of risk management. So risk is basically a possibility of a loss in future. So it is something that you are thinking that may happen in future, something bad that may happen in future, and you are looking at the likelihood of what could happen and how we can stop it. So that's all about managing risk and thinking about risk. One thing that is important is that risk is not a constant thing. Many times in our current security practices, you have like once in a year you have a risk assessment, or you have a vulnerability scan every 3 months, and you think that that is how you are going to go with risk management. Most of the times, risk changes on a daily basis. A vulnerability that was, for example, rated a very low today, and tomorrow you figure out that there is an exploit that is available for that vulnerability, and the risk associated with that vulnerability goes from low to high in a matter of days. So if you are doing your risk assessment every quarter or every year, then you may be living with risk that you initially thought is going to be low, and now all of a sudden it is going to be high. I put this diagram here. It is coming from a project, EPSS. It is a daily risk scoring project for vulnerabilities that are identified. So if you think about the bigger circle, which is all of the vulnerabilities that are identified, the inner blue circle, if you think about, these are the vulnerabilities that are scored by CVSS 7, 8, 9, or 10, something more than 7. So usually we call these high-risk vulnerabilities. And if you think about the red smaller circle, these are actually the vulnerabilities that are exploited. Believe it or not, that all of the high-risk vulnerabilities, they are never exploited. Majority of them are not. Only 10% plus minus high-risk vulnerabilities are ever exploited. So the idea of showing this small red circle is that you need to think about which are the vulnerabilities that are highly likelihood of getting exploited, and plus, as you can see, this red circle, it goes into the low-risk vulnerabilities, so outside of that blue circle, which means that there are many vulnerabilities that are rated as low risk, but they get exploited, and they are used for different data breaches. So how do you deal with situations like this? So that is one of the objectives of maintaining a risk register and keeping up to date about what is the area that needs most attention from you. So if you are using, for example, EPSS, as I mentioned, is a scoring system. They publish their data on a daily basis. You can write a simple Python script or Bash script, and you can download their data on a daily basis, automate it, and every day you would see what are the top 10 vulnerabilities that are being exploited today, and if any one of those is in your systems, in your software, then you can take an idea from that and manage your risk that way. So it is very crucial for us to understand that, number one, risk is not constant. It changes on a daily basis. Number two, to deal with that situation, you need to build some mechanism so that you can, in your program, you can adjust on a daily basis as well if risk changes related to any vulnerability or any system that you have. So one of the main objectives when you build a risk register, you have to think about how you can implement that mechanism. And many times people think that it is very difficult to do those kind of things. It is not. Many times you can write simple scripts. I have written scripts, and the work that I do is mostly about automation of risk management. So you can write scripts, you can write simple web pages using some framework like Django and so on, which can help you manage risk in a proper way. Okay. So sometime back, I did a survey on LinkedIn, and I asked people, how do you manage your risk register? These are the results. This is basically a screenshot from that survey. Obviously, it is not a scientific survey, and it is not like you can 100% say, this is how exactly everybody is doing. My suspicion is that there is some bias. Many people who don't have any risk register to document and manage and track their risk, they may not have even responded to their survey. But people who did respond, 12% of them, they say they don't use any risk register. I guess that percentage is more than 12%, just based upon my understanding of the industry. Then there is a large percentage of people who use spreadsheets. That is still going on, and it is not only in smaller organizations. Some of the major organizations also use just simple tools, like a spreadsheet, or like a document, or like a wiki page, or if people are using Confluence, they are using Confluence pages and so on. I would suggest in the long term, if you are going to build a risk register, build some sort of web application that you can host internally, that is accessible for throughout your organization, and that has some notion of attaching any of the vulnerability or identified risk to an assessment with the internal system. So hopefully that gives you a little bit idea about how other people are doing it. Okay. So now, when you start building risk register, what are some of the guiding principles? These are the things over last 20 years that I have learned working with industry and different people. When you do complex things, usually they don't work. So one of the first recommendation from my side is think about minimalistic. Don't think about boiling the ocean. Think about what is the minimum that you need to do and go with that. Again, start small and make sure that people who are building risk register, some of them are, maybe not everybody, but some of them are the practitioners. So it should not be only the developer's job to build something like that. They should consult very closely with the developers. And you should make that the risk register, whichever way you do, whether it is spreadsheet, whether it is a database, whether it is a web app, that it gives you visibility into the highest risk. It is easy to use, low cost. I think everybody would agree with that. Spending more money is not always equal to getting better results. So make sure that you're not boiling the ocean. You're not building something big, at least in the starting point. And last but not the least, the dynamic scoring that I mentioned earlier, and I will get a little bit more into what dynamic scoring means. So make sure that this is not a static once in a quarter, once in a year type exercise that people utilize, but there is a mechanism where your risk register shows the changes that are happening on a daily basis. So that is very crucial. Okay. So typically, the way people have been doing risk management is the first two, which is qualitative, which is somebody says, I think this is a high risk, or this is a medium risk, or this is low risk, or some variation of that. This is very subjective based upon the experience of the people who are doing risk analysis. Sometimes you would see that one person would say this is a medium risk, other person would say no, this is a very high risk, and you would go to a third person. That person may have a better understanding about additional controls that are in place and may say this is low risk. So this is very subjective, but people do it. It has some value. If you have nothing, I would say starting with qualitative risk is not a bad idea, although it has its limitations, as I mentioned. Secondly, quantitative risk, which is a little bit more in-depth analysis of, in terms of dollars and cents, in terms of quantity, how much, if there is a vulnerability, is it going to, and if that vulnerability is exploited, is it going to result in $1 million loss? Is it going to result in $1,000 loss? And so on. So that's when you do those kind of analysis, that is usually quantitative risk. And the last one is risk scoring, which is relatively newer, and I think this is probably at this point, again, with its own limitation, I think probably if you are still doing qualitative or quantitative, think about risk scoring. That is more based upon data that you have, and that is going to give you a little bit better picture of the risk that you are managing. So typically, qualitative risk is done like this with some kind of metrics. what is the vulnerability, likelihood of exploiting that vulnerability, what is the impact, and based upon that you have some metric like this one or this one. There are, like, if you look on, if you search on images on Google for different kind of qualitative risk management, you would see many of these. Like there would be 4x4 metrics, 3x4, 3x3, you name it. So again, this also, as I mentioned earlier about the limitation of qualitative risk management, that it is based upon opinion and there are so many different ways. So people get confused about what it really is. Quantitative, you use some formulas. I'm not going to go into formulas. These are standard formulas that everybody uses. You will see in every risk management book on information security. But basically, the idea is that you are dealing with numbers when you think about quantitative risk. So if you are, as I mentioned, my recommendation is going to some risk scoring methodology. So if you are using qualitative, sometimes people would say from qualitative, if you are going to go to next stage, go to quantitative risk management. And then you can go into risk scoring. I would argue that it doesn't matter whether you're using qualitative or quantitative risk now. You can always move to risk scoring methodologies quite easily and quite effectively. Okay, so when you do risk scoring, what does it mean? So this is like, next 2-3 slides, I'm going to describe it a little bit more in detail, and that would conclude my discussion. So, so when you're thinking about risk scoring, there are two main things that you have to keep in mind. One is about what is the base risk or inherent risk or fixed risk score, which basically means that every time that you are doing risk analysis, let's say you have an e-commerce solution. And for e-commerce solution, there is a base risk score or a fixed risk score that you can do nothing about it. By that, what I mean is that there is a risk of exposing any web application on the internet. There's nothing you can do it. You are assuming that risk. You are taking that risk because that's how you want to do the business. So that is part of your base risk scoring. There is, for example, you have built your architecture of that e-commerce website in 3-tier or 2-tier, or you are building it in some cloud hosting environment, and so on. So depending upon architecture, how secure it is, how many layers you have, how these layers are separated, network segmentation, and so on. So there is a risk related to that architecture. There's nothing you can do until you change the architecture. So you don't need to worry about that risk on a day-to-day basis. It is there, you understand it, and you have taken that risk. When we think about, for example, attack surface, there is a risk about it. Are you exposing 10 servers on the internet, or are you exposing 100 servers on the internet? So based upon how much your attack surface is that people can exploit, that increases your risk score. But again, this is it is what it is. It is not like if you need 100 servers, then you should go to 10 servers. If you need 100 servers, you need 100 servers on the internet. So again, one thing that you have to one thing that you have to make sure that you understand that this is part of the base risk scoring. Sometimes people would think about how many users compared to, let's say, 10 users of an application. If you compare that with 1 million users of that application, so it is going to be a different risk factor for that. So I have mentioned some of these items here, but the point is that when you are thinking about risk analysis and risk management, think about the things that you cannot do, but they have risk. Score your risk based upon that. Once you know these factors, then you have to create some formula, and everybody has a different formula. I know there are some vendors who will give you some risk scoring. They would never tell you what is the formula that they are utilizing, and you want transparency in that. So if you are building your own application to manage risk, then you have to have some kind of multiplication factor for all of these components that go into risk scoring. So for example, you would have a multiplication factor for number of users. You would have multiplication factor 0.5 for number of servers you have. You would have a multiplication factor of if it is PCI compliance, or if it is no compliance, or if it is government entity. So the multiplication factor that you see in the middle part, that is how you multiply the number with a multiplication factor to get the score. So the basic idea, if you can get from this page, is that there is a fixed risk score of everything that you do, and there's a way to calculate that fixed score using multiplication factor and identifying all of the parameters that go into that fixed score calculation. So calculate that fixed score. If nothing else, everybody can do fixed risk score calculation for the application and systems that you have in your organization. So that is the first stage, or I would say first step, when you are going to risk scoring for your risk management. The second one is now variable or actionable. This is the score that where you can do something. So the fixed score, you can't do anything. It is fixed. Variable is that changes, and this is where you have some actions where you are always looking at in the process of risk management, how I can reduce my variable or actionable risk on a daily basis. So for example, if you have to apply patches, you did apply patches, and your risk score is going to be lower. If you have 100 vulnerabilities, you fixed 20 of them, your risk score, variable risk score, is going to be lower. So again, you take some of these ideas, like how many patches I have, how many vulnerabilities I have, if there is a disaster recovery capability that I don't have today, and tomorrow I am going to build that disaster recovery capability 50%, then it is going to lower your risk score. If I am doing a pen testing, I have 10 issues, and I fix 5 of them, that will lower my variable or actionable risk score, and so on. So again, you are going to, number one, on the left-hand side, as you see, you are going to list all of the factors that go into your variable risk score, and that would vary from organization to organization. You would identify what would be your multiplication factor, and you would get your variable risk score. This is your risk register application. This is the score that it shows you on a daily basis, that yesterday it was this, today it is higher or lower, and this is the trend that is going on, and that is going to help you not only identify and take action, but also if you need to request any new project or new funding for managing risk, that is going to help you, because now it is not somebody's intuition, it is not somebody's idea of whether it is high, medium, low. You have a methodology that is transparent, you have risk factors, you have multiplication numbers, and you can share it with everybody within your organization. This is how we are doing it. There's no subjectivity, and that is going to give you better credibility. Now, last thing that I would say is that when you are thinking about variable risk score, there is a drill down. I'm going to give you 2 examples of how you do that drill down, so that you get the idea. But again, based upon your organization, that drill down may be very different for different people. So let's say you are scoring your vulnerabilities. And it is not like a one number. There are going to be multiple numbers that are going to be part of your vulnerability variable risk scoring on a daily basis. So for example, you have, assume you have 1,000 servers, and you have you are scanning vulnerability on 700 of them, but the other 300, they are not being scanned. So that is your coverage. That is going to be a factor, that are you covering all of the machines that you need to scan, or are there some part of population that is not being scanned? If that is the case, that is your risk, and you are going to calculate that based upon whichever formula you decide. Secondly, age of vulnerabilities. Let's say you are looking at your Qualys scan, your whichever scan you are doing, and you see that there are vulnerabilities that are 3 months old, there are vulnerabilities that are 6 months old, and based upon that, your score would be different for those vulnerabilities than something that is just identified 2 days back. So the age of vulnerabilities, for example, is going to be a factor. And then on daily basis, as I mentioned, some vulnerabilities may be scored low yesterday. You got new idea from EPSS, from whichever place, and now you know that there's an active exploit that is available. So on a daily basis, you get that data, you put in your risk register, and it gives you a different score. So rescoring of existing vulnerabilities, that is going to change. So that is just one idea about if you are thinking about vulnerabilities, how on a daily basis, even if you are not doing daily scan, just because you are getting a daily score from third parties that are available in free and open source, your risk score is still going to be changing on a daily basis. Second example is about, many times people do assessments. Assessments could be third-party assessment. It could be, penetration testing. It could be internal assessment of a project or a software. There could be some SaaS, DAS tool, those kind of things. So for the assessments, again, you need to drill down and you think about, is it a third-party assessment? How I am going to score that one. If it is an audit finding, that would be a much different scoring for audit finding. Again, the type of audit is also going to tell you how much, what your multiplication factor would be, and so on. So the idea here is that each one of these areas that you see on the left-hand side, and there could be more for your organization, that you need to think about a little bit next level and drill down and figure out what are these subcomponents of what you are scoring, and how you can take those subcomponents into an overall risk scoring methodology. So based upon that, you would have your daily risk score, and that would help you prioritize about the projects that you are going to work on. The good thing about risk scoring is that more data you have, the better your scoring would be. And you don't need to, again, as I mentioned earlier, you don't need to start with, a big bang type, a huge implementation of risk scoring methodology or risk register. Start with something small. Start with the data that you have, and incrementally start making changes and start adding more and more data sources. So for example, initially you may have only data about vulnerability scanning. Then after that, you can take that data and implement it. After that, you can drill down and start looking at vulnerability aging. 3 months old, 6 months old, how long it has been there that I have not done. Then you can start including that one. Then you go to EPSS and start getting their daily scores of vulnerabilities that you have and start implementing that. So take one step at a time when you are implementing your risk register, and that is going to be very helpful as well as successful. And the more data you have, the better your score is going to be, the better you would be able to prioritize and justify for your funding and overall risk management framework. So that's all I had. As I mentioned, I was not going to take the whole hour. I don't think we need the whole hour, but I shared some ideas with you. I think some of those ideas probably you are going to implement and find useful. There is a lot that I have seen in last 2 decades of my work in information security field, and there are many people struggle justifying cost. Many people struggle justifying having larger teams. Risk scoring is one of those things that can help you do that and justify the expense that you need. And in some cases, actually help you eliminate some of the tools that you may already have. So with that, thank you so much. I have put some information here for my contacts. Best thing is if you need to send me a message, just DM me on Twitter, and that would be best. Otherwise, I have a personal blog and as well as my LinkedIn website. So with that, thank you so much for your time, and hopefully this was useful.
Thank you so much, Rafiq. I don't see any questions online. Just a heads up for our YouTube viewers, if you're on our Slack, you can join the main stage channel and pose any questions there. But I'm going right now to questions in the room. So this man has his hand up first.
When you do your risk assessment and you're trying to pull in data, who do you talk to? And do you talk to everybody, or do you go to specific managers or the working people to get your data?
Yeah, so very good question. There are data sources that are within your organization. There are data sources that your vendors can provide, and there are data sources that are available open on the internet. So my suggestion is that first of all, before you go to anybody, look at all of the data sources that you need or that could be useful for your scoring and risk management program. If there are data sources that are available internal, so for example, vulnerability management data is available usually internally, whoever is running your vulnerability management program, they would be able to do it. So start with socializing with managers, their teams, understanding how easy or difficult it would be. At the same time, I would emphasize actually quite a bit on this thing that many times people don't realize that the vendors they're already working with, you're already working with, they have a lot of data that they can share with you for free, without any additional cost, and they would be happy. Usually vendors, they are very happy to share the data that they have. We at Verizon, we have a lot of data that we share with the community in general. I mentioned EPSS group that I am part of. They look at all of the vulnerabilities that are identified, and they share data for free. Similarly, your vulnerability management vendors, they would have other data sources. They may have their own scoring method that they would be able to share with you on a daily basis. So think about vendors. And last but not the least, think about the open source data that you would have. But who to go? I would suggest there are always some people who are listed as the owners of data. So identify, number one, identify which data you need. Number two, if it is internal, who is the data owner? Go to that person and start socializing. So that's how you get it. But I have found more and more that vendors and open source data sources are actually very reliable and very much helpful. And they are free, usually.
Thank you. Who's got the next question? I'll come to you next.
During your presentation, you mentioned that there was maybe an opportunity where not 100% of your systems would be scanned. I'm struggling with what would be a valid use case of not scanning non-prod or other systems.
Yeah, again, very good question. Usually, the reason for not 100% scanning is not because people don't want to scan. The reason is that people don't have a very good handle about their asset management. That is the number one reason that I see over and over. People just don't have a good count of all of the systems that they have and start scanning them. So to your point, there is no good reason for not scanning systems that you don't have. Usually in IT environment, that people are willing to do it. But the asset management is the main issue. Now, on the other hand, if you are, for example, in a manufacturing environment, there are systems which we call operational technologies, and there are many situations where people don't want to scan those systems because they are not built for security, they are not very stable, they could crash, and if any one of those systems stop working for any reason, there would be implications on physical universe. A machine may stop, an air conditioner may start doing heating instead of cooling and whatnot. There are reasons when you don't want to scan those systems. But in most of the IT environment, what we see is lack of asset management is the core reason.
Just a quick question. When I looked at your risk scoring, are there tools available to enhance that? Pre-made spreadsheets, templates, things like that?
Yes, there are. People have spreadsheets, templates for risk register. Usually what they lack is scoring methodologies. So there is actually an open source project that I am working on. It is not published yet. So at some point in near future, next probably 3 to 6 months, not 6 months, by end of March 2023, we are going to publish that open source scoring methodology, basically a web-based application. But having said that, there are many commercial vendors in last 2-3 years who are basically offering their systems for a fee. So if you want to do something like immediately, going commercial is one option. The only thing that I would caution you about any commercial systems is that, number one, they try to solve everybody's problem in the same way. So it is not customized. As I mentioned, from your organization's perspective, the scoring method could be quite different than a large organization compared to a small organization, compared to an organization in manufacturing versus retail, and so on. So that is one thing that you have to think about. The other thing that you have to think about if you go commercial is that they are not very transparent. They don't tell you what their risk scoring methodology is. They don't tell you what their formulas are. They say we use artificial intelligence, machine learning, AI, and ML is like the buzzword that everybody would throw at you. So there are issues with that. So I'm not very comfortable yet about going that route. I think more prudent way, if you can put some resources, is to build something for your organization. Start small, start with like, if there are 100 data sources that you can utilize, start with like 1 or 2 and then slowly build on top of that. You would find that way much more rewarding and much more useful for you.
Great, thanks. Anybody else? What do we have here? All right, I'll take one last look online. Didn't see any questions there. Oh, well, thank you very much, Rafiq.
Okay, very good. Thank you.
And I'll just make a quick announcement here. So for those of you who have a badge with a ribbon on the bottom, you're welcome to join us for lunch. That's going to be served over in Ferris West C. There's a limited number of tables over there, so you're welcome if you want to bring a plate over here to these tables as well. Those folks who are getting lunch elsewhere, there's a few options. If you go downstairs to the lobby, there's a little place there called Spark. I'm not sure how many seats they have. If you go through the lobby and continue, you'll get into the convention center itself, and then if you turn right, you will eventually make your way to a food court. Or also, I can't really give you directions, but a couple of blocks this way down Vine Street, there is the North Market, where there are a bunch of different stalls and actually some really fantastic restaurants in there. There's also some restaurants along High Street. If you want, you can go to the registration desk. We have some of these maps from Experience Columbus, and they point out a few options as well. So thank you all, and we'll see you back here at 1 o'clock. Hey there, welcome back everybody. Hope you all had a great lunch. And we'll be starting back up. So this morning we had Apache, and we're going to kick off the afternoon with Nginx. Again, you folks out there on the YouTube stream, once we reach questions and answers, please go on our Slack to the main stage channel, and you'll be able to pose questions there that will relay to the speakers. But without any further ado, I'll give you Tim Quinlan.
Do you guys hear me okay? Sound good? Okay, good. I guess I can just move this out of the way then. So let's start it off with a little show of hands. How many folks are using Nginx in what you would consider an advanced state? Are you, already have a proxy set up? Are you doing clustering? Or you have it in like a really high volume production? Anything like that? Okay, good. How many of you, keep your hands up, how many of you are using Nginx on a smaller scale, maybe just serving up some standard issue content, things like that? Great, great. How many of you are maybe just using Nginx for your own enjoyment or for your own hobby? You got maybe a container running, or you're installing from your OS or from your OS repos, things like that. Good. So how many of you have never even heard of Nginx? Really? Okay. Wow. That's good. Well, we got at least almost everybody to raise their hand right there. So anyway, my name's Tim Quinlan. I'm a technical account manager. I work for F5. F5 acquired Nginx Inc. a few years ago. We'll get into that very briefly. But, I basically work for the company that, supports Nginx. I work with some of our largest customers on their installations, help keeping them running, and best practices and things like that. And you can ask questions at any time. I'm always happy to stop. I got some cool little cats to reward folks for questions, so you may have a stuffed animal thrown at you if you ask a good question. So the agenda, we'll do a quick history of Nginx. We'll talk about the basics of configuration and operation. Then we'll talk about the reverse proxy use case, which is one of the most common, and we'll get into some of the options there. Then we'll talk about some data plane scripting with NJS, which is our implementation of JavaScript. And if we have some time, we will talk about a high availability, high availability API gateway setup. And everything that I'm doing here before the high availability stuff is all based on our freely available container that has the official image of Nginx on it. And in the links at the end, we'll have the GitHub where it all is. So everything I'm doing here today, you'll be able to just pull down off of GitHub and have it running in Docker if you want. And then also the HA stuff uses our Nginx Plus, which does require a license. And there's also a GitHub for that. And if you want to try that, just come see me at the booth, and I'll get you a trial license. It'll be good for 30 days. So with all that, let's get started. History. So Nginx has been around since 2004, so almost 20 years. It was originally designed to solve the 10,000 concurrent connection problem. Like, that was the big goal, and to just generally outperform Apache. Those were the initial goals of the developers. It was a very popular open source project, still is. In 2011, Nginx Incorporated was formed, and that simply was to, come out with a premium product, Nginx Plus, that was based on the open source product and provide commercial support for it. Then in 2019, Nginx Inc. was acquired by F5, and they want to use, or the whole idea there is to use Nginx as sort of a foundational software for modern applications. Nginx is released under the BSD 2-clause license, so that means there's a Nginx open source. It's freely available. You can do whatever you want to do with it, as long as you attribute, basically. And then Nginx Plus is based on Nginx open source, and due to the fact that it's all BSD licensed, you know, it's closed source software. It's not like an open core or a module on top of it. It's its own its own separate thing. I just pulled this off of Netcraft the other day. Nginx is the most popular web server out there. You can see it's got about a third of the market, and that's just pure Nginx itself. Some of the other little squiggly lines on here are products that are based on Nginx open source. So if you added them all up together, it would be a little bit higher than that. And then these are the sources that you can get Nginx from. So from F5, you can get an official Docker image. That's what we're going to work with today. There's mainline and there's stable, right? Mainline is the newest, most cutting edge stuff. Those are the odd releases, I believe, the odd numbered releases, and then stable, it's forked off of mainline every once in a while, and then just the critical patches are applied to that. So, you know, they're both very stable, but if you have something where you require like super stability, obviously pick stable. If you want the latest features, you pick mainline. F5 also provides Nginx open source packages for all the popular package formats out there. And you can actually get commercial support for Nginx open source if you use those packages. And then Nginx Plus, same thing, it's from F5. And those come in, you know, package form for any distro out there. From the community, obviously, you can download packages, you can download the source code, whatever, do whatever you want there. Most OS distros have it. I honestly can't think of one that doesn't off the top of my head. And then, of course, there's the Docker community. So there are countless images out there that have Nginx on them. So who knows what version it is. But you know, if you're involved in one of those community undertakings, congratulations or kudos, I guess I should say. Thank you. We have a ton of other stuff available that is open source and free that rides on top of Nginx. Nginx open source, obviously we'll talk about that today. That's the foundational product. Nginx JavaScript, we'll talk about that a little bit today too. I have a couple of very basic examples, and I'm talking very basic. You know, we have agent that can connect back to some of our management software. Unit is our application server. And then Amplify is our diagnostics stuff. And then we also have some Kubernetes native things down there. Once again, it's all based on Nginx, right? It's essentially Nginx that is, you know, you can run with a CRD. So as I mentioned, you know, Nginx was acquired by F5 to be a foundation for modern apps. This is sort of this shows, you know, our enterprise side versus our free and open source side. You know, we have things at the data plane, control plane, and management plane for both of them. I'm not going to really go into any of this in detail. We're just going to focus on Nginx. If you want to talk about some of these other projects or products, come see us at the booth. So configuration and operation. So Nginx is the config files are hierarchical, right? You have these what we call contexts, right? Each context inherits whatever is defined above it as well. So in this here, if you define something in the HTTP context, the servers and the locations and the upstreams underneath it inherit that as well. So let's say you have you know, one directive. Let's say you have hundreds or thousands of virtual servers defined, and you have a default SSL key, right? You can put that in the HTTP context, and then everything below it will inherit it. And then if you need to override that, you just redefine it wherever, you know, at that lower context, wherever you are. So in the case of an SSL key, let's say you put it at the HTTP level or server level, but you have a few locations that want to use a separate key for whatever reason. You just redefine the SSL key in that location, and it's fine. And nothing below that location, or nothing next to that location, will inherit its stuff, it'll still inherit it from the higher thing. So it's just all hierarchical. And when you're reading the documentation, you really want to pay attention to the hierarchy. If you look at these two directives, and these are things we'll go over later, these are directives for rate limiting. And the limit request zone must be defined in the HTTP context. If you try to define it anywhere else, you try to define it lower, or if you try to override one of the already defined ones in a lower context, Nginx won't start. It's that simple. The next directive down, that is the limit request. That is the actual call to where you're going to set your rate limit, and that can be defined anywhere. It can be defined in HTTP. It can be defined in server. It can be defined in location. So this is one of those directives where you could possibly override at a lower context. You could set at the HTTP level. Let's say you're doing an API gateway, and you have a default SLA of 1,000 hits per second for your whatever offering, and you could set that at the HTTP level. But then let's say there's a customer who wants a higher or lower limit, then you could override the limit at the lower level. Now if you are going to override the limit, obviously you need to have a second limit request zone configured, but we'll get into that later. Whoops. So managing the configs, without going into any detail about our management layered products, it's really standard issue config file stuff. You can do one big monolithic config. You can put everything in a confd directory, and then it will just kind of assemble everything in whatever order it finds it down there, as long as the files in that confd directory are kind of a cohesive little unit. You can and the order is not too important. You can get away with that. But if you have something where you need to have certain sections, you want them split out into different files for version control or whatever, but you need to have them load in a certain order, you can use include files. And then in your main config, just call those includes out specifically where you want them. And there's a couple of lint checkers you can use. The Nginx -T just does a lint check. Make sure your config looks good. Nginx T will actually print out the assembled configuration file. So if you have, however many include files or however many conf files, you can print out the entire configuration and see where things are landing and see where things are going. And then we always want to use the Nginx signal, Nginx-S, to reload. The reason being is it will do a lint check on the configuration, and if it senses that, or if it doesn't pass the check, it won't kill any of the processes that are there. So let's say you have, most OS init scripts are going to do this the correct way, but let's just say you have an OS init script that's not behaving well, and it does an Nginx stop and then it tries to restart Nginx. Well, if you have a typo in your config, now your web server's down, right? Because it's going to stop the process, and then it's going to try to start it with a bad config, and it's not going to start. The reload signal, like I said, keeps everything up there, keeps everything running, and maintaining whatever active connections it has, and then it brings up the new rev. So I talked about the Docker image. We'll do this and we'll get into the first demo of the day. We released two. There's Nginx stable and there's Nginx latest, and they go along with what I discussed earlier with stable and mainline. And it's really simple to do. I don't know if you're familiar with Docker. You can run a command. Something like this will start up the web server locally, and away you go. We can do the demo real quick if you want. You can see there's our HTML directory in there. Can you guys see that, or you want me to bump that? There we go. Can never remember which key to use on a Mac. Can you see that? So we can just do a typical Docker run command. We're going to forward port 80. We're going to attach our HTML location. I got to cheat. I don't remember. Where is it? User share Nginx. Nope, I'm not connected to the network at all. I got everything pulled down locally. I was getting ready to say if you was, you may want to change the port because they may have a fit. Yeah, no, we'll be all right. Don't worry. As long as I can remember here. So there we go. We got it running. We can see here that we are running Nginx 1.23.2. So it's the odd number for the minor revision, and that indicates that it's a mainline release. So if we want to look at, see what we got going. There we go. There's our custom HTML. The extent of my web development abilities. It's all in the GitHub. Don't worry, you'll be able to get it if you want. Yeah, and then you can also if you want to run the stable image, it's the same way, right? Same thing. You can see that it's actually running Nginx 1.22. Okay, and obviously the same material, right? Same source material. So that's pretty straightforward. And I just picked the wrong one. So that's the simplest use case. If you just want to try out Nginx, that's all you need to get started. So now let's talk about the most common use case for Nginx out there, and that is a reverse proxy. So what is a reverse proxy? This is a very simple diagram. Basically, you have users making requests to an instance of Nginx, and then that instance of Nginx forwards those requests to upstream servers, pulls them back, and sends them back to the clients who are requesting them. So why would you want to do this? There's a lot of different use cases for this. Caching of, say, heavier content like images or media of some sort. You could have a much more robust box at the front and have a bunch of small, tiny little servers in the back serving up the content, or maybe pulling down dynamic stuff from your database or whatever it is. But you're keeping all the heavier media closer to the people who are using it. Load balancing as well, we'll go over that. Once again, you could have, one-to-many servers in the upstream. They could be perhaps different classes of servers. You could add for scaling or something if you had a bunch of heavier servers in the back and then maybe a few lightweight ones, you could weight the load balancing. You can get pretty granular with it. SSL termination, depending on what sort of environment you're running, you can basically handle all the SSL or all the SSL connections from that reverse proxy, and then just talk back to your backends without SSL. So, you can save some cycles doing that. Not many people are going to do that nowadays, especially if you're in the cloud. But in a completely internal environment, you could do that. And then the big one is the API gateway. There are tons and tons and tons of folks using Nginx as an API gateway, and that's the examples we're going to go over. So basically, an API gateway, it's just a service gateway. Somebody's going to connect. It's going to ask for a URL, and then the API gateway is going to forward that request to the appropriate backend server or servers, and then serve it up. A lot of credit card companies do this. Most of the time that you swipe your credit card, actually goes through an Nginx instance at some point. So it's a huge use case for it. So there's 4 components that we need to look at to set up to set up the reverse proxy. There are upstreams. These are defined in our HTTP context. These are where you define those endpoints that the Nginx instance, the reverse proxy instance, is going to forward those requests to. They don't have to be Nginx. They just have to have the port open that you're sending information to. But most likely, if you're using Nginx at the reverse proxy level, you're going to be using it at the upstream level, unless you maybe have a gateway service that you're running, and your customers are actually giving you an endpoint to forward that traffic to, and then they're going to have whatever they have at that point. Keep alive, we'll talk about, not entirely necessary, but it saves a lot, especially on a very busy API gateway. Basically, it'll just keep the TCP connection open between the reverse proxy and the upstreams, and it will save you that cost of continually reestablishing for every connection. We'll talk about load balancing as well. And we can go into a couple of different algorithms that we have, but we're just going to stick with round robin and maybe some weighted round robin for the demo. And then we can talk about persistence. If you have a, say, not entirely stateless application that is running on one of your upstreams, that when your user hits your gateway, they need to always hit the same back-end server, you can use persistence to do that. So let's just get into a bit of a demo here. And I killed my clock by, let me just do that. I killed my clock when I had to exit out of PowerPoint. So everything, like I said, I'll have in the links at the end. Everything's on GitHub. The entire demo can run in Docker with Docker Compose. I'm not going to go into the specifics of that, just suffice to say that you need Docker Compose installed. And basically, this output on this screen, it's essentially the syslog, right, from those, or the log from those containers. So there's no, we'll be referring back to this screen, but just keep in mind there's no real order. There's no mutex or anything on this. It's just whatever the containers are spitting out shows up in here, and whatever order they get returned in is the order they're going to show up. So let me expand that one up. And the first thing we're going to do, the upstreams. So the way I configure this is, I'm in the wrong directory. We're just going to go into the virtual file system for the container that's running the reverse proxy right now. I put everything in conf-d. I have a Docker DNS defined in there, so Nginx will use Docker DNS so the hosts can talk to each other. That's only really relevant for the demo, but I have one file for upstreams and one file for my virtual server. So let's look at the upstreams. You can see that there's a couple of different upstreams defined in here. Any amount of locations can use these upstreams. So you'll see when we get into the virtual server configuration that there's a lot of locations that will hit these. But we have basically right now, if we look at this one here, we have upstream 1 defined with a max fail of 1, upstream 2 defined. The max fails we'll get into that later. And then we have keep alive defined as well. But we have this IP hash. This is what enables system or session persistence. We have that commented out now. And then this weighted entry, we have that commented out as well. So if we look at what happens when we make a request, everything's running on 8080. Okay, and boom, there we go. So we just have a little hello OLF. Now, if we go and look at our requests, we notice there's only talkback here from the reverse proxy. There's no talkback from our upstreams, and the reason being that our slash location, right? All it is it's just serving up HTML out of this thing. So it's not actually forwarding any requests. It's just that location is just a regular basic web server. But if we look at this next location down, that's called LBS for load balancers, right? We have this directive called proxy pass, and it passes it to this Nginx LB, which is defined, which is what we were just looking at. And then we also have a rate limit there as well. We can talk about that later. But if we now look at the load balancing location, now we can see there's a lot more talkback here. Right? We see reverse proxy 1 got the request right here, has all the header information and things like that, and then it forwarded it out to upstream 1. Okay. Now, I have the logging turned down on the upstreams to kind of reduce the noise on this screen because it's a pretty noisy screen. But suffice to say, any headers that you get into the reverse proxy, you can forward on out to the upstreams. So we're in just a basic round robin setup. So if we hit this a couple of times, there, upstream 1, still upstream 1. There we go. Oh, and we got upstream 2 just popped in. So now it's probably going to start kind of alternating back and forth. There we go. There's upstream 1, upstream 2, upstream 1, upstream 2. So super simple, right? 2 evenly load balanced upstream instances. We talked about keep alive. We're probably not throwing enough traffic at this to even make keep alive relevant, but it is something you definitely want to do. I'm not going to go too much into tuning all the individual settings, but that is definitely something you want to have. The load balancing algorithms. Like I said, we're going to stick with round robin, but what I want to do is I got this example already cooked in here. We're going to comment out that one. We're going to uncomment this one. So basically what this says is the default weight is 1, right? So when we say weight 3, that means that this is going to, once it starts load balancing, it's going to get 3 requests for every 1 that the second server gets. And you could put anything in. You could put, whatever, 7 and 2 if you wanted, like 7 on one and 2 on the other, like however you want to do the ratio. Just have the default setups there. So all we got to do now is restart Nginx on the container. We're not going to bring the container down. We're just going to reload Nginx. And we're going to use that signal to reload. There we go. Now, when we take a look there, we'll just start throwing a few requests at this. Everything's coming from upstream 1 still. Oh, okay, now there's upstream 2. So now we should get 3 in a row from upstream 1. And then this should be upstream 2. There we go. So it's just a 3-to-1 ratio. It's pretty straightforward. But like I said, you can do the ratios however you want. And typically you're going to have a somewhat even distribution or somewhat even capabilities on all your different upstreams, but you never know. Sometimes you might have some faster servers or some slower servers that you want to account for. Oh, and then persistence, right? So we can enable that IP hash directive on the upstream, and this will keep I'm going to reload Nginx again. Start hitting it with a little bit of some curl. Now, we should never see it flip over to upstream 2 because we're in a persistent connection. So now, as long as that instance, or as long as those connections don't time out, and there are, you can look in the docs and stuff to see what all the different timeout parameters are and things like that. That we're not throwing enough traffic at it now, nor will we be using it long enough to really see. But you know, as long as this client is hitting from that same IP, they're going to get to the same back end. There are other things. It's IP hashing is pretty simplified. I mean, I can just think of a ton of different ways. If somebody's behind a NAT or something, right, that's not going to work. But there are other algorithms that you can use. And then our Nginx Plus product also has a few more that are a little more advanced. So what I'm going to do is just back out that change right now. So we have even load balancing and no persistence. Oh, and why don't we do this? We'll approve. I made an intentional typo there. So let's reload Nginx. There, it's going to say there's an unknown directive SRVER, but if we start throwing traffic at it, it's still serving it up, and it's still serving it up in the same pattern that we were before, right? We are tied with persistence to that one server. Now, if we go in and we correct our error, and if I could type, I'm going to reload Nginx on that container. Everything's started up cleanly. And now, when we start hitting it with some requests, eventually you're going to start to see it load balancing back and forth. There we go. There's upstream 2, upstream 1, upstream 2, upstream 1. So, and it seems to take a few hits to actually start load balancing back and forth, just because this is an extremely low traffic environment, right? If you had this in production, it would be, you know, instantaneous. So those are the basics of a reverse proxy. And like I said, there are many use cases for reverse proxy. And then there are tons of other directives. There are tons of options for these directives that we don't have time to go over. But everything's really well documented. Oh, and I should point out for the documentation as well, nginx.org is where the documentation for Nginx open source is. docs.nginx.com is where the documentation for Nginx Plus is. They look incredibly similar. They have very similar branding. It's the little green hexagon with the N versus a green hexagon with an N plus in it. So if you're using open source and you find some docs on nginx.com, those may not work on what you're doing because those are for extensions that are written into Nginx Plus. Now, if you're using Plus, you can use the documentation from either side, but if you're using open source, you want to stick with the documentation in open source. So one of the you know, it's not like, you know, Linux versus Red Hat, where there's completely different branding, completely different look to the website, everything. They look the same. So let's get back into our demonstration, or to our PowerPoint here. So, like I said, those are the ultimate basics of setting up a reverse proxy. We'll be hanging out at the booth all weekend, so you can come see either me or my colleague Dave over there, and we can talk more about it. Rate limiting. This is another big thing now. I mean, I can think of hundreds of reasons why you would want to rate limit. I mean, obviously, denial of service protection. But if you are running a service gateway of some sort and you are, you know, selling your service to people, you want to set an SLA for them, right? And you don't want them going over that. If they're paying for 1,000 hits per second, you want to leave them at 1,000 hits per second, right? So we briefly saw these two directives earlier. I used an example of looking at the context for the location, or excuse me, looking at the context for the, where you're supposed to put the various directives based on the documentation. So I do have rate limiting set up in this demo, so we'll just jump back out. Look back in here. Now, if let me blow this up once. If we look at, where are we? We look at our upstreams configuration. We see that there, right? We've looked at that. We're going to look at our virtual servers. Okay, this is what I was talking about. You may have things kind of scattered around your file system, and you don't really know where they're going to be or what context they're going to be. But if you can use that nginx-t, and it doesn't work with less on this for some reason. Oh, it would help if I actually ran it on my, not on my local system. That stitches together the entire config file. So here's our virtual server stuff that we saw. Here's our upstream stuff that we saw. But then there's also a bunch of other stuff from the main nginx config file. So if you look at it, here's the events context. We talked about that when I showed you that little tree of things. That's its own separate context under what's called the main context. That's where you kind of set up directives and things for how the binary is going to run, how it's going to operate, things like that. There's an HTTP context, which we are working in now. That's where you set up all your HTTP stuff. Underneath that, you can have streams, which would be like non-HTTP. Like, so if you're going to load balance some encrypted protocol or something that's not exactly HTTP, you can do it there. But you can see we're still in the HTTP context, even though these don't really line up just because of the indentation's different. But we're still in the HTTP context. We have upstreams, and we have our servers. So we have this limit request zone set up. It's in the HTTP context. That's where you have to set these up. You can have more than one as long as they're named something differently, right? So if you wanted to set up a second zone, so let's say you wanted to have a default zone that served whatever 500 hits per second, you would set it up right here, right? And then we would call that zone 1, and you could put zone 2 and have it for 1,000 hits per second for your premium customers or whatever, right? Anyway, since this is a pretty low traffic demo, I have put it at 1 request per second to actually show that it works. So that's the memory zone that keeps track of all that, keeps track of all the hits for that thing. Now, I've also put in this location, and this LB's location that we were using, we're still passing the traffic up to the upstream servers, but we're actually capping it or rate limiting it at the reverse proxy tier with this call right here. We say, here's a limit request. We're going to use zone 1, and we'll allow a burst of 5 before we start, capping it down. So if we, oh wait, that's the window I want. If we still look at this location, right? It's fine. It's serving traffic up, no problem. We can cut out a lot of this to say we can tell it's coming from upstream 1, upstream 2, upstream 1, upstream 2. Okay. Now I'm going to use AB to throw a ton of traffic at it. I think we've got to put the whole URL in. You can see it's being capped right now. We threw all that traffic at it. It's going to take a few seconds for all those requests to actually get processed, right? You can see some of these requests are pretty long. If we go into, I probably should have done this the other way around now that I think about it. In my mind, I did this differently. If we go in and we remove that limit request, or request limit. All right, we've restarted Nginx. We're going to throw all that traffic at it with AB again. It serves it all up immediately, right? But if we go in and we enforce that, sorry. Then we start seeing where it's getting limited. Now, if you look over here at the container output, you can see the requests are coming in. The requests are trickling in, but it's not going to actually forward that to the upstream until it's, you know, gotten down to the whatever cap you put on it. So you can see it's all pretty consistent. But like I said, you can have more than one rate limit. You can define a default rate limit up at your HTTP context, and then override it down in your locations. So pretty straightforward stuff. Once again, there's a lot more to it than just this. This is just the basics. The docs have everything, or come hang out with us and see where we can help you. Okay, the next thing is mirroring. And boy, I'm talking too much. So traffic, is anybody doing mirroring right now for anything at all? Basically, okay, we got one guy back there. Basically what mirroring allows you to do, here's our standard issue, kind of super basic reverse proxy. We have all the same stuff. The client requests are coming into a reverse proxy tier, and they're splitting them up between one-to-many upstreams. We can also mirror the traffic that comes in and pipe it into, say, a staging server, right? So, you know, you could, you know, stage your changes there, make sure that it can accept the traffic. Other, like, API security systems have, like, a learning method to them, so you can pipe all your traffic to that, and it can learn to see what your customers are doing, and you can build security rules from it, things like that. I'm sure there's a ton of uses for this. It's very popular. Most of the ones I see working with our customers are, you know, for the security, for building their security rules and just making sure everything's going in. So we'll take a quick look at this. This is defined in our virtual server as well. So basically, when you mirror content, you need somewhere to mirror it to. So I have created a location block that's called mirror target, and it's defined as internal only, so you can't hit this from outside of Nginx. Only Nginx can feed traffic into this location. And it's proxying the entire URL out to this Nginx mirror upstream, which, if we look at that, it's just one server. You can, it doesn't have to be one. It can be as many as you want. It doesn't matter. And we have keep live set up. I'm not going to really affect anything in this demo. So we have the mirror target. I said it's internal. We're passing some extra headers to it and things like that. Then we have a location here that's called mirror. It's just doing a normal proxy pass to Nginx LB, which is our standard set of upstreams that we have been using. And what it's going to do, it's going to mirror everything to mirror target. And we're not going to send the whole body. We're just going to send the headers, right? Because that's pretty common for people who are just doing security analysis on what they're doing, or on what they're seeing. So if we look, we'll throw some traffic at localhost 8080/mirror. And if we look at our container output, see who's doing what down there, you can see now we have our normal hit at reverse proxy. This is where I was trying to explain earlier, like the order of stuff comes out here isn't always logical, just because it's whatever container gets there first. So we see it hit our reverse proxy. We also see it hit upstream 2, which is perfectly normal. We also now are starting to see mirror 1. That means mirror 1 got a copy of the traffic, and that's it. And then the cool thing about mirroring is it just sends it over the fence. Like, it doesn't wait for a response. It doesn't wait for anything, because the last thing you want to do is have your mirror go down and then affect your production traffic, right? But if we look at this we hit it a couple of times. There we go. So now we got upstream 2, mirror 1. Here we got mirror 1, upstream 1. Well, there is only one mirror, but you can do whatever. I mean, the mirror itself, and if we get into the NGINX Plus demo, the way I set that one up is the mirror is actually another API gateway, right? It's another reverse proxy. So you're sending the mirror traffic to a reverse proxy tier, and then it's splitting it out amongst its backend servers. Because, some of these places that are doing millions of hits a day, credit card companies and things like that are using this, their mirrored systems are pretty impressive. I'd like to have one of those in my basement, right? So, okay, we have about 10 minutes left. So, extending NGINX. There's a bunch of different ways to do it. We're only going to talk about one. Well, 1.5. So, modules, right? Modules are written in C because NGINX is written in, guesses? Yes. So basically, a module, it's just, they can be compiled in, they can be dynamic, whatever, right? There's a humongous community out there. This URL contains maybe not all the known ones, but all the very popular ones. Some of them are even included in NGINX core at this point, right? We've already looked at upstream, we've already looked at mirroring, and we've already looked at rate limiting. Those are from modules. So we have a thing called NJS, which is NGINX JavaScript. It's basically a subset of JavaScript. It's not fully blown. It's kept small to be fit for. It's just big enough to be fit for purpose, right? For manipulating and massaging HTTP requests. You're not going to be able to write your application tier with NJS. It's more of a, think about it like your app. It's for customizing your application architecture, if that makes sense. It's compatible with ECMAScript 5.1. It has some features from ECMAScript 6 in it, and it's a module. So basically, you're using a module to write software. You're using an extension of NGINX to write software to extend NGINX, right? It's kind of like, pimp my ride, right? Heard you like extending NGINX, right? So let's extend NGINX with an extension of NGINX. It's a little more complicated to set up, but still pretty easy. You load the NJS module in the main context. You include the JavaScript file that you've written. You import it, and that can be, I have the context written here. That can be pretty much anywhere. So once again, you can have the default, the override, whatever. And then you call the function. We have the two main ways to call it are with JS content. That is, so if whatever program you wrote is actually generating content and sending it back, you use this directive to call it. And then there's JS body filter, which is you're sending the content somewhere else, or you're sending the request somewhere else, retrieving the content, and then massaging the content, and then returning it to the client. And there's the full docs are there. We're just going to go through a couple of very basic examples. Forget where I put it, actually. A little bit, one more. Where the heck did I put it? Oh, right. I have it under the HTML directory. And then I just have, the way the Docker's set up, it just mounts this directory. Or does it? Where did I have it? I apologize. All right, so I can't believe I'm yeah, that's true. Ah, there we go. Thank you. It's been a while since I've given a talk in front of actual humans. Typically, I'm talking to my cat while I'm looking at a Zoom screen. Anyway, thank you, whoever that was. Who said that? Here. There you go. First launch of the day. I wrote two very basic, extremely simple, easy to grok examples. There's a hello world. Super easy. It's a function that just returns a hello world command, and it sends it out. So if you look at, where are we now? And we look for, did I pass it up? Oh, I did pass it up. So here's our location, NJS hello. As I said before, let's see. Oh, that's right, it does that goofy thing. We have, here's our full Nginx config file. Right at the top in the main context, we actually load the module. It's just sitting there on the file system of the container. We load it, we run it, and once we get into our HTTP section, we set the JS path. That's basically, you can define the whole path for each call, but this is just say, hey, in general, this is where you're going to find JavaScript, right? Or this is the first place to look for the JavaScript, and that's just that folder we were looking at, and it's mounted up with Docker. Then we import the JavaScript file, and then we use JS content to actually call the function from JavaScript. So, super simple. A lot of that is a way to say, there. It's just a hello world with NJS. And as you can see, that is just going to be the same, whatever message is here. So now, you could write whatever you want at this point. Like I said, you can't write a full-blown application with this, but you can do some pretty basic stuff. Now, the second one that I want to show you is this. This is string to lower. So all this does is it takes your data in, runs it through a string to lower type, to lowercase in JavaScript, and then returns it out, right? So if we look at the config again, this location is actually sending the request out to our upstream tier, right? It's going to get whatever it sends back. It's going to import the string to lower JavaScript, and then it's going to do a body filter on it. So if we looked at And as you notice, the proxy pass for this location is going to the exact same spot that we have been using, okay? If you want to look at it here, at our load balancer, so it's just this kind of test page that we use that just shows you where the request came from and stuff like that. But pay attention, this is all mixed case, right? If we send the same request but we run it through that content filter, right? It's all now lowercase. So pretty simple. Like I said, I'm not going to go into any great detail here. You can read the docs and kind of figure out what you would want to do with that. You can do a lot more than just changing the case. And I'm out of time. So I got through all the basic stuff I wanted to get through with open source. I can just talk really quick about high availability. There are 3 NGINX Plus features that make HA possible. There's shared zones, there's active health checks, and there's dynamic upstreams. Basically, the shared zones, it's a state database between the however you define it, between like if you had a multi-tiered reverse proxy. So you can share rate limiting info across there. Active health checks will constantly ping those upstream servers and then take them out if they're unhealthy for whatever reason. And then there are dynamic upstreams as well that can help you with auto scaling, right? So with standard NGINX, if you wanted to add an upstream server, you would actually need to reload NGINX. With this, you can just make an API call and add it. Like I said, I'm out of time, but I'll be around all weekend. I have a full demo set up for this as well that you can access from GitHub, but to get it to work, you do need a trial license. So just see me and I can get you a trial license. It'll be good for 30 days, and you can play around with this too. Let me just skip all this stuff. I'll print these out into a PDF and put them up in the GitHub as well. But if you just remember my name, Tim Quinlan, is my GitHub. And there's the NGINX 102, which is the stuff we talked about. The NGINX Plus API Gateway is the stuff I was just talking about before, or a minute ago. And the rest of the links are just to various things that we talked about throughout here. So if anything, just this slide will get you everything you need to know. All right? We good?
Thank you very much, Tim.
Since I ran out of time, I will be right outside for Q&A. Okay?
Fantastic. Thank you very much. And so Dave, you can come up and get hooked up and we'll get you going. All right, welcome back, everybody. We're looking now to move on to Bash and lots of fantastic things that you can do right in the shell. So please welcome David Both.
Thank you, Vance. I'm really glad to see all of you here. Unfortunately, right now is my normal nap time. And I think I can tell that at least some of you have your normal nap time about this time too. So I will try to keep you awake as much as I can. If I fall asleep, somebody please wake me up. I would like to talk about Bash for a few minutes, but just to tell you a bit about myself, I've been in the computer business for 50 years, actually a little more than that. I allegedly retired 10 years ago, but I still have so much fun playing with computers that I've written several books about Linux and a lot of articles. You can go on my website, www.both.org, and find out a whole lot more about me, but that's just to give you a little bit of an idea of how long I've been working in this industry. The thing you see, well, can we pull up the display? Yeah. The thing that you see here, that is a little bit of an ASCII art, animated ASCII art, and I think it's a really cool indication of some of the fun things that we can do. I like to have fun. I play around a lot. I tell my wife I'm experimenting, and I think that is one of the things that allowed me to keep 12 computers at home as long as I have. There we go. Okay. So I'm going to talk about configuring and using Bash. Can you all read that okay? Okay. And one of the things that I find fun is little command line programs like this one, which is how I figured out how to make that, that little screen before. This is the code for that. $message holds the message that I'm using, and the boxes is a little tool that prints the boxes around the outside of the message. We're going to talk about a lot of these things. We don't have a lot of time, unfortunately. I could spend about 6 weeks talking about Bash. I actually spent some time with my wife practicing my presentation today. Unfortunately, I had like 42 hours worth of stuff, and I had to cut it down into 50 minutes. So we're going to skip over a lot of fun and interesting stuff, but I do have some links at the end that will take you to some more detail about what I've been doing. This is Ian, by the way, and he's holding up a little bit of card that gives you a little bit more information about me. I'm on Mastodon. I don't do Twitter anymore. At LinuxGeek46 at linuxrocks.online. How many of you are sysadmins? Okay, how many of you are not sysadmins? Okay, how many of you who are not sysadmins actually do things that sysadmins do? You are sysadmins, okay? I don't care whether your boss has that title for you, but you are a sysadmin. And anybody who is a sysadmin can tell, because I've got this list of things here. First of all, if you think my books might be a fun read, if you've ever repaired your own computer, I've got a list that's about 40 lines long that I just couldn't put all on this slide, but I just felt like it was very important to ensure that you at least had some idea of the kinds of things that sysadmins do. One of the things that I find fun is I change things on my hardware a lot. This is my home system. I've got 2 grandkids who have asked me to help them build a gaming system on this Master Frame 700 frame, just like this one. And it's really cool to have something in common with my grandkids that I like and that they like. My teenage granddaughter basically said, "Gee, Grandpa, I really had a lot of fun doing that." So it makes me happy. So here's a Linux truth. I've got another one later, but this is one Linux truth. Unix wasn't designed to stop its users from doing stupid things, as that would also stop them from doing clever things. I have done a lot of both. And usually it's the stupid things that I've tried to recover from that has helped me figure out how to do the smart things and the cool things. A lot of people ask me how I learned Bash. Well, I first got a bunch of books and started memorizing all of the commands. No, not really. I didn't do that. How I did it really is I just started out by doing the things that I needed to do at any given moment in time. I started with the basics, moving around the directory tree, and I started with list commands, learning the rest as I needed to. I always assumed that the Linux command line could do exactly what I needed it to do, and then I went ahead and figured out how to do it, because I know it can be done, okay? Yeah, I see some heads nodding back there. And I play with it. I do stuff like this all the time, you know, just coming up with little fun things like colored banners using the lolcat program, right? And it's fun. So I learned how to do these little fun things, and then later on, a problem comes up and I decide I need to do something, and oh, I know how to do that. It's one of those fun things that I learned a little while ago. The command line interface, and if you'll excuse me for a second, I get dry mouth, is basically any text mode user interface to the Linux operating system that allows us as users to type in commands and see the results as text output on the display. And this is kind of the architecture that we're looking at. This is just conceptual, and it's very idealized conception at that. The operating system will open a terminal emulator or a virtual console and open a shell program in that terminal emulator. And there's a lot of shells. We'll talk about a few of them as I get a little further along. The shell displays the command prompt, and the user types in a command at the command prompt, hits the enter key, and when the enter key is hit, the shell transfers that information back to the operating system, which then does whatever it was told to do, and then sends the information back to the shell, which displays it on the command prompt, on the command line again. Command prompt itself, it's just a string of characters. And it's usually got a cursor, which is flashing most of the time, and that is prompting you to enter a command. A shell is probably the best interface for sysadmins. There aren't any artificial limits. I use a GUI. For example, I'm using a console as my terminal emulator, but I'm just using it on the GUI interface. That gives me a whole lot more flexibility. But the shell prevents us from running into artificial restraints that can be placed on our ability to do our jobs by whoever wrote the GUI program, because they can't write everything possible with all of the options and arguments that you might use on a command line. They can't possibly think of everything that you might want to do. So as a result, I find that the command line is my best way of dealing with all of the sysadmin stuff that I need to do. It does make it easy to automate things, and I find that everything should be automated. If I do a task once, if it takes more than one command on the command line, I automate it. I put it in a script, okay? We'll get back to that a little bit later. Every user can have their own default shell, and it can be different. The default is bash for most Linux distros. Does anybody know of a Linux distro that uses something other than bash as the default? SUSE? Okay, what do they use? ZSH. Okay, ZSH. I've tried ZSH, and it's pretty good. I just like bash a lot, and it's everywhere, right? When I was working at a number of different jobs, all of the versions of Linux that we were using used bash as their default, so that's what I got used to. But Z shell is also a lot like bash. Okay. You can specify the default shell for each user in etc password, and the user can change their own default shell as long as it's already been installed on the system using the change shell command, chcsh. Bash, as I've said, is the default shell, and it's based on the Bourne shell, which was originally developed by Stephen Bourne, and when it was written as bash, and it used a lot of that, the same syntax that the Bourne shell was using. So they called it the Bourne Again shell, which I think is kind of interesting. Some of the other shells that I've used, C shell, if you're a C programmer. How many of you are C programmers? Okay, I see 2 or 3. It has the same syntax and structure that C language does, so you'll find that familiar, and your muscle memory will be very happy with you for using the C shell. The trusted C shell, I really don't know a whole lot about that. I've only used it for a couple hours while I played with it one time. It's mostly been replaced by bash. The Korn shell, I used that quite a bit when I was at Cisco. We had a lot of Unix machines that used Korn shell, so I got real familiar with that. A lot of the scripts that I wrote under bash run under the Korn shell. Is there a question back there?
Well, I was going to just say, as an avid C programmer, I don't like the C shell. Mostly because it's incompatible with doing scripting, but Dash, Korn shell, KSH, ZSH, so many others, they're all compatible with bash, but not C shell.
Okay, I'll change my slide next time, but thank you. Did you all hear that? Okay. And of course Z shell, which is very much a combination of C shell, TCSH, and the Korn shell. So why do you like Z shell?
Oh, I didn't say I liked it.
Oh, okay. Oh, why do you use it?
Because it's installed by default. I run it long enough to switch to bash.
Okay, he says because it's installed by default, and it's because he's got his muscle memory already set up with it, okay? Whoops. And no, I didn't have anything to drink at lunch. Shell programs or scripts are just a sequence of bash commands. You can create them on the command line. I do that a lot. I just do some ad hoc command programs from the command line, and it's a really good way to do things. A lot of the sample stuff that I use in this presentation is just ad hoc command line programs. And then you can also store them in an executable ASCII text file. Those are just a number of commands in that file, and they just each run in sequence. This is an ASR 300. That's it. Can you see the? And it uses a roll of paper to display what you've typed and what the results are when you get the results back from the computer. This is Dennis Ritchie, and Ken Thompson, who were actually the creators of Linux, or Unix rather. And they're at the PDP system that, on which they wrote Unix. And this is a little bit newer terminal. Have any of you used this? Have any of you used the ASR 300? Yeah, I learned Bash on an ASR 300 dial-up terminal at 1200 baud from the University of Toledo up in Toledo. Go Rockets, right. And the computer they were connected to was here in Columbus. It was a GE system, time-sharing system. Did any of you know that General Electric created computers? Okay, a couple of you. I see a few hands. And that was my introduction to system time-sharing systems. It was pretty interesting, but it's been a while. And a virtual console. Do you all know what a virtual console is? Does anybody not? Do they need me to show anything else besides this? I think there's an issue there, but you can still see the typing, right? Okay, cool. Terminal emulator. That is a software program that it runs on the GUI desktop, and it gives me an interface into the computer through the shell. Okay, the software terminal emulator basically is just a tool. It's almost the same as having an ASR 3. No, it's not an ASR 300. It's more like having a really good deck. VT100, but it gives you that access to the command line. There are a lot of terminal emulators. Like everything in Linux, I find that there are a lot of options if you want to select a terminal emulator. I like console. I like Xterm. Sometimes it's fun to play with the retro terminal emulator. Anybody? Yeah. And I like the XFCE4 terminal also. One of the things that I like about XFCE4 terminal and console is the fact that they give me the ability to do fun things like split my display into multiple sessions, okay? I could do it here. Let me do it here too, okay? You can probably see that better because it's bigger. So this gives me a lot of flexibility in terms of how I deal with having multiple terminal sessions open at the same time. And I typically have several. I've got a number of them open right now, and we'll see why a little bit later. But some of the others are Terminator, Tilix, RxVT. I've used all of these for at least a short time at some point in my career, and they're all very cool. But like I say, console is it for me right now. Let's talk about pseudo terminals for a second. One of the things that Linux is really good at is devices, and pseudo terminal is just a device file, a device special file that allows the terminal session to attach to it so that it has access to the system. The dev directory is what contains all the device files. And the device files are kind of like a gateway to the devices they represent. It's not a device driver. It's different from a device driver. But let's take a look at what's in there just really quick. Notice here that you have all the hard drives. Okay. Actually, these are these are not hard drives, they're SSDs, but they're on the SCSI port, so they look like hard drives. And we're going to do some fun things here. So who knows what this is going to do? Anybody? That's all right. You know it? Actually, it kind of goes in the other direction, but you can wipe the disk. The DD command is sometimes, actually a lot of the time, called disk destroyer. I've managed to destroy a few disks using it. Some intentionally, some not so much. Yeah, it gives us 16K of the first 16K on the device SDA1, okay, on that partition. So I gotta do my password because of sudo. And this is the beginning of that. And we page down, and guess what we see? This is all the LV, the logical volume management information, okay? It gives us the capability, the DD command gives us the capability of looking at the contents of any device, including the hard drive partitions, the hard drive, the boot record, all of that. Not only can you look at it, but you can change it. I'm not going to demonstrate changing that. So this is just one sample of the really cool stuff that you can do. And remember that I used sudo here because we're going to talk about sudo again. Programs use standard I/O for input and output. It saves a lot of programming because when Unix was first designed, it actually stored the output from one program in a file and then they would use another program and input that file to the program rather than using the vertical bars that we use now to pipe things from one program to another. And its primary function is to move a data stream from the output of one program to the input of another. And it's that piping in pipelines that makes it really powerful on the command line. And of course that's true of any command line rather than just bash, but it is an excellent feature to have. It's just unbelievable. Have you all heard this? Everything is a file? Has anybody not heard that before? Okay, I guess everybody's heard that, but is it really? Or is everything a stream? Think about that for a minute, okay? Where do you get the data streams from? From a file, okay? My files are on my hard drive, and when I do a lot of the things I do, my programs get the data off of that file and run it through a data stream, okay? Send it as a data stream through my pipeline, and it comes out the other end. It could go to the display, or I could redirect it, but I think that they're actually interchangeable. A file is a data stream on a hard drive or a SSD, and a data stream is just stored in a file. Does that make sense? Okay. But I think I'm the only one in the world that thinks about that right now, okay? So I think it helps me to understand a little bit more personally about how that all works. But here's an interesting demo. Let's just do it this way. Okay. How many of you know what Who Am I does? Among other things, it tells us what the terminal session I'm coming from. Okay, this terminal session is attached to device PTS6. That's /dev/PTS/6. Okay. So here's a little program, very similar to the one that I used earlier. It just creates a banner that says Linux Rocks, and it encloses it in a box and then runs it through lolcat. Okay, that's pretty simple and easy and cool. But then if I run it through /dev/PTS6, I redirect it to that, and it comes out over there. So every device is like a file. Those are the exact same commands I would use to redirect it to a file. So this is a really good illustration of what it means when you say everything is a file or everything is a data stream, because a data stream can go to a file. Okay? Does that all make sense? Okay. So there are 3 shell types. And I'm not talking about Z shell or whatever, C shell. In this case, I'm talking about a login shell versus a no login shell versus a no login shell. The login shell is one that is created when a login occurs. For example, if I log into a virtual console, okay, that is a login shell. If I log in to the GUI is a login shell. Anything I start, any terminal session I start under the GUI in a virtual terminal or a terminal emulator under the GUI, that is a non-login shell. And we can tell the difference. I can prove that, okay? The no login shell, I'm not going to spend a whole lot of time on it, but it's basically a program that says, gee, you can't log in. And it's used for mail servers, for example, would use a no login shell. And the reason they would do that is you don't want your mail users to log into the server. You just want them to be able to log in and get their email. And that's kind of what that helps with. It prevents them from actually logging on to the server. It's a security thing. So these are all the bash configuration files that you're going to run into. Oh, well. The global ones are the ones where I like to do most of my work and make changes, because that makes all of the changes exactly the same on every user. And I have a number of users on all of my systems. They're not different people, they're all me, but they're different user accounts. And so I want the same tools that I use and the same configuration that I use on all of them. So that's what those first 3 or 4. There's also a global non-login configuration file, which is bash logout, and that will run any program that's put into it, any set of commands when you log out. Again, that's a global one. The local login configuration, they all have, they're all located in your home directory, and they usually are hidden. They begin with a period, and they kind of go along the same way with the global ones, in the sense that they have the same or similar names. There's a couple optional ones, the ones at the bottom. Those are hardly ever used. I've not ever seen them. Does anybody know when .bash_login or .profile in your home directory is in use? Anybody seen that? Okay, a couple people. I'm sorry? I've seen .profile used by some Wayland compositors. By what? Wayland compositors. I'm sorry, I'm still not understanding you. Wayland compositors. Wayland, okay. Compositors, which are basically Wayland's version of a window manager. Okay. Like your OpenBox. Okay, did you all hear that? He said it's used by Wayland, the Wayland compositor, right?
Some of them, not all of them, but some of them.
Okay. I'll have to remember that. Thank you. This is kind of what startup looks like, and it's a little bit like that other diagram that you were shown a little bit earlier. But one of the things that I find tricky is trying to decide which sequence things work in, okay? Which sequence the files are used in. If it's a login shell, it goes this way, and it starts with etc profile, which looks for the files that are in etcprofile.d, which is a subdirectory that contains startup profiles for all shells, or most shells anyway, but also those of bash. And then it returns to /etcprofile, and then it goes /etc/profile, then starts your local bash underscore profile, and that runs, and then that's done. And again, if you've got a .bash underscore profile, which almost every bash system has, then these others aren't even going to get looked at. So the bash underscore login and the bash and the profile command, those files are not even going to get looked at. Okay, because this is first found. Okay, if it finds bash underscore profile, it's not going to go and look for the rest. It will just execute that, and then it will exit. If we go to the login shell, the non-login shell, it executes .bashrc first, which then executes your .bash underscore profile, and then it goes to bash. Okay, this is really irrelevant. And I say that because most of the time it's not, you're not going to care about that most of the time. If it becomes important because you're having a problem setting up your configuration files, you'll have to do what I did, which is to set up, just to add a line that prints out which file is being run at any moment in time during the startup of the bash session. And under Fedora, this is what it looks like for a login shell versus a non-login shell, okay? That's not non-login, that's non-login. So it's quite different. And that's partly because the non-login shells inherit the environment from the login shell from which they were spawned. So for example, the desktop is a login shell, and it has a bash environment. And when you launch a bash shell within that environment, that bash shell is a non-login shell. So, but it still needs a little bit of additional stuff. And if you want it to be different from the login shells, you can see how you might do that in this case. It runs some of the same things, but it doesn't run the .bashrc, for example. And my laptop is a System 76, and it comes with Pop! OS, which is a version of Ubuntu. I've since switched this to Fedora because I really do prefer Fedora, but when I first was using this and trying to get used to Pop! OS and just try it out and see what it was like, I checked that to make sure that, to see what the login shell and the non-login shells do. It's different. So that's one of the reasons why it's kind of irrelevant for me to go into the details of that picture before, that graphic, because it's probably different on your distribution, okay? So I just put in those commands to print out what shell program is, configuration program is running at any given point in time, so you can see the sequence. If you're having a problem getting your bash shell configured, that's the way to figure out what's happening when, okay? And then the best place to put or fix whatever's going on, okay? I hate typing, and yet I've written a few million words over the years, kind of not exactly one finger, but kind of 2.5 plus a thumb on each hand. And yeah, I see some smiles out there. So I'm not alone in that. But my objective is to be the lazy sysadmin, and one way to do that is to reduce the amount of typing I have to do. And I think all sysadmins are lazy sysadmins, even those of you who don't have that in your job titles. And so I use aliases for that. We saw actually that earlier this morning. And aliases are just a way of expanding. So if I type Vim at the bottom here, this is one that I added. I don't want to type -C : color scheme desert every time I start Vim. So if I type Vim, the alias will be expanded to that command, okay? And that's the same with all of these. For example, Glances, which is one of my new favorite monitor programs. And this just, I don't want to type --T1. That's just too much typing, okay? So I type Glances, and this alias expands it so that it updates every second. That's basically your time for refresh. Command line recall and editing. I did that a little bit in the other screen where I just did the up arrow and went back and used commands that I'd previously typed in because it's really clumsy. I'm so clumsy at the command line, it's really hard for me to type while I'm trying to talk up here. So I can't type and talk at the same time. So this presentation is a lot faster because I'm not typing at the same time. I also like to change Emacs mode for Bash, which is what the editing structure is the Emacs mode. But I like VI mode because, like I say, I'm familiar with VI. I started editing with VI years ago. Bless you. And even though I could probably learn it if I really wanted to, I like VI anyway. So I just change everything to VI mode. And the details of all that, it's pretty simple. Some of that is in the resources at the end. Tab completion, how many of you are familiar with that? Is there anybody who's not familiar with it? Okay, y'all know what that is, and it's just basically enabling you to type enough of a command to make it unique, and then press the tab key and it completes automatically. And it can be applied to the host names, to file names, directory names, program names. This is fun, the expansions. These are very useful tools, and I've used some expansions in various Bash programs that I've written over the years. It's a really cool way to reduce typing, and it gives us some really good logic that we can use in our shell programs. There's 7 types all told. I'm going to quickly look at 5 of those. The tilde expansion, that's just basically a short name for your home directory, whatever that might be. In my case, it's /home/d both. And it looks at the $home variable in your environment. Brace expansion, how many of you are familiar with that? Okay, a few. Well, this is what brace expansion can do. It basically takes a series of strings and creates a name that's individual out of each of those. Okay, so that's going to look like this. It's easier to show it than it is to explain it in this case. Okay, does that make sense? Okay, the next step is something like this. Okay, to create names of test files. And that's what that looks like. And then, who knows what this is going to do? Exactly, with a bunch of other stuff too. But yes, it's going to create files. The touch command will create the files for us using these. I've got 1, 2, 3, 4 expansions in there. Okay, and it's now created a bunch of files. How many do you think were created? 3 times 200. Yeah, 14,472 files. Okay, so just can you imagine trying to create that number of files one at a time by typing their names all in? Not me, okay? This is a really good way of shortening the amount of time to do something, as well as creating a lot of opportunities for creating large numbers of files or file names, whatever. So what this is going to do, this is just going to show us some of those files, and I can scroll down and just quit out of that. That's just less. This is going to show, okay, here we start with file globbing. Okay, we've got 2 different file globs there. This is going to show us all of the files that start with R, have something 05, and it doesn't matter how many characters there are where that star is. But then it's going to also have, after the 05, one space, one place, and it doesn't matter what's in that one space. That's what the question mark does. It just says, okay, I'm going to match anything in that one column. And then everything with a .txt end. So that's kind of what that looks like. Okay, out of 14,472 files, we selected those using file globbing. Command substitution, this is fun too. Everybody know what command substitution is? Does anybody not? It's okay if you don't. It took me a while to figure this out, but I use this a lot of times in generating loops. Instead of something like this, typing each item that I want in that loop in a for command, which comes out like that, I do something like this, which is use the sequence command. And that just says simply give me a sequence of numbers from 0 to 50. And that list of numbers becomes the list that is used to set the value of the I variable, okay? And that looks like that. Of course, I've specified that it's not going to do vertically but horizontally by eliminating the line feed at the end. So here's arithmetic expansion. Basically, in this case, I'm just creating a little simple calculator. It says 1 + 1 is 2. One thing about Bash, Bash does not do, it only does integer math, okay? It does not do floating point, okay? So it's good for some things, but not so much for others. The things like calc can be used for that if you need integer math. But then we can do something like this. We can assign those variables, and var3 equals var1 times var2, and then we echo the results of those variables, okay? So arithmetic expansion, like I say, it's limited, but I find it useful occasionally. Functions. How many of you know what a function is in Bash? Okay. It's basically a function name with a pair of empty parentheses and then a list of commands. Do you know what this does? Anybody know what it's called? Fork bomb. That's right. If anybody wants me to explain that, I'll be outside, and you can come and talk to me then, or find one of the other people that said they knew what it was, okay? But bad, don't do it. And this is a simple example of a harmless function, okay? Just basically the function name is HW, and it just echoes that string, and then the last command on that line calls that function, okay? That function is now still in memory, okay? So when you create a function like this on the command line, it's still in memory. And like I already said, don't do it. If you do it, your computer will come to a grinding, screeching halt. It won't be as showy as on TV, okay? No sparks and explosions or anything like that, but it'll be just as bad. Return codes. Return codes are a really important part of Bash programming, and a lot of times I use the return codes directly, but there are some commands that automatically use them without me having to intervene. The return code of 0 always equals success. Anything else is a failure or an error in whatever command was issued. For example, if I try to change directories into the temp directory and then echo the question mark variable, which is what holds the return code from the previous command, I'll get that, a 0. That means it was successful. And even though my fake command line down there doesn't show that, it actually is in the /temp directory. Now if I try to change directory to root, because I'm not the root user, the change directory command shows permission denied, but the return code is 1. Okay, that's on the second line there. We can use those return codes in these things called control operators, double ampersand and double vertical bars. How many of you have ever used those? Yeah, quite a few of you. So you know then that, let's just dissect this a little bit. I'm setting the name of the directory, the dir variable, to testdir, and then I'm doing make dir $dir and echoing the result. If it's successful, we get what's after the double ampersand, which will be a message that says directory created successfully, and if it fails, which is after the or there, it's going to say error, directory not created. Well, that was created successfully, okay? Notice that one of the reasons you might want to do this is that when things are successful, by and large, Linux follows the Unix tenet that silence is golden, okay? That is, if the command you issued works, don't say anything. So, Mike Gancarz, read his book, Linux and the Unix and the Linux Philosophy. Mike Gancarz. Now, I changed the value of the dir variable. In this case, it's now going to say the directory is /root/testdir. What do you think is going to happen? It's going to fail, right. So we get the other message. Permission denied is provided to us by the make dir command itself, but the error message that I created is now shown also, because that was in the segment of that little command line code that occurs when something fails, because we got a 0, or a 1 for a return code. Okay, real admins don't sudo. How many agree with that? How many disagree vehemently? Or maybe not so vehemently? Okay. Well, you all saw me actually use sudo a little while ago, right? So, yeah, you know that I use it. But I read an article by this title, and I thought it was actually a good article, and then I had written an article previously that real admins don't sudo, and I decided that I really needed to look at this again for a couple of reasons. One is because Seth Kenlin, who is he's an editor for opensource.com, which I write for frequently, www.opensource.com. And he's also the technical editor for at least 2 of my books, and might be 3. But he kind of called me to task on this, and he said, yeah, there are some really good reasons for using sudo. So I looked at it again, and yeah, there are some good reasons for using sudo, but let's look at some of the bad reasons first. One is that some of the distros like Ubuntu force users to use sudo for every administrative command that requires root access. First of all, that is not a lazy sysadmin type of thing to do. I find those extra keystrokes are slower and they take extra typing. It makes me less efficient. Users can make the same errors, but it just takes them longer to make the same errors. And then it takes them longer to fix it once they've made those errors. So, and in my opinion, this is my opinion, it makes your system much less secure because anybody, if your sudoers file is incorrectly configured, a lot of people can do things that they might not ought to be doing. But there is a good thing, a good sudo, and I think my time is coming to a close here, but this allows user limited access to programs that require root privileges, and that's why I used it, because the bash program that I'm using for my demonstration here is run as me, and I don't have root privileges, so I needed root privilege for that dd command. Okay, so that was just a way of giving myself that elevated privilege for one command. And I'm going to skip ahead a little bit and just say, automate everything. Okay, automate everything. Here's the resources that I told you about. This is going to be available from my own personal website, the one at the bottom, this whole, the tarball for this whole session. I need to do some updates and get it put up on my website, but it's also going to be on the OLF website once I get it updated and sent back to them. The Bash man page is also a good place to get a lot of good and interesting information about how it all works, but it's not really a tutorial. Okay, some of the other resources on the previous slide are going to be better for that, so that you'll be able to learn rather than just see the info. Oh, that is on Rails, but it's not Ruby. More fun stuff that, there was some stuff I really wanted to do, but didn't have time for. So thank you, I appreciate your time.
Well, big hand to David. Unfortunately, we're out of time for questions, so if you have any questions for David,
I'll be out there.
Or want to debate him on the use of sudoers, look for him outside of the room.
I look forward to that, and I'll be out there also during the happy hour tonight.
So debate sudoers over drinks. That sounds like a worthy discussion to me. I will be on the other side of the room while you're having that discussion. I'm pleased to introduce our next speaker. Our next speaker is Tony Bemis, and Tony is going to be talking about how to secure IoT devices by not being on the cloud. I'm really excited for this presentation. Big hand for Tony. Well, while Tony's getting set up, our fine Mad Dog will be sharing a bit about his BOF tonight.
Hello, ladies and gentlemen. We have an old farts BOF tonight. Everybody who is an old fart is welcome to, I'm not looking at you for any reason, is welcome to join us. You don't have to sign up for anything, and you can leave when you want to. But this is just some people talking about some old things that we've seen from time to time. And I've done this for students in universities, and they go, "You got to be kidding me. You did that?" Yes, we did. And so if you'd like to come and speak and talk about your experiences of 15, 20, 25, or 50 years ago, you're welcome to. And if you'd like to learn about some of this stuff and think about what it means in terms of today's technology, you're welcome to do that too. Thank you.
Thanks, Mad Dog. That should be a lot of fun. Good to go, Tony? Tony's taking live demo to a whole new level.
If we're going to do IoT, we got to be able to.
Are the lights going to go on and off?
These will, not these. They said it's automatic.
Oh,
It's turned on. You probably just have to turn it down.
Okay.
Test, test, test. There we go. All right, everybody can hear me now, right? I can hear myself. All right. So, do we have anybody that likes Raspberry Pis out there? Yeah. Anybody upset that we can't get any more Raspberry Pis? Are they very hard to find? Yeah. Yeah. So today's demo, I'm going to be running Home Assistant on a Raspberry Pi 3, and that's Pi 3 because I can't get anything else right now. It's just an old system I had. And if this live demo doesn't work, then I'll VPN into my home and show my home one. Or I might even show both. Let's see. I'm not sure if my battery will last an hour, so let's make sure we're plugged in. HDMI. Uh-oh. Is there an adapter for this HDMI? Because it's too close to my hinge, and it won't plug into my HDMI because that thingamabobber on top here. Guess that's what I get for trying to use a system so old as mine. All right. All right, while we're doing that, I guess I'll plug in a couple lights. So I guess I could chat a little bit while we're waiting for the cable to be replaced. Anybody here doing home automation? A little bit, yeah, yep. So there's a lot of different protocols out there with all the different stuff coming out. And one of my pet peeves is that the box will all say Wi-Fi, even though it's not networking or not Ethernet or whatever. So I'm like, no, what is the actual protocol? So you have to pick up the box, read through the whole thing multiple times, and then you finally find what it's using. All right. I'll get into it as we are talking, but my favorite is Zigbee. Anybody else use Zigbee out there? Yeah. You know, there's a few caveats, and I'll get into it during the call, or during the talk here. But that Zigbee, there's a few things you can do, and it's rock solid. But other than that, if you kind of just try to not do it that way, I guess it could be an issue. All right. Okay. Yeah. I think after the login, it'll detect the monitor. Do, 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 do. Right. Ooh. Is it gonna? Maybe. It's a SSD, but it's a almost 10-year-old laptop. It's a i7. Normally works pretty good, except for when you try to plug in to do a presentation. All right, let's see. All right, let me reboot once again to see.
Should I just unplug it and let you boot up all the way and then plug?
No, it should be fine. goes. Ooh, all right, let's see. Oh, does it not like, oh, there it goes. All right. I think that'll be all right. All right, thank you. All right. All right, here we go. All right, so as the introduction was, I am Tony Bemis. I've given a talk here a few years ago. I'm from Michigan, so I've talked a little bit at PenguinCon also. If you're, yeah, it's not too far away. It's probably about 4-hour drive from here. So if you're from Columbus, PenguinCon is a great convention to go to also. And it's in the spring, so it's almost a perfect like 6-month back and forth. So you get all your Linuxes in. Okay, so today I'm going to be talking about secure your IoT by taking it out of the cloud. And IoT, right? So what is the Internet of Things? It's basically what just devices plugged into the internet doing things. A lot of times they're little single-purpose devices, so light bulbs, temperature sensors, but it can be things all over the world. It could be, there's industrial uses of it, but what we're going to be talking about today is home use. So a lot of the home automation and light bulbs, sensors like that. So when I talk about security and home automation, you've got to weigh the convenience versus the security, really. Because if I think about, you want to make it easy, usually you take away some of that security. And my idea of security is a mix, right? I think of like a couple different things. Is security of your device itself, of your home network, but then also security of your data. And if you're going to be in the cloud, then you're going to have some of your own personal information in there. And you may not think, oh, it's just a username, it's just a password. What are people going to be able to do? Turn lights on and off in my house if they hack into my account? Maybe. But they can also look at when you're turning lights on and off. They can get a profile of when you're home and when you're not. And there's other ways of attacks that you can try to destroy devices, your heating, cooling. I would say more of the modern device, IoT stuff like your thermostat, it's not going to hurt or break your furnace, but it might make your house hot for a while. And that's some expensive heating. And then they can take that and they can sell it off, right? So data leaks, and if you're in the cloud, you know, and there's an attack, then you're going to be, you know, somebody could take that, try to sell it. They're going to compromise the devices itself. And what they do is that you could take that and then turn your light bulb into a part of a botnet, and then start triggering DDoS attacks, and your light bulb is part of that. So I would think the best way to do that, make sure your light bulbs and your switches and your stuff can't get out to the internet. So to control it, you want to be able to control your device itself, right? So limiting internet connectivity, you can self-host it. So having, and I'm calling it self-hosting, just a Raspberry Pi right here can do that, right? It's just a small little computer running an operating system, running software that you want to run on it. Taking it out of the cloud. And some of that, you have to be able to patch your firmware. You have to be able to limit the internet connection or internet access that your devices has. So then you might need to run a firewall, something that you can maybe let it out to one or two places. So it gets, we're getting back into the security. Convenience is getting low here, but security is getting pretty high. And we want it, so we're pulling it out of the cloud, we're pulling it out of the big data, we have more privacy. So with replacing the firmware, there's a couple options you have. You can, if it's an ESP-based device, like ESP32, then you can put things like ESP Home or Tasmodo on it, or Tasmoda. You can use communications that don't connect to the internet at all. So things like Zigbee and Z-Wave. And then you have your hosting it itself with you know, what you want to put on the device or on your own server. You have Home Assistant, there's a Mozilla Web Things, and OpenHAB. The Web Things is a pretty new project. I say new. I was running it about a year and a half, 2 years ago, and it was just kind of getting there where things were working. And then Mozilla handed it over to be a project on their own. So at this point, it's just Web Things. What I like about Zigbee and Z-Wave is that they are local. They don't connect to the internet. It uses their own protocol, and it's a mesh networking setup. So I can have my hub here, and I plug in a little USB device, and this can do the the Z-Wave or the Zigbee, and then it connects over to a light bulb. And then, say I have the light bulbs in the same room, should be able to communicate fine, right? It's 2.4 gigahertz, no big deal. But then I have something that's on the other side of the house I want to be able to control. Well, instead of having multiple hubs, you take another device that's always going to be connected to the power, like a plug, a light switch, or a switch. Put that somewhere in between, then it starts mesh networking and then expanding out so that you can always have connection. So I ended up going with Home Assistant. And Home Assistant I really like. It's because it lets you do the self-hosting easily. It's all the local communication. You don't have to let it out to the internet if you don't want to, but there is a lot of internet-based features. So if you want to give it some internet connection, then it gives you the medium that you control what it does. And I really like that. The multi-vendor, multi-support, or multi-protocol is really nice. because I can take a Zigbee device, I can have Z-Wave devices, I can have multiple devices on my wireless internet or my wireless network, and it'll go through and find those for you and help you configure them, or you can turn that option off and do it all manually. Then there's community support. So what they do is, within Home Assistant, you can have a lot of different plugins and add-ons. And there's official ones that Home Assistant develops and supports. And then there's community-based ones that is called HACS, H-A-C-S. And then you can take, and that will expand your Home Assistant even further. The two ways to be able to install Raspberry Pi, or Home Assistant, is either on your Raspberry Pi or in a Docker image. So you can run it on a small, lightweight hardware, or if you have a server running Docker, you can put it in there and give it all the horsepower it needs or you want to be able to do additional things. My setup at home is running Raspberry Pi 4, and I have about 50 devices on it, and it's smooth sailing. So we have a mix of devices, we have a mix of automation. So whenever one thing happens, it does something else, or you could do it like at a certain time. We can do this. It has options in there that when the sun is down and you see motion, then you can turn on the light. So I have my backyard is the light will only turn on after the sun has gone down. So that's really nice. So if we look at the screenshot I have here, this is actually what I got off of the install, my Raspberry Pi 3. This was sitting on my home network, my IoT network, and we can see that it auto-discovered hardware that's on the device and other things in the network. So it has built-in support for Google Chromecast, for some to cloud devices. It can do, it sees it says Conb 3, and that's my Zigbee dongle. Then it has a few other things that it went through and was able to put in there. The Philips Whiz has built-in support, so you don't even have to do any configuration. It just pulled them right in and gave you as light bulbs on the Wi-Fi that you can use. If you were to buy them new, you'd have to use the Whiz Light app to set them up first to get them on the Wi-Fi. And then once it's there, then you can bring it into Home Assistant and automate things, control it from there. But so with the Tuya, those are the really cheap IoT bulbs and plugs and stuff that they require you to go through their cloud. And if you find out which version of the hardware it's running, you can see that it uses either an ESP device, or they might have changed it to one of their own chips. You've got to be careful when you're buying those things. But if it has a ESP device or a chip in it, then you can replace that firmware, and then you don't have to. You're not required to use their, their cloud, which is really nice. And what it is there's it's a script that you run on your computer, and it actually does an attack against the light bulb. It knows an exploit that it can get in there and then replace that firmware with Tasmota. And then with Tasmota, it doesn't have any kind of connection out to the internet. It's all local. Just like I was saying, local communication is really the best, right? You've got Zigbee, Z-Wave, Wi-Fi networking, and then MQTT. MQTT is like a messaging system that is built into Home Assistant, and there's many other ones, or sometimes you might call it Mosquito. And that's a method that it can send information about what it's doing and then receive information. So all my Tasmodo devices are all using MQTT to communicate back and forth. So when we flash the device, there's two ways. There's the TUIA convert, or over-the-air kind of firmware update, or you might have to bust out a serial to USB and actually plug it in or connect it to the chip itself. But then you can replace that firmware. And so here's a couple screenshots of what you see. So the one that's a little bit higher, that's a light bulb. And you can turn the light on and off. You can make it brighter or dimmer. You can, and if the bulb supports it, you can do the temperature change on it. You know, make it like more, it's in Kelvin, so I don't know, you know, it makes it really bright or make it soft lighting. Then there's the different options for for communication to your Home Assistant or whatever you're going to use to control the device. MQTT is the common one for Home Assistant. There's also the Dometics built in. I haven't used that one, so I don't know much about it. But it makes it pretty simple. All right, so let's do a little bit of demo here. All right, so what I have set up here is I have just a cheap home router, and it gives me Wi-Fi. And then I have a little dongle here that'll give me internet access. So I'm connected to the hotel Wi-Fi, so we're getting internet. And I have my Home Assistant is wired, plugged in. And then everything else is either going to be wireless on the network or it's going to be Zigbee. So I have a light strip here. And this is set up with Zigbee. And then I have a little Node MCU device, and it has a temperature sensor on it. Node MCU has the ESP chip on it. This is an ESP8266 with Wi-Fi. It's actually pretty old. I was trying to write some Arduino to run on it, and I just couldn't get it to go right. And I found out that Tasmodo will run right on it. So I was able to do a simple firmware update with the USB device, or USB to serial. And then now, within, I would say 15 minutes, I had it on my Home Assistant. When it took me, I was trying like months and months trying to write a Arduino program to run on it, just to report the temperature. All right, so with Home Assistant, everything is web control. So by default, their dashboard, or the main screen that you log into, is it's going to work? Okay. It's what they call Lovelace. Oh, okay. The TV is going weird, but the screens are good. All right, that's good. All right, so they call it Lovelace. And what they do is they have like an auto-generated dashboard. So anytime you add a device, it automatically throws it on here. So that can be handy. Somebody that just wants to get something up and running and play with it a little bit, it's super simple. And what we can see on here is that we have devices that are in the ballroom. So that's the room we're in right now, right? We can see that there's a temperature sensor, and it's 66 degrees, at least up here at my table. That's why it's chilly in here. It gives us the humidity and the dew point. There's also, we don't have to worry about the TV, it's fine. We have a couple light bulbs and light strips, and you can click on here to turn them on and off. So my light strip is turning off here. I have a light bulb down here. This is running Tasmodo. And I can turn that on and off simply. You know, and then you think, well, it's it's running Tasmodo. Let's see if we can get to the home screen for that. So 10.0. See, was I think it was 2 or 3. Yep, there we go. Oh no, so this is the temperature sensor. On my router, this is not what I run at home. It's so cheap that you can't set any kind of dynamic DHCP or anything like that on it. But with the temperature sensor, it's given us here the temps in Celsius. You can go through and change that by a couple commands and tell it to be in Fahrenheit. But let's go back and look at Home Assistant. It's already done the conversion for us. So we don't have to get into the device and tell it what to do. So it's simple. We have another one here in the middle that it says sensor, because I guess Home Assistant, I didn't give it a good name. But this is a plug. It's a smart plug down here, and nothing's plugged into it right now. Here, let's plug in that light bulb. And then we should see that now we're getting a little bit more information. We're using 3 watts of power to light up that light bulb. So if I turn that off, then we should hopefully see the wattage go down a little bit. Now it's using 1 watt of power with it turned off. I mean, a little demo like this, you're thinking, what is, that's funny. You can look at it and see how much, but you can actually turn things like this into automations. So you can say, you know what, when my device is using power, I want it to do something else. Or I want Home Assistant to tell my home speaker to give a notification. So what I have set up at home is when I start the washer, then it thanks me for starting the washer. Yeah, it's funny. I'm starting it. I'm starting the wash. But I'm thinking that helps a little bit with spousal approval. When my wife starts the wash, it thanks her also. Anyway, so I have one for the washer, I have one for the dryer. So that's running Tasmodo also. So we have, let's see, this was 10.2. That's right, 10.0.0.3. Yeah, here's my smart plug. So it's also showing here what the voltage is. So we're getting 116 volts. I think anything above 110 is safe in the US here. It's showing 1 watt of power, just like we saw on the other. If we go, let's see, 10.0.0.4. And here's my light bulb. So I turned it off within Home Assistant. And go in here and toggle it, and we can turn it back on. It's pretty dim right now, so let's turn that up. Oh, that's changing the temperature. And then here's turning it brighter. And we can do all the same right from within Home Assistant here. It's the same brightness, temps, and it's giving us the value that it's going to change it to. And you can see the numbers that as I'm turning it down, that's in Kelvin. So if I turn it down to 2000, then it gets like a warmer light. Or if it's wintertime and you say, I need more like sunlight beaming at me because I'm in the basement every day, then we can bring it up brighter and make it feel like I'm not getting depressed. So this, like I said, this is the main screen. We have, or one other thing that we have in here, is see the A and the T at the top? Those are users. So you can do user tracking, or when you could be tracking, like when you come into the house, your phone connects to the Wi-Fi, it says, hey, and then you can have a notification say, welcome home, sir. So it's a lot of fun. Or you can do your more custom dashboards. So we have here, we have the temperature sensor, lights. This is more what I would go for, because the other one, I don't need to know every single device or every single value coming off of the switch. So then I can limit this down. We're using 9 watts of power to light up the bulb. I cranked up that light, didn't I? So that one's using Tasmodo. I have another bulb over here using Zigbee. And it's, you know, it just works. You can see right here that, that it's grayed out. It means I can't use it right now. So it can tell that it's not on, you know, you can't connect to it. But if you could bring up the brightness and the dim, things like that. Going in, looking at some of the things we can do to change it, it automatically tells me if there's updates. So that's a simple way to update it, keeping it secure. There is a cloud component if you wanted to. You can, I think you pay a little bit of money and you can have it where your phone can connect to it anywhere. So you don't have to set up a VPN to be able to get into it. So it makes it a little bit simpler, a little bit easier. But I don't go that way. I want to keep it extra secure, just keep it local to my house. And then under devices here, this is where we can go through and add in extra, you know, this is where we can add in our devices. We can add other integrations. We have, you can see right here's the Conbee. This is the Zigbee adapter. And under devices here, we can see that there's 3 devices. So we have a light bulb, the light strip, and then it says the coordinator. That's the actual USB device that's on it. We can also go into the settings, and we can set up automations. Now, this one being the demo one, I haven't set up automations in here, but it could be set up where if you say, when you turn on one light, turn on another one, or you can turn off. I find automations are more paired with motion sensors, really nice. So now at home, I walk through my basement, and as I walk through the basement, it detects motion, it turns lights on and off for me. So I don't have to hit light switches. Anybody use the Mycroft or have one at home? Or how about Pycroft? So Pycroft is Mycroft that you can install on a Raspberry Pi. You can set up your own home or voice assistant that you could talk to it. And that's actually what this was, my Raspberry Pi is my Pycroft before that. And there's the integration with Pycroft into it. So then you can talk to it and say, you know, hey, Mycroft, turn on the kitchen light, and it'll turn it on for you. All right, let's look at my home one, and we'll get a little bit more to look at. And connect to my VPN. And is this where my live demo is going to fail on me? Maybe. All right, here we go. So I have, you can set up different dashboards. So we have one that's called Overview and one that's called Lights. The lights one I use because I have a tablet hanging on the wall of my house that my kids can walk up and start hitting lights, changing the colors, and then there's party mode. You can hit that and it automatically starts making all the lights rotate through all the colors. It's like we're having a rave at our house. I'm automating the Christmas lights. You know, if I had my camera at home turned to the lights, I could show you my Christmas tree turning on and off. But if I turn that on, then we can see that with the light bulb, or the lights on the tree itself, here in a moment it'll tell me how much wattage my tree is using at any moment. And, you know, so other lights you can do let's see. The exciting stuff is on the main overview. That's where you can have a thermostat. So I can turn my temps up and down just like a Nest, but local. That's where I have my washer and dryer. I can tell if my washer's running at home. This is really interesting. I've never had to do this before. Let's try something. There we go. All right, so we have the thermostat down here. So I can turn up the temp, I can make it air conditioning, I can, heating, cooling. And with automations, I can have a button that when I hit the button, or I can do it from my phone, and I can say, you know what, we're leaving for the weekend. So I hit the button, it automatically drops the temp in the house down. And then when I'm driving home, I said, you know what, I want to bring the temp back up in the house so I can turn it on from my phone. Because I'm connected to my VPN, then I can turn it back on and it brings the temp up before I get home. So we can save a little bit of power there. And then I set up this temperature graph here. And I wanted to be able to watch to see like how long the furnace runs. I was using it more with air conditioning in the summer to see how much power I'm using, or if I have the temp drawn down a little bit, am I going to use more, or how much more does the furnace run? And we can see that for every couple hours, the furnace runs for that long. Like we could say from about 6:07 to 6:45. So it runs for roughly 40 minutes for multiple times. So this is a 2-day. Is it 2 days? No, 24-hour period here that we can see how many times it runs. So if you want to be able to, get data on your house itself, right? I don't know how much you can do this without having some kind of sensor you can track it on. When I have my temp sensor at home, then I'm tracking my temperature in the garage. Is it cold out there? Should I be making some kind of changes to, make sure my pop that I have sitting in my garage isn't going to freeze overnight. Bring that in. And then one of the other things that helps with spousal approval is I have my firewall hooked up through Home Assistant, and I can go in and turn on. So I have specific rules that I have allowed through that I can either turn on or off. So if my kids aren't listening, doing their homework, I can say, oh, no more internet for you. And I can stop the kids' internet right now. And then it goes through and puts on that rule and kills it off. I have separate VLANs. So I have an IoT VLAN. So if I have something plugged in that needs to get DHCP to get out, then I have a rule for that. Right now that's turned on. And it was because I was doing the setup for this. But I'm not home. I don't need that turned on. So that's going to be turned off now. I could log into my pfSense and do that. But my wife doesn't know how to get in and turn out rules on and off. But now she can do that also. We can do it. And what's also nice is that with the users, you can set up permissions based. So this part of the dashboard, only my wife and I can get to. My kids can't see it. So that tablet that's sitting in the thing, they can't get over to a different screen and start turning their internet back on. I can say, oh, no, no, no. So they're actually doing really good right now, so I'll give them their internet back. Well, yeah, and I think they're still at school, at least on the way home. So nobody's really at home. We can get a good sense of what's going on with some of my automations and my motion sensors. Yeah, we can see that all the motion sensors either show clear or one is unavailable right now. So with those clear, it means there's nobody moving in the house. So it's safe. And you're like, wait a minute, if I have motion sensors all throughout the house, I should be able to turn on and have it notify me if it sees motion. So it's kind of like a poor man's security system. So I have that set up also. And to be able to turn that on and off, I'm like, oh, I don't want to pull my phone out to say turn it on when I'm leaving and then turn it back off. So I have RFID tags around the house that just a little circle thing. You can get like 30 of them for $5 off of Amazon. And I tape it to the wall or to the door frame as I'm leaving the house. So I grab my phone, I tap it as I'm going out, and then it enables that, that automation. I also have it turned on, so I'm like, you know what? I have it enabled, so it turns my garage door off. So if somebody happens to have gotten the code for the wireless, then it turns the power off to the garage door opener, and they can't get in my garage either when I'm gone. So it's simple, you know, just little simple things here and there that all blends it together. Now, and I say simple, these are really basic automations that I have set up. There's other people, you go on YouTube, and there's all sorts of dashboards that people have set up and automations that are really, really neat. I just haven't had the time to go through and set up most of these, or to buy all the hardware for it. There's one of the podcasters I listen to on the self-hosted podcast. He has a RV, and he has Home Assistant running in his RV, and it's going through and checking, because he does a lot of boondocking or camping without power. So he has a solar system, he has batteries. It's monitoring all those things. And if the battery level gets down to a certain point, he has it turn off the plug to like the toaster and things like that, so that it doesn't use up power, you know, or you don't accidentally start a toaster and it kills the rest of your power. It's kind of interesting. So I have the hacks turned on, or added in. That's what I was talking about. And there's a few, you know, integrations you can add into here. And I say a few, there's thousands. So if you have a device that may not have been part of the Home Assistant by itself, then it'll add it in. You can go here, somebody else has built one. Or if you say, you know, that thermostat card was kind of nice, but I wish it did this instead, then maybe somebody has built something like that, and you can search through hacks, and then it'll go through if you find it, and it'll be like, oh, there we go. You know, like for my Whiz light bulbs, there's an extra automation for that, or add-on for that. Fully kiosk browser, that's what I use for my tablet. It's an old Amazon Fire tablet. It actually has a broken screen and everything. My kids won't use it. So I'm like, well, we can make that my thing in my house and make it easy. So yeah, anybody got questions? Yeah.
Awesome presentation, Tony.
Thanks.
One question that I had was, like you mentioned that you have your lights on motion sensors. Spousal approval would go down terribly if suddenly your Pi crashed.
Right.
You couldn't turn on lights when you walk into the room, so is there a way to do a backup?
Sure. Yeah, he's asking about motion sensors walking through the basement, have it turn on and off. And what are the backups? Because say if the Raspberry Pi crashes, or for some reason, you know, it's not working. So what I have is on the light bulbs itself, you can have it where if you turn the power off and then turn it back on, it automatically goes to the on state. So we got switches still. We can walk around and just turn on the switches. So you can change the default state of the bulbs itself to help with that. There's other ways with Tasmodo, and you can have device groupings. And so for the case that Home Assistant's not working, and say you have a Tasmodo switch and a couple lights and stuff, you can have them just talk to each other and flip things on and off, and that'll work. But I think for the fallback, I think the default option is really the best way. Because say if even your Wi-Fi goes down, then all of a sudden all your lights are, you know, nothing's going to communicate. So then the default, just the old-fashioned light switches are still going to work for you. Yeah.
So I've ordered a Home Assistant yellow, and it's coming my way. But in the meantime, I've been using Google Home for a lot of stuff.
Okay.
One thing you didn't mention was the amount of data that Google Home sends from something as innocent as a light bulb. It's a huge amount of data. I don't know what it's doing because I haven't taken a chance to look at it, but you know, it's a huge amount of data. But they say right in the literature, if you have more than like 20 or 30 devices in your house, you may want to think about splitting your frequencies and stuff, putting all that on 2.4 and the rest of the stuff you really want on 5.8.
Yeah. So what he's saying is if you don't have the hardware, he can't get a Raspberry Pi, or he's ordered a Home Assistant Yellow. What that is it's a device you can order straight from Home Assistant, and you're supporting the project. But there's a little bit of shipping delay on those. And so he's using the Google Home Assistant, or Google Home at this point. And there's a lot of data that's going back and forth, even when it's just sitting there, a light bulb that may not be on or off or whatever, and there's still, it's communicating back and forth. A huge amount of data, yeah. And I've noticed that with my, Chromecast devices, that you can set up within the Google Home app, you can set up like sound groupings or speaker groupings. And you want to be able to, I mean, I guess it's a little different from your case. I haven't actually tracked how much data is going out. But if you have something like pfSense, like I'm running pfSense, then you can go through and start tracking some of that and see what it's doing. But what I found is when Chromecast is talking, it's very chatty. And when you make that grouping, Home Assistant will see that as one, as another Chromecast device, and you can cast to it. But it is taking down my network every time I do that because they're so chatty, and it's all on 2.4. So at this point, I have like 50, 60 devices on this one radio, and I start trying to play some music to those devices, and then all my light bulbs drop off the network. And it's actually Wi-Fi. Like I go into my unified controller, and they're all just not there anymore. Like they've all disconnected. And it's because Chromecast is very chatty and causing issues.
If you're using any other type of thing in the 2.4 spectrum, that can also interfere with it, right?
Yeah, anything in the 2.4, microwaves. The microwaves are really common for disrupting Wi-Fi.
Types of remote telephones, wireless remote telephones, also 2.4.
Right. Yeah, and Zigbee is in that same boat. It's also 2.4. So there could be a little bit of clash there. So you got to be, I don't know, that's where some people start using Z-Wave instead. They're a little bit more expensive, but you go from the 2.4 to 900 megahertz. And so they might connect a bit better for you.
Yeah, I think
so it's a little bit of a trial and error, yeah. I got a little bit of. Do I have a dashboard for my Desmoda devices? Yeah. Are you dashboarding the energy usage? I'm not. I don't have a specific dashboard other than right now we can see that whether it's turned on or off. But what you can do, and what's nice in Home Assistant, is that you can go into your history here, and you can say, I want to see my dryer. And let's say let's see, how long has it worked in the last month or so? Sometimes. That's exactly. So we could say, oh, you know what? In the last month, I've run my dryer 6 times. And we actually, you can see a couple, maybe it's 8 times. Like these, I mean, we've been there. We do laundry and groupings. We'll do like 5 loads here, 5 loads there. So if we were to strip this down, we could see maybe each one of those has a little bit of gap in between. So you can do ad hoc dashboards like this. You can look up the items. You can create a dashboard just for this kind of thing. And like I said, there is the energy tab, and it's kind of neat if you have the stuff to run it. I don't. So in Michigan, we have, and I live in the Detroit area, so we have DTE as our power, or our energy company. And they have this little device that you could plug in, and it connects to your network, and it's actually an MQTT broker. So we're talking about MQTT as a way to communicate back and forth. At one point, I had my Home Assistant grabbing information from that, and I could tell how much power my whole house was using, and that was really neat. But then when I started using Tasmodo, Home Assistant only allows you to use one kind of broker or the other, and so I couldn't use them both. So I'm like, you know what? I'll figure out something else later. So I went with the Tasmodo devices over my Energy Hub. But there's other things you can use, and like I say, the power or the energy usage data has to be formatted a certain way for it to automatically pull into this energy dashboard. So if you have the devices or you set it up correctly, then it's a really cool thing. You go on YouTube, there's all sorts of people that are using it, and it's really neat. They have, then the device, what I really want to get, is the ones that has a bunch of little CV clamps, and you can put it on your power fuse box or power box, and then you can watch the power usage for each circuit in your house. And that'll bring it into Home Assistant. There's certain ones that work with Home Assistant, so do a little bit of research. Yeah. How long does it keep the data? Yeah, it's configurable. I went with whatever's the default, so I'm not sure how far back we go. Let's see, I think it has to be a current device to be able to look back, so my DTE device is no longer connected, or I took it out of the system, so it won't show up in here anymore.
We have a question back here.
Yeah.
Have you tried running Home Assistant on like VMs, or have you played with that at all? And if so, what like good, bad have you seen from that?
I haven't, but like I said, if you want a lot more power, run more intensive automations, then that's really the way to go. Run it, and don't run it in a VM. You run it in a Docker image. So I suppose you could have a VM that's running Linux, that's running Docker, and run it all in there. So it depends on your system. What I want to do is I'm going to change my my TrueNAS over to the new version that you can run Docker images on it. And then I was going to start testing it there. I just don't have a system right now running with Docker, or haven't had the time to put it all together yet. But what you can do, and I've looked into it a little bit, is you can do a pseudo federation with Home Assistants, where they do MQTT back and forth. So you can get communication. So I can have my, I can have a Raspberry Pi with a couple of the USB devices here in one part of the house, and you can have the Docker image running on a server in the corner of your basement, and you can get them to communicate back and forth. So that would be neat. I was also looking at a way, it's like, what if I put this into my dad's house? And then I can control it from my Home Assistant at my house. That would be a neat way. You'd have to set up a VPN and everything to get the communication back and forth. But I have heard that it runs really well across WireGuard. And I'm doing OpenVPN to connect to my house right now, so it works well that way also. Way in the back.
Home Assistant has an ISO you can download and install it directly to a VM, or I have it running on a mini PC.
Oh,
and
really?
It runs fantastic.
Is
You
that
just have an ISO, you just boot off of it, it installs everything you need, and away you go.
Wow, I tried looking for it in the last 6 months, and I couldn't find it. Is it something that was from a long time ago, or was it recent?
No, in fact, I just started doing this about a month and a half ago.
Oh, wow. Right, the ISO is the way to go then.
Oh, absolutely.
Yeah, so you have
guy
a
next to me
dedicated
is
VM.
running it in a VM, and it runs fantastic for him as well.
Yeah.
So.
And you could probably do USB pass-through, so you don't have to run a Home Assistant or run a Raspberry Pi to have your USB dongle. But what you have to do is, say if you're running Zigbee, you put your always-on devices strategically through your house, so then you have a full mesh network throughout your house. And that's actually what I'm doing in my basement. I have the light bulbs that I plugged into, or I've screwed into the little, the lights along the top. Well, they're always on power, and I can turn them off. I turn them off in my Home Assistant, but then the Zigbee, the radio is still running, so it creates that mesh network, And now upstairs, when I have other lights that are on the opposite end of the house, they still work fine.
All right, big hand for Tony. Thank you, Tony.
Thanks.
Do we have our next speaker in the house? There we go. Get you set up real quick. Right. Our next speaker, Mike, is going to be talking about free cybersecurity training. Mike is an instructor for Northwest State University near college, community college near Archbald, Ohio. He's spent nearly 10 years teaching electrical engineering. Before he was an instructor, he spent 20 years designing and maintaining data networks for school districts throughout Northwest Ohio. He has a generous grant from the NSF to work on cybersecurity for advanced manufacturing projects, and really excited to see what he has today to talk about cybersecurity training. Big hand for Mike.
There we go. All right. Sweet. All right, we ready to go? Everybody hear me? All right. Well, first, thank you for the introduction there. That was a very fancy introduction. My name is Mike Witkowski. I come from the northwest corner of Ohio, if you have no idea where Archbold is. That's surrounded by cornfields. And that's about describing northwest Ohio. However, we have a lot of manufacturing around us. We get a lot of bleed down from Detroit with the auto manufacturers and a variety of others. So we were, Tony and I, Tony is sitting, wave Tony, this is Tony, he's the Tony Hills of the coordination here. We've been fortunate to be blessed with the opportunity to work on this NSF project, or this NSF funded project, to develop training scenarios for advanced manufacturing. So that's partly what I'm going to talk about today. I'm also going to use this, the excuse for coming to Linux Fest, other than the fact that I wanted to talk about what we did, was to also show off how we used open source tools to provide this the training scenarios here. So that's where we're heading for. That's what we're looking at. All right. So why this project? Why do something like this? Well, you know, in the world of today, cybersecurity is only going to get more important as we go further. There's no question about that. The days where we could toss things back and forth in plain text and not have people worry about people seeing what we're doing and malicious activities are long gone. So we need to have a more secure stance in our data networks. Particularly in our more sensitive data networks that deal with manufacturing. Because our manufacturing networks are very different than what we have available to us in our typical IT configuration. And so that's where this project is trying to come in and to educate and fill that gap between what IT does and what OT does. The other thing that is a driver is, Stuxnet. If anybody know what Stuxnet is? I should hope so by now. If you don't, go out there and Google it. It reads like science fiction, but it's history at this point. It really happened, and it's really frightening. And we're feeling the effects years later, and like I said, it's only going to get worse. And ransomware is where we are today as a real possibility in any network. And ransomware, anybody ever been hit by ransomware? A couple of you? Okay, fortunately I have not, but I'm not going to tempt fate and say that, I'll never get that. It can happen to anybody. And really, it's a horrible thing if you're going to if you go through that. Do you have fun with that? No. Okay. But I look at it as an opportunity. To me, it's kind of like COVID. You know, who enjoyed COVID? Yeah. I just came. Actually, I had a friend one time asked how we were doing with when everything was shut down for COVID, and I said, well, it's kind of like any other Tuesday. We didn't go too far. Just stayed at home and did what we had to do. But ransomware, it's a horrible experience. I wouldn't wish it on anybody. Well, okay, maybe a couple people, but most people not so much, or most organizations. But one thing it has done, it's allowed IT and IT security to monetize the cost of cybersecurity. Okay, it's at least allowed us to have this discussion with. I'm here to. You guys in the mic here to feedback? Oh, ah. Thank you. The light's still on, but nobody's on. Is that better? Oh, that's much better. Okay, great. All right, good. So ransomware has allowed us to at least monetize and have a discussion with upper management as we need to say, look, this is what this costs. All right, and this cost is coming out of our pocket and going into somebody else's pocket that doesn't deserve this money, because ransomware people are smart. They do their research. It's not. I'm still getting that. What the heck? Hold on. It's catching me. Okay. Yeah. Oh, it does say it's off. So, they're smart enough to realize that they can't charge if they can charge somebody $10 million, they're going to do it. If they can charge somebody $100,000, they're going to do it. But they realize that it's not like they on a whim pick a company and just choose this group today and tomorrow they're attacking them. They spend time with their research and they gain knowledge and some understanding of who they're going after, so they know who can pay what. And so that helps us as IT professionals to be able to bring that to our check signers above our pay grade and say, look, this is a real issue. You've got a number of companies that have had have been attacked by this around the world, and we don't want to be next. And this is what it's going to cost to get around that. So, good or bad, it at least has given us the ability to talk a little bit more to the C-type people and about what it would cost to mitigate some of this. Another reason for this project is that I come from an IT background, Tony comes from an IT background. who comes from an IT background? Yeah, a lot of us. Anybody come from OT in here? Okay, yeah, nobody. Anybody know what OT is? A few of you, okay? So IT, information technology, OT, operations technology. OT is what you have in manufacturing. They're the people that actually make money. All right, they make money for the company, or at least involved in that business process. Typically, in an IT scenario, your IT departments cost money for the company. Yeah, they're a necessary evil that if the company could do away with us, they would. They can't, but they would. Because when it comes down to the actual bottom dollars, it's the process, whatever they're trying to manufacture, that's bringing the money into the organization. And we as IT, we're just the necessary evil to make it happen better. Also in the process with OT, because they're in charge of what's going on in the manufacturing process, typically from a technology point of view, they're making sure that the production cells are working, that the communication is going back and forth between the historian collectors and things like that. They are supporting systems that can have unique support signatures that you wouldn't necessarily find in IT. In IT, we are typically supporting systems that we can update with the current security packages, with the current security releases. We have modern operating systems and modern hardware systems. But in operationals, in the process, that's not necessarily the case. It wouldn't be a surprise in some locations to find a Windows NT server running somewhere. OS2 Warp, for crying out loud. It's a possibility. You just don't know what that original multi-million-dollar manufacturing cell was delivered with, and it's not like you can update that to the most current version of Windows, Linux, or whatever we're going to run on it. All right, so we have to be sensitive to that. We have to realize that we can't do security updates on that equipment. And so what do? And that's the question. And we have to be able to talk, if we're IT, and have a conversation with the OT people. And the OT people have to be comfortable enough to come back and talk to IT and have a conversation versus butting heads and just getting angry in a room and then walking away because IT doesn't know what we do and OT doesn't have any clue what they're doing. So we don't want that. We want to have a conversation. We want to make this work because ultimately we want a more secure stance. And so that's where we're coming at with this project, is trying to improve that knowledge base between IT people and OT people and have that conversation. So the goal here is to provide some training so that those conversations could take place. Okay, so how do we make this? This is free training. This is the whole point of the title of my talk, is a freely available training. So first of all, the name of the project is, we call it the CAMO project because we've got a nice acronym for it, the Cybersecurity Education for Advanced Manufacturing. But just because this is geared towards advanced manufacturing doesn't mean that it's limited to that. Okay, whether it's critical infrastructure or just cybersecurity training in general that just happens to be looking at advanced manufacturing and some processes that you might find in a manufacturing cell, it's still very useful from a cybersecurity training perspective. This was funded by a NSF grant, National Science Foundation grant, specifically geared towards community colleges in that realm. So it's a clickable link. When you get the slides, you can read up on all the gory details of our project grant. And the freedom part allows us, why is it free? Because we think it's important that this is available, that people can come in without specific monetary restrictions and get some at least basic training for this information. So how do we make it free? Well, obviously the NSF grant that I mentioned earlier helps quite a bit with that. But also that's paid for our time to develop the scenarios. So the scenarios are built, and we've got some more that we're working on to add to this while we still have the funding in the cycle here. But the other half of this is the environment that we're using. You know, we virtualized a training environment for these devices that we want to utilize in our scenarios. And we've done a mix of mostly open source tools that are freely available, as well as some out-of-support software, like specifically Windows XP, which technically we have the licenses for, but I'm sure Microsoft's not going to come after us and say we need more money for something. And it actually is nice to use something like Windows XP, because Windows XP was around for a long time, and without support for a long time, and is still found in places it shouldn't necessarily be found, but still is used. So it makes this, it kind of helps make this even more realistic, because from an OT point of view, you absolutely could have a Windows XP machine running somewhere. Hopefully not Windows Vista though. That would be bad. Or Millennium. Wouldn't want that either. I'd rather have NT running somewhere than Millennium. We also use some demo software to make some of the stuff work, specifically on the Windows XP side. We wanted to be able to provide a couple of aspects of the OT environment, and so we had to leverage some demo versions to make that happen. We're also using some self-hosting for you. This is freely available to anybody. If you want to be able to use this, we're hosting it for our purposes right now. We use these training scenarios locally in our programs. Tony has a class that he goes through every one of these training scenarios as part of his cybersecurity the networking class, right, Tony? Yeah, cybersecurity networking class he teaches. We also have Kellogg Community College up in Kalamazoo, Michigan, is using a couple of these scenarios in some of their coursework. I'm using it in a few classes in my coursework, and we invite anybody who wants to use these in their coursework. It's available. You might just have to host it somewhere else other than our site, but we could have discussions if you needed to. We're going to host this with the Ohio Cybersecurity Range, right? Possibly. Yeah, we're still in negotiations. That was the original intent, but there's been a few things that came up that has kind of sidetracked that possibility, but we're still working on that. But you don't have to have us host it. If you are interested in this, the scenarios are all available online. The VMs are also available online. We also, we have a booth across here in the vendor area, Northwest State Community College. You can't hopefully miss the banner there. But if you come by and ask, we have flash drives that we can give out that have all the VMs loaded and the scenarios as well. And we promise there's absolutely no malware or anything else on there. Just saying. Nothing will track you as far as you know. Okay? All right. So what do you have in these in free? Because free is good, right? Well, it depends what it is, but still, free helps. Don't tell my wife it's free, because it will end up at my house somewhere. Anyway, freely included with every scenario. You've got, of course, our developed environment, which includes 6 virtual machines that emulate a small Operation OT style installation. We've got some videos to supplement the presentations that are included with the scenarios, and a lab. Okay, we've got a lab for each one of the scenarios that walks you through step by step with a question-answer worksheet in some of these, and it just depends on how they've been presented and what we're looking at when we get to the end of the lab. So it can absolutely lend itself towards classroom instruction. You know, that was our original intent, but it's absolutely usable by an individual who just wants to gain more information and more knowledge. Here's a picture of our setup. So it's a training scenario. we have a PLC, we have a sensor pump combination, a tank that we are pumping some type of liquid. I'm assuming it's something more dangerous than water, in and out of the tank. Control system, an HMI system, human machine interface system. Open PC, open platform computing server, that acts like as a historian, a central gathering place for a variety of different data inputs and can be a reporter output for someone who would be interested in the process. And of course, the hacker system that is on the network that we use to bang against the devices out of the network. The devices themselves, so this is where we get into the free tools. We've got the PLC device and the sensor system. It's virtualized, and instead of paying Siemens or Allen Bradley for their usage of their emulators, Tony rolled his own. Tony came up with was able to use Arch Linux, which I give him props to that. That was more work than I wanted to do. Arch has always been a little intimidating to me. I much prefer Ubuntu over the years anyway. And of course Python. All right, Python's an awesome general purpose scripting tool, like we had learned this morning, and with a very robust community. And so as part of that robust community, we have a couple of libraries that are specific to communication in the OT environment. Modbus is a protocol that's been around for a long time. This predates their general use of Ethernet. Modbus has been used on serial ports between devices for quite some time. Not the most secure thing around, but it's part of why you want to protect this OT environment. Modbus is a Python library that specifically has calls to form the correct Ethernet packets for Modbus, so you could sniff these packets and pick them apart and see what turning on coils and status of bits and flip bits and bytes for devices that would show up in the Modbus communication protocol. The Snap 7 protocol that also leveraged is a part of the it's an Ethernet wrapper for Siemens protocol. Siemens. In the OT sphere, Siemens out of Germany and Allen Bradley in the U.S. are the biggest controls company. At least in our environment up in the northwest corner, we've got a lot of Allen Bradley people, but Siemens is very large worldwide as far as an installation base. And Allen Bradley actually is around the U.S. is pretty strongly represented, and Siemens has its pockets too. But they're the two big players in PLCs and controls, but they're definitely not the only ones in town. But these sensors and the PLC systems that were put together are they're just enough to pretend to be these types of devices out on the network. The hacker workstation, well, what else are we going to use other than Kali? I'm sure there's others, but come on, Kali is the go-to. So we've got a Kali box that we spin up for the student to utilize from a hacker's point of view. Excuse me. And of course, the security appliance that provides routing and other network services associated with the network is a pfSense VM that does everything we would need for this scenario. The other tools that we leverage that are non-open source, we've got two VMs that are running XP, where one uses a demo version of KEP Server EX from the OPC server, that historian type box, and then advanced HMI. This just produces a nice interactive graphic on this VM for controlling the system, for reporting the pumping level, the pump sensor, and turning the pump on and off. So this is to be something that an operator would have at their station, controlling the process in the environment. So the scenarios themselves, we've got 6 currently, with starting out with the cybersecurity basics, from the point of view of industrial control systems. There are, like I said, a special case compared to IT, some things that you really have to watch out for when you're managing a controls style system. So this goes over some of the basics, talks about the Purdue model, and how you should zone your networks, how you shouldn't trust the IT network. Even though it's an internal trusted network, you still shouldn't trust it. Nothing against IT, but it's got its own requirements. Wireshark, okay, great, and that's actually where we end up here with this demo. I was going to just show off our system here and use Wireshark as the demonstration. Metasploit, of course, how to take advantage of the exploits that we find on the network, how to zone a network into different networks, and then VPNs and how to use an IDS IPS type environment, which we've got a few more coming, right? By the time the money runs out in the grant, we hopefully will have a few more up here, again, freely available. Okay, so that's what we are offering for this free training and what we're doing with this. I was going to show off Wireshark because Wireshark is one of those, should be one of those well-known products that are used as a informational tool in IT security. So it's a nice basic protocol sniffer, packet sniffer, very mature open source project. Anybody use Wireshark? Oh yeah, okay. Anybody remember Etherreel? Oh yeah, what they used to be. But Wireshark's been around for a while, and if we add in the Etherreel time, for quite some time. But it's a good tool to start with, okay? It gives you the ability to look at packets and to analyze and talk about the bits and the fields and all that good stuff, and to really look at what's going on. So we start with that, okay? The scenario itself is accessible here, and this will be in the notes for the talk, the reference at the end of the slide here, and these slides will be available. They'll be when whatever summary here is, whatever we have for the end of the conference, these notes will be available. The web page itself, I'll bring up the web page, but just some basics before we get to that point. Every one of the scenarios has a similar layout from a starting point. We've got an overview of where we're going with it. The background and videos are talking about the concept itself, and then the lab, okay, and the HTML version of the lab. All right. All right. Time to do a demo. Switch to that. Give me one moment here. That is not my password. Yes, a second. Wrong password. All right. So when we host it, we are hosting this on a box back at our site. I'm just logged in as my instance here, and we run a script that I am not. There it is. We just have a little starter script that we. That allows us to start this up, and it opens up VirtualBox and then spins up the 6 VMs that are associated with this. And so then VirtualBox has got all of these devices up and running for us, and we just, you just switch typically between the Kali box and the HMI device. Really not necessarily any reason to go to the PLC or the sensor box because they're just running in the background. We don't do any changes. They're just providing traffic for us. So I'm going to go specifically. Oop, I don't want you in here anymore. Go away. All right. So we go to Callie. Did I get the password right? I did not. The password. I did that time. Okay, awesome. All right. Come on, wake up. I'm gonna have to reset it. Just Callie? Oh. Well. All right, sorry. Yes, please. 2, 1, go. All right. Yeah, this stuff doesn't take, there we go. It's a pretty nice system this thing's running on, for us anyway. So it doesn't take too long to reboot. Oops. Of course. There we go. Okay. Cool. All right, so here's Callie. For those of you who have never seen Callie, it's available on our devices here. We want Wireshark. I'm not going to look for it. I'm just going to type Wireshark here. There you are, Wireshark. Boop. Oh, geez. Super secret password, which is password. Password 01, actually. So, with a capital P. Now you know. All right. So, there it is. We've got a couple zones down here, of course, defined in the environment itself. But the manufacturing zone is specifically on the manufacturing network. So this would allow us to capture data. I want the cell zone? No. We'll be that way. Okay, well, there's data. All right. There's the cell zone right there. So this is very chatty. Hold on, let me stop that. So without walking through the lab, like I said, these scenarios are available online. If you're actually interested in the details of the lab, I'll let you explore that. But what we can see here with the Wireshark is you notice here, I'm pointing to the sign like you can see the screen that I'm looking at down here. Point over there. There we go. The Modbus, specifically in the protocol column here, you see the Modbus communication, Modbus over TCP. All right. That, through the magic of interpretation here with Wireshark, we can see the different back and forths between the emulated PLC controller and the sensor. All right, you can see a read coil here and a write single register, read holding register, read coil. This would definitely be traffic type that you would expect in a Modbus style OT network. And so, excuse me, with the scenario here, we introduce the student to that Modbus communication protocol that we can witness through the Wireshark captures here. So it gives us the opportunity to introduce Wireshark, but also to do a little bit of a dive into Modbus to see that this is right here. Notice we can read this. So that means it's in plain text. Okay, so another step you could do in here is inject your own Modbus style traffic and control those coils the coils. It's actually, they call it coils because of motor control, but this gets adapted into a variety of different types of control systems. You got to call it something, so they call it coils. But you can attack these registers just by injecting these packets into the network and changing the values that you want to set to make your own control point and control action for those sensor style devices and pump style action devices out on this process network. That's not a good thing. This is why we need to practice seeing this and also protect this network from any kind of outside intrusion, much more specifically than we would, we're already in this protected zone in our IT network. We should be, but we want to be even more protected within the OT network. And the hope is by going through some of these scenarios, people in OT see this, the fragility of this type of environment and the need to protect it, and also then give IT the reasoning why there needs to be another firewall layer between IT and OT, and the specific requirements to isolate that type of traffic. So anyway, just a quick, if you want to know more about Wireshark and its interaction, do the scenario. Okay. Anyway, that was not my screen. Here we go. Get back to this. All right. Okay, so I'm going to take advantage of this and get us back kind of on track on the timing of our presentations. But this is on the last slide. You can see my contact information as well as Tony's. I threw in a couple of related links. The camo scenarios this is just the specific location of all of our scenarios that are out there and available. If you wish to look at them, if you wish to know more about them, please contact us. We'd love to talk to you about them. The link to our NSF award, and if you've never been there, to the CISA.gov site. I'm a big fan of CISA. They've got a lot of freely available utilities that you as taxpayers have paid for, unless you don't pay taxes, then I don't want to know about it. Okay, but it's a great site that actually offers more freely available training in the cybersecurity realm, and specifically some focused, quite a bit focused on advanced manufacturing and critical infrastructure. Nothing we're competing against, but definitely something that we would hold up to as a goal for us to reach with some of their training. But just good information in general can be found at CISA. Okay, and that's my talk. Any questions? Oh, yes, we'll get Catherine.
Videos of the training actually being given?
Yeah, I can bring some video up.
I mean, I don't need them now. It's not of the training being given.
Yeah.
It doesn't have to be now. I just like they are.
Yeah, here I can. Yeah, right here off of scenarios. So sticking with the Wireshark idea, go to videos and boom, boom, boom. Right there. So this basically is, hi Tony. But that's going over the slides that already exist. But so the videos are just a video, literally, of that presentation over the slides. So thank you. Okay.
The manufacturer is not the only one using old systems. If you have universities that have medical colleges, a lot of them are using XP, plus they're using old browsers. And unfortunately, a lot of our military systems are still running on XP.
Absolutely, which is this is focused on advanced manufacturing and critical infrastructure, but yeah, there's plenty of other actors out there that are utilizing older systems because they don't want to change. And I don't have to be inclusive or exclusive. I would love you to be using this if you have this need. We would really enjoy having you use it.
Okay, so my question is, how do you engage vendors with potential fixes, workarounds when you find holes? Like, if somebody's using these tools and they find exploits or, you know, something bad, how do you engage with vendors? Or have y'all done that?
Oh, we've not done that, but you know, it just depends on the vendor. You know, every vendor is going to be different with their ability to report issues with their products. So you go straight towards them to them. You would maybe there's a community page involved with that. I mean, I can't speak to. There's not a one response fits all. It's just going to be dependent upon what you're using and who you're talking with.
So what version of Wireshark were you using to do packet injection? I thought they took that out, and maybe they put it back in. I know mine doesn't have it.
Oh, we're not using Wireshark for packet inspection. Injection. I'm sorry. Yeah, injection. That was. And I apologize if I confuse that. That's what the Metasploit lab is about. Yeah, sorry. So we use Wireshark to see that traffic and kind of get you ready for the Metasploit lab, which would be where you take that traffic that you just saw and now realize the vulnerability is inherent in that by using Metasploit to make that injection and that attack. So. Yeah, no, thanks for pointing that out. I didn't realize I implied that. Yeah, no, I think I actually kind of implied that now that you say it.
Any other questions here?
All right.
I'm not seeing any online.
Excellent.
Just a reminder, if you're on a Slack, you can join the main stage channel and post your questions there.
All right. Thank you.
All right, folks, we have about 18 minutes before the next talk, so it seems like you get a bit of a break. If you haven't already, be sure to poke your head in our expo. Our sponsors are a big part of how we bring this event to you, so please do show them support. Thank you. All right. Hello, everyone. How's your Linux Fest going today? Muted excitement. Well, hello, my name's Warner Moore. I serve on the leadership team with the team here. I give everyone a big hand. A lot of work went into putting this on for you. And Vance, our conference chair, this is his second year doing it. And I'll tell you what, if you think running a conference is hard, try running a conference during the pandemic. So if you see Vance, be sure to thank him for all his work today. I'm excited to introduce our next speaker. Ling Yan is a software engineer at DigitalOcean. I suspect some of you, I'm a DigitalOcean customer, I've been a long time, I suspect some of you are too. This internet service provider has been around for a while. So his background, he focuses on virtualization and the cloud over the past decade. A few years ago, he stepped into GPU virtualization work with Suzy and NVIDIA and started working on machine learning stuff since then. He's been a speaker at OLF before, so glad to have him back. Today he's going to be talking about Kubeflow and bringing your machine learning project into production. It'll be a great presentation. Big hand for Lien.
Thank you. Thanks. Hello. Okay. Yeah. Really glad to be here. Thanks for guys taking the time. My name is Liang Yan, so we just did the introduction here. I've been here since 2018. This is the fourth time be here. Very nice conference. Hope could make it a thing, like every year be here. Feel like I missed something, if not. Anyway, today I'm going to give you a talk about the Kubeflow, like how to use that, how to make them in the production. So let's start. First, just a little bit about myself here. I work at DigitalOcean, so in case I forgot, I brought some t-shirt here, some sticker here, so feel free to grab after that. Myself, quite interested in the open source stuff, so I've been working DigitalOcean now, SUSE before, and Debian stuff earlier. So it's really nice to keep working on this. My mainly working is virtualization area, like the KVM, QEMU, the fundamental of the cloud bottom. And also, I'm quite interested in the system machine learning because working on the GPU stuff. And also, I'm quite interested in ARM62 board. If you see the picture, I kind of have all these kind of boards from outside, kind of fun. That's me. Okay, yeah. That's the part. Yeah, we also have this Kentucky Open Source Society. If you happen in Louisville, Kentucky, feel free to join us there. Would be fun. Now let's get into the fun part. So Kubeflow. Before we start, I actually before talking Kubeflow, I would more like to talk something background there, like why I use that, I choose that, and what kind of user case Kubeflow could cover. So from there, we can have a deep look at the Kubeflow, what it is, what it can do, what kind of components there, how do we build it. And I also run a demo there, hopefully. There's another story about demo, but we'll go there. After that, I would talk a little bit more beyond the Kubeflow, like more the cutting edge of the machine learning today, more specifically distributed machine learning in the production. So what we can do, like the scalability, or using the end-to-end, like to training a model, put it in your edge computing, even in your mobile phone. So I think we can go there. First, Kubeflow. Like I said, I'm not quite a data scientist, data engineer area. So before I start look to Kubeflow, actually I'm thinking to build an app because I've been working on all machine learning stuff, all the GPU, CUDA, TensorFlow before. So I thought, why don't I put it in use? So how could I do that? I'm thinking like a little bit small product. So this is comes. So I actually did a school project before, back in Michigan, so Upper Michigan. That's why you can kind of get an idea why I choose this flight delay predictor. So we have big snow in the winter or other weather, so we got a lot of delay there. So I'm thinking maybe we can put AI, machine learning in use here. We can input like back to the APP idea. So I'm going to get an input with the user, open the APP, and input your flight number and the date. Then it will give you a feedback, like how possible that you got delayed, 15%, 18%. So you can arrange a little bit there. But this is still machine learning area. So we still need to train a model and then use this model to inference the results. So back to this all machine learning stuff. So we needed to get some data. That's called the feature in machine learning concept there. So we choose this kind of, the basic idea is we get a bunch of history data from everywhere. Like I can get it from all the airline company. I can also get it to the weather, the public company there to get the weather information, all kind of this information. And then I need to process them to make them quite relevant to the result I want to use. Like, because when thinking a flight going to be delayed, maybe we are thinking about where this flight fly from where, depart from where, and arrive from where. And also we're checking the time because different time have the rush hour there, like thinking about the traffic there. And also about the weather things. So I choose this kind of things. Now I'm gonna use this kind of data as my feature to train this model. So it's like, eventually the model will be like, I will take, like for example, I would take 10% of the result from the airport and 20% from the time, and 30% with the weather because they are strong relevant. So eventually I will get this equation and I got this model. Now I have this model, but that's not enough. Like that's only kind of one part because I can let a user view. I can see this is my product. Unless I'm kind of this public cloud provider, like I provide this API to you, you access this API, once just charge you with the times there. But the end customer may not be interested. So still comes back to the APP there. So this APP will access the information. So I did a bunch of the machine learning stuff there to get this model running, and then I got this APP stuff here. And the user will access to the model and get the result. I will reprocess the result and give a better result to the customer to have the user experience. So now we have two kind of part of work. I'm sure most of you have been working on the IT area, software engineer. So when thinking as a software engineer, like we want everything automatic. Not only, I think we want everything automatic there. So we just push a button, everything is working there, like the customer doing there. But as the developer, software developer, we kind of thinking, you will probably kind of familiar with this picture here, DevOps, developing operation. So we develop things, we keep developing, and we deploy it to the production, and then get the feedback from customer, either bug or feature request, and then we get back iteration, and we develop again redeployment. But that's for the normal APP, the pure APP there. But for the machine model side, so it's kind of a different story. It's more like the other side. So we needed to get all the data from everywhere, from the company, from the government, from the organization. We needed to pre-process that, like we needed to pick the data we really want, that we cared about, because there would be so many data there. They are in different format there too. So we don't want that. We probably need to do this one. After that, we also needed to set up this basic machine model. Like today, we can use TensorFlow. We can use PyTorch there to design a neural network, or to design a DNN. That's kind of popular today. So eventually, I want this model, this equation that with this kind of feature and the weight there, I get these results. So, but how can make them automatically in one place? So more would be like here. So I want to put them together. So I could check, it's like a whole IDE there. I can change my model from here, and then my data set. Speaking of here, the product is more like a team. But for my APP, I'm the team, so kind of sad. But in a real environment, probably you have this data engineer working on the machine learning part, and you also have the software engineer working on the developer part, the APP front end, like all the UI stuff and action, and also the back end. You need a database to save all the user information. Like if when you want to charge it, you need a billing system there too. That's very important. And then you also need operation. Like if just one APP there, you only have like 100 customers, you probably don't even bother that. But thinking bigger, like the AWS, like Netflix, there will be hundreds or thousands of customers there. In that case, you may need some ops, cloud ops, like to maintain all this kind of data traffic there. So eventually, my idea to create this flight delay predictor APP comes to this kind of a map. So I needed to start from that first. Actually, the data and the APP developing, it could can parallel there. So in case you have multiple people there, but otherwise we can see like you still need to get the efficient data there to do all the data processing. And then you may also need to split the data for the training, for the testing, validation, and for the testing there for different purposes to make sure your model is more accurate. And after that, you have this training model, and you can, the training part could be also tricky. Like if we have so many data outside from so many people there, then one machine probably also not capable. Like same as the APP outside, the end side, the training side, we also need thinking about the scalar. And once we have this model ready, so we kind of like it could roll out to the production automatically like we have this model, we put this model to the back end of your app. Now your front end customer access through the front end of the app, they could get the latest information. Also, to make sure my app is stable and also robust, efficient, I needed to put some metric and logging system. So here, like monitoring that, we can integrate with Prometheus today or ELK for the logging system. We can schedule it better, or if have bug, we get this log information, and then we fix it quickly. With all this, so it comes to the Kubeflow. Actually, it's kind of a, before we really get into the Kubeflow, I give you a straightforward impression from the here. Here is a central dashboard from the Kubeflow. I mean, once you install it, deploy it, you could get something like here. Like I said, it's kind of like IDE, web IDE there. You have all the information you need, like all the process we talked earlier, all this kind of process here could fit some of the components here. So that's kind of why I choose Kubeflow, and that's probably also why Kubeflow is quite popular today. So I think I already talked a little bit that. So before that, I would like, what's Kubeflow? What is not Kubeflow? So from here, from when I first heard of that, it's pretty new. Kubeflow is start from 2018. Okay, kind of the first time I've been here, this conference. So kind of 4 years from now on. When I first heard that, I thought Kubeflow is Kubernetes plus TensorFlow. This just combine them. That's true. That's also not true. Yes, because I think from the start, it's true. We can use Kubernetes is much more popular. It's a kind of a infrastructure platform there. And the TensorFlow is just start. PyTorch or other Minist, other kind of machine learning framework is not popular there. So that's probably they named that. But today, Kubeflow is much more than that. It has a huge toolkit there. It also supports more than TensorFlow. Also, it's an application toolkit. Like I showed you there, all these kind of procedures there, components there. So it's not one application. It's a toolkit there. It's a collection of all these kind of applications. And it's not a scheduler. It's not a scheduler of the Kubernetes to scheduling task. It's more like an orchestrator, like to make all this kind of stuff, to make all this works in peace. And it's also definitely not a machine learning algorithm, and it's not a machine learning framework. So it's not, even it has flow there, it's not TensorFlow. There's a lot of flow outside today. OneFlow, TensorFlow, FlexFlow, PyTorch, Minist, all kind of framework. But Kubeflow is not. But Kubeflow is cloud native. Like it has a Kuber there. It has the Kubernetes parts there. That's a huge plus, per my opinion there. You could just running there, and you could reuse all the scalability, all the resource management from the Kubernetes. And also, it is a very good DevOps, machine learning ops tools there. So that's why I choose Kubeflow. Before we will continue, I'm going to tell you how good, how great Kubeflow is or how bad it is. You just keep in mind, it's not the only one outside. There's a lot of other similar tools there you can choose. So we have this Lugui and Airflow, Kubeflow, and Machine Flow, and Argo there. Argo is a kind of a pipeline towards outside. Quite interesting to me is the Machine Flow is also quite increased quickly. It's later than Kubeflow, but it's very close there. So we'll see how things go there. So just said, Kubeflow is an application toolkit. It has so many components, and each component also has choice there. So now you can see it's more like reuse some wheels outside. We are thinking, we're thinking back to the whole like machine learning and the product stuff there. So you could have found these tools from the Kubeflow. The first, the developing part, all the data engineer like the Jupyter Notebook. So it's awesome. You can write your code there, and it's based on the container, so you can run that. And there's also the training operators. Now we can see it's not only TensorFlow, it also have this MPI, PyTorch, XGBoost, and there's also the workflow building. It's part of the pipeline. I think the workflow building and the metadata is the fundamental to build this pipeline for the whole machine learning product ops there. Machine learning DevOps. So with workflow building, so like if you create something in Jupyter, it will build an image for you automatically, a Docker image. So you can put this Docker, once it's Docker, it could be quite portable. You can just migrate it to anywhere you want to, local or cloud. And also with this metadata there, you could track all the history information of your model. And it's very good to keep life cycle management, also very good for the performance. And also, the pipeline. So we have this whole pipeline. You can, the whole process there, from the data to model to the user there, we can set up a pipeline. And when we start that, when we run that, it will do that all for you. This is the outro of the CI/CD, the machine ops there. So there's also other tools you can use that. But it's like I said, it's a combination. So you can use that, or you cannot. You don't want to use that. That's fine. So I think outside today, for the most of the public cloud provider vendor, they provide this service for you. They kind of have this customized already there. They give you some components there, and they disable a lot of the others. So that's fine. That helps, I think, because when I look at that, it's just so many stuff there. This is the Jupyter Notebook. Like if you use that, you probably will see you can open a web page there. You can put your code there. You can even install your library, Python library, from that page, and this web page will access to the notebook server, which is inside a container there. So, and it will running this container. It will running inside this container automatically and give you the output on the web page. We're going to see that in the demo later. And here is the fairing. This is like when you have the code there, it will build a Docker image for you. Not only for the machine learning code, it also includes all of your other code there, like the APP code or the backend, the database code or billing system code there. You can all kind of, from the code, going to a Docker image there. And then it also could like deploy it automatically. You can, like the Kubernetes, if you apply a YAML file there, it will start this service in the Kubernetes platform automatically. Same here, like it could boot up your machine learning stuff or your software service automatically from your cloud platform or the other cluster. And Katib here, it's a tool, it's an optimization tool for machine learning. When we're talking about how to predict the air flight delay, so I said we have a kind of a feature there. The city, the weather of the city, the flying hour, the flight model there. That's kind of feature. But there's also other kind of parameters there. Besides this one, it's used to describe your model. Let's taking neural network there. You're probably like how many layers and what kind of a learning rate you want to use. That's kind of a mechanic there, but there a different value also could give you different training speed or even accuracy. So this tool could help you to choose the parameters automatically for you. I think there's also one other side called the auto ML, auto machine learning there. It will get. I personally think this is an option now. Like if you want you can add it later for optimize your machine model there. From here, the idea for it is quite standard. Like we are going to search like how many layers of your neural network, what kind of a learning rate there. So this kind of parameter there, here we are using experiment, and all these combination will be inside this experiment, and it will create different trials. Like it's random. You can randomly search there. It's kind of the try different combination there. Let's say I have 3 and 5 layers. I have this learning rate 0.1, 0.01 there. So I just combining them and training all of them, and then compare the last results, and then choose this one. So it's kind of a learning algorithm here. From here, you can get the best parameter for your machine model. And this is the very important part, training operator. Very beginning, Kubeflow, I said, sounds like Kubernetes and TensorFlow, and more like how do we running TensorFlow inside Kubernetes? And that's very, thanks to the Kubernetes, it has this customer resource definition there, CRD, from 2000, I think it's 2017. And then 2018, it used in the Kubeflow. So with this all resource, you create a controller there, and then you build this resource from the Kubernetes, and then also add a webhook for your dashboard there. Voila, you got an operator. And because there are so many machine learning framework outside, there's also a lot of operator here. It's kind of like if you are doing this kind of work, you feel like it's not like you are using different library, Python library or C library during your software development. It has a lot of dependencies there, learning curve there, so it's kind of difficult for you to transfer from one to the other. So now upstream kind of had this try to unify one operator for all of that. So kind of looking forward to that. Here is a TensorFlow operator. It's kind of using a distribute model here. It's using the parameter server. So we have one server here to save all the features there. And each worker will running one set of data there. And each data, once it running one side iteration there, it will update to your feature parameter there. And you're going there to update there and then distribute to all the workers. So eventually you get the whole training process done. This is the last part of the machine learning ops there. So we have this model. We like to deploy it to the front end to let customer to access it. So the Kubernetes has this Kubeflow has this Kubeflow serving there. So it also reuse the ISTO and key native here. So it kind of put this serving process as a serverless service for the Kubernetes. And it's like each time the app will call the model time, it's actually using the API or RPC, REST, FUL there to connect them, and then get the results back. And when access to that, the KF serving actually access this serving, and then access to it will distribute to one of your model, the inference worker there to do that. Because thinking the bigger system there, we also have kind of thousands of models there. It's kind of we also need to like how to coordinate that. And KF serving just did this for you. And each one you can see from the native, it's kind of the Lambda today, it's serverless API call, function call, and it's still doing all the service detection for you. And then goes to the Kubernetes, and eventually go to the GPU, TPU, CPU, or the compute resource. So this is the whole pipeline. Now is kind of the whole process here, from the data to the serving to your eventual customer. So we kind of have this pipeline tour here. So if I'm not sure, like I just recently working on this pipeline stuff, the code concourse there. So it's kind of a thing. All this DG graph here for you, one step by step, and there may be dependency there block your process. And this is the whole architecture behind that. Like I told a little bit there, so this one is used the Argo. It's based on the Argo pipeline tours outside. That's for not only for the machine learning, but for everything like the normal software development. With this machine learning, because all kind of data process stuff, training process there, so Kubeflow actually redeveloped that and goes this KFP here. And the two important part, if you're working on this pipeline, two important part is that you need a very good history tracking system to make sure each step, how there goes. And you need to track what's the stats there. The other one is you also need to kind of to pass all the result from one stage to the other one. That's kind of the fairing. That's the artifactory here. So you get some data from this container. You can just share it to the other container, to other task, because it's not safe, and they shouldn't be supposed to see each other. So you need to use Artifactory. You use other things there to share. Like maybe one way is that you you actually save the data to a persistent volume over the whole system. And when start the next process, it's going to download from the Artifactory to get the data there, to get the information input from there. So with this all, you could get all your process keep going. And eventually, the things, the app Explorer to me becomes something like here. So you can see the whole data process part. We kind of use the Spark there to do all the big data, or HDFS there. And then we can use the Argo to keep it going, the whole process there. It's not really Argo, it's the KFP now today. Kubeflow pipeline, KFP. And also the trainer part, we can use the Jupyter notebook and to write your code. And we can build the model. You can design your model in the Jupyter notebook. You can also optimize it with the Khtib to get all the parameters for your model. And you also need to verify it, test that if it's good or bad. After that, you can you can training during the training process. If you have so many data there, terabyte data there, you may need a better training system. There's TensorFlow for distributed system, and this is here is the Harvard. It's from the Uber. Like today when we call Uber food or Uber ride there, it's kind of also have this training process back in their data center. They also have this serving here, so they probably also use this pipeline there. And then we can use the rollout. We have this Selden. We can also the fairing. We can use we can create all our data to the container. So with that, we can serving that to the kind of the front end, the production end there. We can deploy them in the production. And also to make the production work well there, we need to monitoring, we need logging. We can using the Prometheus and ELK, Elastic Kibana, Logist Kibana there for your log system there. It's all in one now, in one platform. So that's cool. So now you have the whole team, you can working together, really working together. Like the data engineer working there, you can put all your data in one GitHub or GitLab there and build this pipeline. So everyone changes, it will update to the other people automatically and eventually going to your customer. So that's mostly the Kubeflow. So I'll just show you a quick demo for that. I set the experiment flow. I actually set up it in the cloud, DigitalOcean, so we cannot cloud. So I just use the DigitalOcean Kubernetes as the fundamental platform, and then I install the 161 Kubeflow on that. And our Kubernetes actually using Linux, Debian Linux distro there. So when I check, I also set up in local. I tried so many different things there. The easiest one I feel is you using the Juju and micro Kubernetes from the Ubuntu. It could just create your own Kubeflow cluster under 1 hour. That's very quickly. One interesting found is that about the Kubernetes version, when I checked to the upstream, they said they only support their Kubeflow only support 1.22 for the Kubernetes. But I still could install that in the cloud, the DOKS there with 124. Today, the most new one is 126. I think it just released this week or recently. So when you want to install there, you can use the first line while customer writes there, and then you needed to manufacture, and then just this one line could do all the job for you. You just needed to edit some 3 or 2 components there. After that, we can download this configure file from the cloud, and then you can operate from local. So I'll just show you here. Here is how I create my Kubernetes cluster here. You can just create here Kubeflow. So I choose 3 node here running, and I choose some good dedicated node there. So resources, you can see there are 3 nodes here, and also some other thing. And then we can get into the Kubernetes dashboard. So once you create it, actually here, you can download the, where is it? You can download a configure file here. You can download it to local. And then in local, you could just, here, Kubernetes control there. So you can use local to access it. For mine, I'm using the local command to use that while loop and to install the Kubeflow. So here is how the Kubernetes looks like. Then deployment, all the jobs. Yeah, servers. So you can see there's already TensorFlow. You can see all these kind of. You can see the name place here. There's already Kubeflow installed there. And here is the real Kubeflow install. The good part, when you download the configure file to the local, the good part is quite convenient. The bad part is it's easily confused with your local setup. Like I said, I have 2 Kubeflow clusters. I set one in the local, I set one in the cloud. So before I came here, I set a pipeline there, demo, but I set that in my local cluster. Now when I switch I have a desktop there. So when I switch to here, there's nothing here, but I just use 2 hours to build some simple stuff here in case we can. So for example, notebook, it's super slow here. And there's a tensor bars here. If you're working in TensorFlow or PyTorch there, you want to see how your data is training. You can, in a graph in visualization, so you can use tensor board. It will give you how the training person. Come on. That's kind of, don't like demo. Yeah, by the way, I'm using port forward here, so you can see I'm using localhost, but actually I access to the cloud here. Come on. It's timeout. Okay, sorry, we'll back here later. So still, like with all the cloud setup there, I still reproduce some stuff. I built this Jupyter running example there. I set up XGBoost pipeline example there in kind of 1 hour there. So it's still pretty good when using the cloud service, the cloud native stuff there. So this is all the no. Okay, so anyway, let's continue. So talking all this stuff, so my original idea is to build this flight delay predictor app there. But I needed to develop this app stuff. I needed to develop this predictor stuff. So I needed to involve 2 different kind of stuff. But I'm a lazy guy. I want to put them together. Or like if you are a team leader, you're a manager, you may want to see everything together. Like you can control everything there to control the timeline there and see the priority. So that's a very good choice for you, the Kubeflow. But by working on this Kubeflow, I found 2 very interesting areas, kind of the bottleneck for the Kubeflow or even for the machine learning. One, it's also quite the popular today, like people, a lot of company, university working on this area. I'm also kind of working on that too. The first one is the distributed machine learning. Like thinking about, I got this picture from online, not quite clear, but not sure if you could see. It's quite good. Like from the very top side, it's all the pipeline, all the working flow for your work, for your product. A little bit further, you need some training framework to do all the, in case you have a very big training data set there. So you can using like here, there are 2 mainly folks here. One is the parameter server. The other is the all-reduce. That's the one from the Uber they're using. So you have this take a neural network example. So each layer has all this kind of feature. And you need to think all the kind of values there. One way is you can put all this kind of the feature parameter in one server, and every worker is think with that server. Or the other one is there's no server. One just doing one portion, and then it will pass to the next. So eventually, once all the working done, you get the latest results there. So, and then keep going. You have this training job operator. And then you can also, because sometimes you need to do the batch job, and it also has another scheduler. Keep going, it's going to the Kubernetes pod, the nodes there, the server. And you need to thinking about CPU or GPU there. So from all the Kubeflow, all the training part, this is kind of separated from the whole process. This is a vertical. We are looking from the vertical perspective to seeing how they do this machine learning training or inference there. This is the to get a better operator scheduling and optimize your model to do it. Like we can do the KTB, or we can using some weight initialization algorithm methods there, we can do that. The other way is kind of a different. It's kind of related to the KF serving. So like I said, one way is we get this model, we serving to the user and the user. So we can use the API there, so all the users can access to it. Good part is you can put your inference worker in the cloud, and it could be very fast, but also bad. Like if you lost the network, just like I had here, you lost everything. But the other way is you kind of get all your code model, you build it into a mobile, a more light model there. And this model can be deployed to the really end user directly. Like this model could running in your phone for the app. Like every time my phone could do that, could just use the phone. If there's no data center, there's no connection, network connection, I can still use that because there's the inference inside there. The part is that you need to update. Otherwise, with the time goes, it may become late there. So it's not accurate. So, but that's also a direction. And today there's this kind of using from the compiling area. Like there's this TVM, and there's also the LLVM there. They could do this working for you. So all the data, all the code there, it will get into a very light model. So that's quite also interesting area. So that's all I got here. So like I said, I'm not a full Kubernetes guy or data guy. I'm more interested in the infrastructure, distributed machine learning, GPU stuff. So when I'm doing, I found quite, yes. So deployment is kind of hell. Like if you want to just test that locally, try the Juju and Kubernetes. And if you want there, but you want also you can try it from the cloud, but you probably need to spend some money there. For this one, it's not free. So running side, there's also some working to do. Like for me, I'm trying to training that work. So I needed to set up the Docker side, and I need there's only like 2 CPUs. I gave 2 CPUs or 2 gigabytes for the Docker, and I need to do that. That you need to customize there. So this part is not quite well in the Kubeflow. And also, we also needed to set up the Docker repository there, because all the work we are doing there, all the steps there, it will become the one Docker. So we needed to put it somewhere in case we manage them. So that's separate. That's kind of separate with Kubeflow. So other just the training model, that's the pure machine learning stuff. So, and yeah, also the last part is system failure. Like when I serving to the real part, it may cause one of your node failure there. Good part of Kubernetes, if you set the replica in Kubernetes, it will boot up automatically for you. I think, yeah, that's all. So many stuff here. I hope you found something interesting. Before the real QA, I just show you, there's some AI cloud provider outside. This kind of a company, and if you are using the GPU, I also did some summary there. So the cloud, what kind of GPU could get from which kind of a cloud provider, and also what kind of service you can get. I will send this slides to the organizer here. Probably online, if you're interested, you can go there. So anyway, let's get into the QA part. I can answer that.
Right. Thanks so much. I'll be running microphone. We have a few minutes for questions. Are there any questions? Well, it looks like no questions. Big hand. Thanks so much for presenting.
Okay. I was thinking, anyone who bring a question, I'll give you a T-shirt. But then, why bother? Why treat myself so hard?
Oh, free anyway, T-shirt.
Yes. Anyone? I also have some sticker here. So I got some T-shirt here. I think I have 3 large size, 1 small size, 1 XL. Come get it. Don't fight. Thank you, guys.
Oh, cool. Thanks so much. Our next presentations will be introduced by our president of OLF, Bethlyn Eicher, but it looks like we have about 6 minutes before we'll get started. So Beth will be taking us through our next session at 5 p.m. Thank you all. 6 p.m. I have no idea what time it is.
test. here comes Sam, our wonderful production manager as part of Team OLF.
But we're barely getting any audio, but it's there, so it's just gonna be cranked, so I think it's a short in the headphone port.
Okay. All right, we're just gonna be okay. We might have a little bit of audio issues towards the end of our presentation, but due to the timeliness of the matter, we are just going to simply proceed as is. And for those of you watching from at home, we'll see if we can go ahead and retroactively edit this for YouTube purposes. Thank you, and let's enjoy the show. All right, welcome to the Ohio Linux Fest Open Libra Free OLF Con 2022. We have a 20th year anniversary special edition. I will be your host, Beth Lynn Eicher. I am the president of the Ohio Linux Fest Corporation. I am so glad to be here. I am so glad that you are here. I have a co-host here, which is the lovely Miss Kara Pritchard, who is with the Linux Foundation. Can you come up with me, Kara? Yes, Kara. She's got her laptop because you can pry it out of her cold, dead hands. She's that kind of hacker. Miss Kara Pritchard. Hi. Give a hand for her. Kara and I met in an IRC chat room, I'm going to say circa 2000-ish, and I was part of Western PA Linux Users Group, pound wplug, on what predated Freenode. And what Linux Users Group were you at?
In 2000, probably one of 5. Over the years, I was like kind of racking my brain. I'm like, why is Beth Lynn asking me to be here? Why does she want me to do this? And it kind of hit me when I realized that everything that I'm doing right now, from career, social, fun, everything started in September of 1995 when I was on IRC and found this channel called the Southern Illinois Linux Users Group. I had no idea what Linux was. It didn't take me very long. Silug, Southern Illinois Linux Users Group, he's sitting back there, was pretty quick to fill me in. But everything since then. So between Illinois, Indiana, and Evansville, we had 5 different groups that we were working with, traveling through all the 3 states. We worked on collecting resources for users groups and had built a website for linuxusersgroups.org, which turned into the first lug project on linux.com. And I think it was somewhere in between there that I ended up meeting you on IRC.
That's beautiful. I want to also point out that the Ohio Linux Fest Open Libre Free, now known as OLF Conference, started as an interlug gathering. That it was basically this on www.ohiolinux.org. Join the first of its kind, a meeting of Linux enthusiasts from all over Ohio. Members from 9 Ohio user groups will be gathering to share insights, to listen to speakers from open source community. This non-commercial event is hosted by the Open Source Club and 9 participating groups at the Ohio State University in Columbus, Ohio. Who wants to go with me? Friends, I almost didn't go. Who am I to go to a Linux Fest? Am I enough of a Linux Fest professional? Am I enough of a user group member to participate in such things. I think that time has really shown the test that absolutely that I am here, and absolutely everyone here in our studio audience from beautiful downtown Columbus is most definitely welcome to be here. And all of you from the YouTube world is most welcome to be here. We have a very special opportunity to review all of the distros that would answer my emails, quite frankly. And a fury in the past couple weeks leading up to this event. Let's just do a review of what makes each distro great to show what would happen in an open source sort of environment where we're not trying to be competitive here, but what sort of distros would we used to install back in the days of those early user groups? You would have install fests at your user groups, right?
Yeah, we did. We had install fests at colleges and libraries. We had a college bookstore that let us host there. My favorite place where we had meetings and events was at the Illinois State Museum Research and Collection Center. We saw some really cool stuff there. But everybody would come lugging in. I mean, it's a little bit different than it is now. They'd have the full tower cases. You didn't dare put the chassis on because your hard drives were going to overheat. They're all nice and bent to handle shape on top. I think they're a footstool somewhere there. The 40-pound CRTs. So you got tons of exercise at those events. But it was all over age ranges. We've had people that were coming in with their kids that we now have gotten to follow for a better part of 30 years that have full careers in IT. We got to watch them with their first installs. You know, everybody got together fighting. They couldn't get on the network. They couldn't get audio. Their modems, oh crap, that's a Win modem. Yeah, yeah, from one end of the gamut to the other. They were powwowing and solving troubleshooting issues, planning work projects, and it would happen at all these events.
I have a confession to make. The first distro that I successfully installed was Caldera Open Linux. These were the people who got kind of bitter about things and turned into SCO and started spreading all sorts of fun. And if you don't know what I'm talking about, oh dear child. We really stuck together as a community because there were plenty of other options in the sea of distros, and every single year it felt like this was going to be the year. This was going to be the year of the Linux desktop. The reason why I chose Open Linux is because it was in the back of a book that said, learn Linux in 24 hours, and I was really excited to learn it really fast. We have a thumbs up from the audience who apparently had that experience too. How about you, Kara? What was your first experience?
Oh, I had a little help. Though my install was kind of fun. I did have a dual boot setup. And my first install of Red Hat 4 something in '96 was dual booting off of a SCSI hard drive, daisy chained off my SCSI controller on my sound card, hanging out the side of my 486 box. Yeah, so I was booting that fairly early. My first exposure to a VI in that day. I thought I broke things. I may have cried. I did cry. He laughs. Yeah, I did. But yeah, so it would have been Red Hat 4.
Well, I'm sorry, very sorry that this is not the Red Hat 4, but this is the Red Hat 5 user's guide. So if you will promise me to not cry, at least for the duration of this presentation, I will give you this manual.
Very cool.
Outstanding, outstanding. And that was what year?
I would have been in 90. I would have been in 96. Was Windows free in late 97, but I did spend a little over a year dual booting.
Wow, that's amazing. It didn't even come into something that I felt that I could do until 1999. But as I look into the audience, is there anyone here who wasn't even born in 1999? Yes, yes, ma'am. Thank you. And yes, absolutely. We've come a long way as a community and as a Linux festival, and now as an open Libra free conference. What are your memories of Ohio Linux Fest? I know you've come back time and time again.
I think this is probably my 10th one. And if somebody could go through the database and find out how many times my husband's been here, we keep arguing if it's 15 or 16. As long as you agree with me, come back and let me know on that one. So for a good long time. But it's just been kind of fascinating thinking about where the community started. And, we like to say it takes a village. And I know depending on who you ask, you can think somebody from the Linux family thought they wrote that, but it pre-existed us. But we prove it over and over and over again. I did have some pictures and stuff we were going to show off what the difference is with with everybody huddled around. They're great big giant 19-inch CRTs figuring these things out. And then they would hang out all night, and then they would go home and they would get on IRC and Slashdot and whatever else, and then they would keep going. And if you think about it, that's not too different than what it is now.
For the dear children in the audience, this was before containers. We had to put our own desktops at risk to try a new distro. There was no VirtualBox. You had to go in for a deep dive and say, I'm going to try this because I believe in free software.
Yeah, I always like to kind of put out there, because what has changed is a lot of people have gone remote. We sit there on meetings with our cat in our lap. We maybe can throw our laptops on our back and go to a favorite beer hall and find a couple of friends to talk to. But as things have changed, our community has gotten bigger because they've gone all virtual. Getting back in person, especially after things have been kind of weird for the last few years, and you could leave feeling so refreshed, you got all these connections again, you get all super excited, and you think about the next one and you wonder, do I have the mental energy to people that much? And I'd like to remind you, when you think that's how exhausting that is, you're not carrying a 40-pound CRT.
So, in honor of all of this spirit, we've decided to bring virtually to you an install fest of sorts, where you'll be able to take a little nibble and enjoy hearing what is great about each of the distributions who would answer my emails in the fury of leaving up to this event in the past couple weeks. We have several brave souls who've accepted the challenge of answering the question, what is great about your distro? You have one slide, actually you have 0 slides because of how it panned out. You have 5 minutes to go ahead and tell us everything that is wonderful about your distro. And then you will hand the microphone back to Kara. If you extend your time, then I will tackle you and you will not have the microphone anymore. Do we accept the rules? Yes. I am seeing a thumbs up from the front row. We will go in a certain order decided by me as the executive and president of the Ohio Linux Fest Corporation. We will very quickly have Alma Linux represented by Veni Vasquez, who is the chair of the board of the Alma Linux OS Foundation. We will have CentOS being represented by Sean McCants of the CentOS community manager. We will have Fedora represented by Ben Cotton of the Fedora program manager. And we will have SUSE represented by Robert Sayatra of the SUSE head of community, and Rocky Linux represented by a project contributor of Rich Alloway. So the first brave soul to come up to the stage would be, yes, you. Yes, you.
Yes, me.
Benny Vasquez.
Yes, me.
For Alma Linux. What's great about your distro?
Everything? Everything's the answer we all have, right? Yeah, I'm pretty sure. So, if you haven't heard, Alma Linux is one of the new kids on the street. We are just about 2 years old. We are a downstream repack of Red Hat, kind of like historical CentOS Linux. We are a huge community with lots of amazing human beings. We, from my perspective, one of the most exciting things is that because we are completely controlled by our community, everything that we're doing is something that somebody needs. So we have support for 4 different architectures. We've got all kinds of, oh, my slide's not up there. You don't get to see it. Ha ha. But we have ARM64 support, we have obviously x64 support, PowerPC, and S390, and it is so exciting to be part of a community that's so engaged and so excited about what they're doing. You can find me later out there. I know we're short on time, so I'm going to cut it there, but come by and I'll tell you about all of the exciting things we're doing that was on the slide.
Switch your video output to mirror, they'll get your slides.
We're optimistic that we will have slides. No? Maybe? Benny, would you like a second chance?
No, I'm fine.
For those who do not hear her in the mic, she's like, yeah, I'm good. I'm sitting down and it's almost happy hour. So, yeah. All right. Next up, we have Sean with CentOS. Sean? Tell us what's great.
Hi. Hey, oh, the slides are gone. The slide is literally a little piece of paper, a little cardboard on my on the booth out there, so you can come and check it out. So, CentOS Linux is a continually updating a distribution that tracks just ahead of Red Hat Enterprise Linux. What? I'm getting hecklers already. So CentOS Linux is continually updating. It gets packages before you get them in the next minor version of RHEL. CentOS Stream, I'm sorry. Yes, I can't talk about the project in general. You guys are messing me up. So it does have the major version. CentOS Stream 8 is not the same thing as CentOS Stream 9. It's not continually rolling like a Fedora Rawhide or an OpenSUSE Tumbleweed. But it's always getting the next minor version, the updates that'll go into the next minor version of RHEL. These are all, stable updates that you've seen, usually in Fedora and stuff already. And sometimes those are also backports of stuff depending on the engineering on it. And oh, I put 5 hours on my clock. Cool. I got 5 hours.
You took responsibility for it, Sean.
Anyway, so so that's CentOS Stream, and some of the reasons you would care about it are, first of all, most importantly, it's actually how you get anything done in whether you're running CentOS Stream or you're running RHEL or you're running a RHEL derivative. The process for changing what's in Red Hat Enterprise Linux and the rest of the entire family there is to do it within CentOS Stream. So it's a way for the community to actually contribute and help develop RHEL and everything in that family. It's also, it's a very RHEL-like operating system. The difference between RHEL and CentOS Stream is actually very small, and it's getting the updates just a little bit faster for them RHEL. So if you don't actually need to be pinned to one of those individual versions, CentOS Stream works really well. It's really good for integrators, testers, people who are building software that's intended to be on top of CentOS Stream or on top of RHEL, on top of anything else, is you're getting the opportunity to actually test and do stuff before the next version of RHEL comes out. And we also, aside from CentOS Stream, we're a host for a number of really cool special interest groups that build really cool stuff on top of CentOS Stream. Thanks.
Ben, you seem rather eager to get up here and represent Fedora.
I'm rather eager to get to the happy hour. So I represent the Fedora project. I'm the program manager, chief cat herding officer. The great thing about Fedora is it's sponsored by Red Hat, but it's the community's distribution. Red Hat pays me to work full time in Fedora, pays a few other people, but so much of what happens in Fedora is you doing the work that you think needs to be done. Fedora as a project really has, strong belief in working with upstreams and really integrating upstream releases as they come out. First is one of our 4 foundations because we want to be the first to really deliver that upstream experience. We also focus on freedom. Anything that ships in Fedora Linux is free software. You will, except for a few binary blobs for firmware, but we're not going to ship software that isn't open source, isn't free software. Friends is the biggest one. That's the community. I was a Fedora contributor for a decade before I started working at Red Hat, and I stayed and I slowly started doing more and more work because the community is awesome. I love being around our community, and I love to talk to people who are using Fedora and helping them become contributors. And then features. One of the things I've talked about in the past is that operating systems are boring, and that's really good. We want them to be boring so people can use them. But there are things that we can do to advance the operating system, even though most people don't have to care about it day to day. Things like RPM OS tree for basically immutable operating systems in the desktop and server space. So Fedora project produces Fedora Linux every 6 months. It's got about a 13-month release cycle. We have a wide variety of different variants. There's a workstation variant, server, cloud, different technologies, different use cases that whatever you want to do. And if there's something that we're not producing that you want, you can come in and do it, and it's a first-class citizen along with everything else.
I think it's Mr. Sertia's time.
Yes, yes. And I have special party gifts for you, sir.
Oh my goodness. Are you serious?
Yes.
For me? Did you see this? I'm getting this. Are you going to take this home?
It is the SUSE Linux 7.0 Professional with 1,800 applications.
I don't even know what to say. Thank you. I might have to try to. I have to find a machine that actually has a DVD-ROM or CD-ROM. I don't know if I own one.
Well, you know you're going to need these floppies too.
Oh, I'm like, what am I going to do with this? Oh. Well, I don't know how much time I have, but can I start? May I?
Well,
after this beautiful
you
gift.
know that you're going to need this configuration guide.
Well, thank you, Beth. It'll go in my pocket. Well, thank you. My name is Robert Sertia. I'm the head of community evangelism for SUSE, and
You know what? It's hard to say this, but it's about the community. That's really where I would start with it. And for us, we have distributions of Linux that meet any need. For continuous updates with Tumbleweed, if you're daring and you want to do that on a desktop, don't ever do it on a server. It is one of the best for your desktop. My desktop runs it. It updates continuously, and I don't worry about it. We also have Leap, and this is akin to the classic way we do things for a great server version, right? And I love that. And if you need a micro OS or a immutable operating system all based on SLES, you have it right there. And when you're building something or you're designing something and you go, I want to take this to work and I want to do this at work, we give you an option to do that. And you can start it in OpenSUSE and flip it over to SLES with just a key. There's no redoing anything. And if you think about it, that gives people the freedom to try and do something and prove it works, and then take it to work. And when their boss goes, hey, I need someone to support it, call those guys. But it works. And that's one of the things. And so when I think about that, that's what we offer to that community. What is your need? Is it a continuously updating operating system? We have it. But when I said community, and not only because I'm part of the community, and I don't run a community, you don't manage a community, you contain a community, right? Like, 'cause I've learned that. Like, you don't tell a community what to do. They tell you. What, really? Was it 5 minutes? Wow. All right. Well, I'm going to let it go because I know everyone here wants to go to happy hour. Beth, thank you. I don't even know what to do with all this.
Fantastic. Great job. So, Robert from Susie. Last but not least, we have Rich Alloway to represent Rocky Linux. Rich.
Now, see, you had to look down to see what my name was, because these guys, you all know them. They're all famous.
Where have you been, man?
I've been working on the inside, the closed source side of open source, where the company uses open source and they don't want you releasing the stuff because you're not selling it to anybody. It's only used internally. Anyway, I'll start off with a little intro on myself. So I'm Rich Alloway. I'm the lead for enterprise Linux development and support at OpenLogic. And I'm also a testing team member for Rocky Linux, which is why I have the honor of speaking to you today. I've been working with Linux professionally for about 28 years and started a little bit before that Slackware, somewhere around 1.0. I know it was a pre-1.0 kernel, they're growing pains. So I'm here to represent Rocky, so let's talk about Rocky. Where did Rocky come from? Well, I'm not going to start off with, first the Earth cooled and the dinosaurs came. We're not going to go that far back. We're going to fast forward a little bit. We're going to go to the 90s, where Red Hat Linux was introduced. And Red Hat Linux was pretty popular. I think we all have heard of Red Hat, I would hope. And a couple years later, Red Hat Linux gave way to Red Hat Enterprise Linux. And a couple years later, that was about 20 years ago. And then a couple years later, in 2004, CentOS Linux came out. And then December 2020, Red Hat announced their intention to retire CentOS Linux for CentOS Stream. And a lot of us felt that might leave a void. And so Rocky Linux, along with some other distributions, came out of that void to fill it. So Rocky Linux is a community-driven enterprise distribution designed to be 100% bug-for-bug compatible with Red Hat Enterprise Linux. We rely on the upstream people. The Rocky Enterprise Software Foundation was created to oversee Rocky Linux and possible future projects as well. The charter and bylaws for RESF were just ratified last month, and those charters and bylaws were to enforce that Rocky and RESF are community projects striving for transparency. Best way to see that transparency is to join our community. Go to the Rocky Linux chat server. That's where most of our community interaction happens. That's where our teams meet. That's where our SIGs meet and where contributions are discussed. And the level of participation is completely up to you. You can just sit there and you can just watch what's going on and just learn. You could ask questions and learn that way, or you can volunteer and become part of our growing community. What makes Rocky Linux great? Getting down to the point here. So I'm going to start with our build system, Peridot. It's a custom cloud-based open source build system. And it brings the magic of building an enterprise Linux distribution out from behind the curtain. So anybody can stand it up and basically replicate the builds that Rocky is creating. It natively supports modules and software collections, handles importing of packages, debranding, things of that nature. And beyond the technical benefits, Peridot also builds trust with the community by providing transparency into our build systems. We have special interest groups. The teams responsible for Rocky are special interest groups, but then we also have several other SIGs that exist to extend Rocky Linux beyond the core offering. If you're security minded, you might be wondering, what does Rocky Linux offer to me? Well, the Rocky Linux security team is working to obtain various certifications. Right now, thanks to a $1 million sponsorship by CIQ, the Rocky Linux security team is working to get Rocky Linux FIPS 140-3 certified, and we're scheduled to go into government lab testing in January. So that's a pretty big step for us. You might be wondering about release stability with such a a new distribution. Obviously, we're reliant on the upstream RHEL. Did I mention bug compliant or compatible? We also have a quality assurance team. So we have a testing team who works closely with our release engineering team and infrastructure team, like Neil here. And we work together to validate that we are that bug compatible. And we don't release something until it's right. We got manual testing and automated testing with each release. We improve our testing processes. We add more tests. We automate some of the manual tests. So there's continuous improvement there. And anybody who thinks that free software is free, it's not exactly free. Somebody has to be paying for the infrastructure, paying for the resources necessary to create, a relatively huge distribution. All of these enterprise Linux distributions are humongous undertakings. So we get support directly from many organizations, including the big 3 cloud providers. So AWS, Azure, Google Cloud, all provide us with resources. And then there's commercial OS support available from companies like OpenLogic. Rocky is also easy to try. We've got the varied ISOs for installation. We've got container images, public and private cloud images, and if you have a system that you want to migrate to Rocky, we have an aptly named Migrate to Rocky tool to help you with that. So basically, in summary, if you're considering Rocky Linux, you can be assured of an active and growing community, as well as the confidence in a quality enterprise Linux distribution.
Fantastic. And I would like to welcome Sarah from OpenLogic up to the stage to talk to us a little bit about embracing all distributions. No matter what distribution you use, whatever operating system you use, it's always been part of the Ohio Linux Fest values that you are welcome here. So how does OpenLogic feel about all these distributions?
Yeah, so let's be honest. The reason I'm up here is we get to invite you all to the happy hour. But thank you. First of all, I want to just say Open Logic, we support community open source at an enterprise grade level. So that's basically what we do. First of all, I want to just say it's really great to be part of an event here today that parallels with that tool agnostic. So great panel. Can everyone just give a round of applause to our wonderful panel we had tonight? Yeah, thanks. So
Open source, open source.
So one of the things that I'm finding as people have been coming around and talking with me this afternoon was, who the heck is Open Logic? And what do you guys do anyway? So as I mentioned, Open Logic is part of Perforce software, and we support all community-based open source. So to be part of this with part of a group that aligns with that philosophy is really, really great, and I'm really happy to be here. Javier Perez is our chief open source evangelist. He couldn't be here today, but he does have a message for all of us. So we're going to play a quick video here about our upcoming State of Open Source report.
Hello, Ohio Linux Fest. My name is Javier Perez, Chief Evangelist at Open Logic by Perforce. Wanted to let you know that this year, again, in collaboration with the Open Source Initiative, we ran a very successful global survey about the state of open source software. We're doing the analysis and we'll be releasing a comprehensive report in January, followed by webinars and more content. The 2023 State of Open Source, it's about the use and adoption and support challenges of open source across all industries. We're also going to learn about the latest technologies and the level of maturity within organizations. So stay tuned for the 2023 State of Open Source report.
So last year, this report was close to 80 pages. We're going to try and pare that down a little bit, make it a little more digestible this year.
Thank you.
Yeah, you're welcome. You're welcome. I did want to make sure to let you know that we do have an opportunity for that webinar to have. You guys are going to be the first people to be able to register and sign up for that webinar happening in February. The report is free. So if you want to download the 2022 report, talk to me. But yeah, I think everyone's probably, who's thirsty? Anyone thirsty?
It's taco o'clock, folks.
It's taco o'clock. I'm from the Midwest, and so I give directions by landmark. So we're going to go out the door. If you want to see me at my table, I'm closest to the bar. At least I've been told that. So thank you again for spending this weekend with us here at the Ohio Linux Fest.
Fantastic. Thank you, all of you. We are so honored that you could all be here. And for those of us tuning in at home, we will see you tomorrow, bright and early at 9 o'clock with Ms. Anna Grainer talking about what it really means to be a technical guru when your technical guru is somebody else's guru, somebody else's guru, somebody else's guru. Down until, yes, even my grandmother, who was scared of a computer mouse because she thought that it was trying to catch her, is somebody's technical guru. Thanks, everyone.
you.